Good morning, and welcome to the FCC's Forum on Open Radio Access Networks. This event originally was scheduled for March, but I hope and expect it will be worth the wait. Thank you all for joining us, especially our conference participants. We have quite a lineup. Among those speaking, all 5 FCC commissioners, experts representing world-leading technology companies and upstart firms, top talent from the Academy, Commerce Department Director of Policy and Strategic Planning, Robert Blair, former ranking member of the House Intelligence Committee, Jane Harman, who now leads the Wilson Center, and for the first time I'm aware of, the U.S. Secretary of State is participating in an official FCC event. Now, usually the FCC could only get a turnout like this by offering free food. Clearly, that's not happening here. So what's the big deal? Well, the big deal is 5G. These next generation wireless networks will be embedded in almost every aspect of our society and economy, from businesses to homes, hospitals to transportation networks, manufacturing to the power grid. Over the past few years, the FCC has aggressively executed our 5G FAST plan. This strategy features 3 key parts: freeing up spectrum for the commercial marketplace, promoting wireless infrastructure, and encouraging fiber deployment. Now, this strategy has yielded big results. For example, we've already completed multiple spectrum auctions that have repurposed huge swaths of spectrum for 5G. And we've seen record-breaking capital investments in infrastructure essential for next-generation networks. But our focus isn't limited to promoting networks that are strong. We're also committed to making sure that they are secure. For years, U.S. government officials have expressed concern about the national security threats posed by certain foreign communications equipment providers. To address this concern, we've aimed to protect the integrity of the communications supply chain, that is, the process by which products and services are manufactured, distributed, sold, and ultimately integrated into our communications networks. And specifically, the FCC has prohibited the use of money from our Universal Service Fund to purchase or obtain any equipment or services produced or provided by companies that the FCC determines pose a national security threat, namely Huawei and ZTE. We've also started a process to identify and catalog insecure equipment used in USF-funded communications networks so that we can hopefully implement a program to remove and replace it once Congress appropriates funds for this purpose. Now, looking to the next generation of wireless technology, much of the equipment at the heart of 5G networks currently comes from just a few global suppliers. 3 of the most prominent are Sweden's Ericsson, Finland's Nokia, and South Korea's Samsung, but the largest of them is the Chinese company Huawei. Carriers building out 5G networks rightfully worry that Huawei equipment could expose them to security risks. Huawei's market power, aided by generous subsidies from the Chinese Communist Party, often might seem to make that company the cheapest and thus best option for network equipment. But the Chinese national intelligence law requires companies like Huawei to cooperate with and keep secret state intelligence work. The law also creates opportunities for Chinese intelligence agencies to compel access to an organization's facilities, including communications equipment in certain cases. In short, many are recognizing that you get what you pay for, and that the long-term costs of using insecure equipment are likely to outweigh any short-term savings. In addition to these security issues, carriers may be concerned by relatively consolidated marketplace. Some have told me, both here and abroad, that vendor diversity is useful in terms of price competition, avoiding the lock-in problem, and ensuring a backup supplier, among other things. Well, technological innovation has opened up a new path to address these concerns, and that technology is the subject of today's forum, Open Radio Access Networks, or Open RANs. Open RANs could transform 5G network architecture, costs, and security. Traditionally, wireless networks rely on a closed architecture in which a single vendor supplies many or all the components between the network base stations and the core. But Open RANs can fundamentally disrupt this marketplace. We could see an exponential growth in the number and diversity of suppliers. We could see more cost-effective solutions. And critically, we could see the keys to security in the hands of network operators, as opposed to a Chinese vendor. All this might explain why some telecom companies are beginning to develop and deploy open, interoperable, standard-based, and virtualized radio access networks. Now, as an added bonus, many of the leading firms in the Open RAN space are based here in the United States or in countries generally aligned with our vision of 5G security. How this marketplace will evolve is hard to predict with certainty, but here's what I can say with confidence. Innovation and competition make for a stronger, healthier telecom ecosystem. That's why so many are excited about Open RAN's potential. And that's why this forum is so timely. We want to encourage research and development into innovative network solutions. One way to do that is by convening the top experts in the field to discuss the benefits of Open RAN, the challenges of implementing it, and the lessons learned from deployments thus far. That's exactly our task today. And so I'm grateful for our impressive roster of public and private sector experts for taking the time to discuss with us the current state of Open RAN related technologies and the path ahead. Now, before I relinquish the floor, I want to thank the FCC staff who helped make this event possible. Among the 31 staffers who brought us from concept to concrete, Ken Baker, Connie Diaz, Kamran Etimad, Monisha Ghosh, Charles Matthias, Robert Pavlik, Les Platt, Michael Smith, Cecilia Sulhoff, Becky Tangren, Janet Young, and Marasha Younger from our bureaus, Evan Swarstraber in particular, and Sean Spivey from my office, and as always, Jeff Reardon and the Commission's AV team. With that, it is my honor to present this important message from the United States Secretary of State, a distinguished Kansan, and my friend, Mike Pompeo.
Hello, everyone. Secretary Pompeo here. I first want to thank Chairman Pai, a fellow Kansan, for inviting me to speak. As Secretary of State, I've spent a lot of time addressing the China challenge. The Chinese Communist Party is leveraging its technological prowess to erode freedom and democracy here at home, indeed all around the world. That's why the United States has called on our allies and partners in government and industry to help us protect our people's freedoms and data from the CCP. I'm very pleased to say that a growing wave of countries and companies have banned Huawei and chosen clean vendors for their 5G networks. Now it's about 30 countries that are clean countries, and many of them are the world's biggest telecommunications companies and nations. They're using technology that makes them clean telcos. We've also rolled out the Clean Network, a coalition of like-minded countries and companies committed to protecting user privacy and cybersecurity from malign actors. The Clean Network maximizes connectivity without risk from untrusted vendors and stops the CCP censorship of Americans. I hope today that each of you will determine how you or your company can join or support the Clean Network as well. On a similar note, I support the FCC and Chairman Pai's strong efforts to free as much possible spectrum for 5G as possible, and to do so as quickly as possible. I hope that each of you will do that too, because when Americans can compete and innovate, we will win. Freeing spectrum will drive a fast build out of our own 5G networks, and freeing spectrum will stimulate innovation that will drive economic growth and push 5G technology into everything from manufacturing floors to telemedicine to autonomous vehicles. And it's critical. It's critical for our national security and that of other countries. We want our friends to choose trusted 5G vendors for their network needs, not vendors tied to the Chinese Communist Party. Look, the world doesn't want China's communists hacking into self-driving cars or their home appliances or their medical tools. If innovators can integrate open networks and deliver the best network edge solutions, we'll help citizens all around the world avoid these very threats. But we need to be open, the spectrum needs to be open, and we need to do each of these things if we're going to achieve any of these goals. Look, it's very simple. Technology must advance freedom. That's what we believe in the Trump administration, and we hope you'll join us in these efforts. Thank you again for having me. Good luck.
My thanks to the Secretary for those remarks. And now we are honored to hear from Mr. Rob Blair, who works at the Commerce Department as the Director of Policy and Strategic Planning. I've seen him hard at work on these issues both here and abroad, and I'm glad he's able to participate in today's forum. Mr. Blair, the floor is yours.
Thank you, Jeet. Can you hear me?
I can, yes.
Very good. First, I wanted to say thank you for the invitation to speak today. You and your staff have been a pleasure to work with, and I know all the work that went into making this event happen. This is a critical time for us to get together and talk about this issue, and I'm very much looking forward to discussing ORAN a bit. And as you well know, I think it's going to be a key part in building a more secure, democratic, and diverse telecommunication system. Your comments were perfect opening up this session. They're a great introduction to the situation we find ourselves in, and truly the promise of ORAN and a more diverse telecommunication ecosystem. But before I turn to ORAN, I want to note at a very high level some of the work that the Department of Commerce is doing to support the national strategy to secure 5G. The administration, all of us, continue to strongly defend our nation's economic and national security. One big focus of that effort is securing our telecommunication system. Back in March, the president signed the National Strategy to Secure 5G, which I think is an incredible achievement. And the Department of Commerce has been leading or supporting a number of work streams within this national strategy. I'm not going to have time this morning to go through all of our work on this front, but I want to highlight just a few key points. First, NIST, our National Institute of Standards and Technology, is increasing its focus and investment on advanced communications. It's identifying security gaps in the communications equipment supply chain, and it's coordinating participation in many of our standards development activities. Our International Trade Administration is developing a strategic framework for promoting U.S. 5G tech companies around the globe, working closely with our colleagues at the State Department and working with our trading partners to achieve the goals of our national strategy. And NTIA, our National Telecommunications and Information Administration, is working to make more spectrum available for 5G networks. It's also launched a program to share information about supply chain risks with industry partners, and this will be a key point when establishing clean paths overseas and clean networks overseas, as Secretary Pompeo just alluded to. NTIA is also working with international and private sector partners to develop principles for promoting a vibrant and diverse 5G ecosystem, which I'll return to in a moment. Now, I want to turn to the challenge we face, our vision for a more secure and prosperous future, and our plan to achieve that vision, working in coordination and always cooperation with our private sector partners. The current situation presents our nation and frankly most of the world with a serious challenge. There's only a few companies at this point building 5G networking equipment. Some of those companies are subject, as we've discussed, to the control of authoritarian governments that, among other things, are not governed by the rule of law, do not have independent judiciaries, and have no respect for personal privacy protections. In fact, some of these governments use our very freedoms against us. This situation is bad for countries, it's bad for companies, and it's bad for citizens. It's bad for countries because they cannot build strong societies when they have untrustworthy and insecure telecommunications infrastructure. It's bad for companies because the natural monopolies held by incumbents have such high barriers to entry that new, more innovative companies are not able to break into the marketplace and provide better, less expensive products and services. And finally, the situation is bad for American citizens and indeed citizens around the world who cannot enjoy the fruits of new, innovative products and services that never reach the market, and risk having limited or needlessly expensive access to 5G networks that even then would continue to be insecure and untrustworthy. So given these challenges, we have a vision within the United States government of harnessing the potential of 5G to increase prosperity while simultaneously increasing our economic and national security. This vision includes a couple points. One, improving our and our allies' economic and national security by building our future telecom systems without any untrusted vendors. And secondly, harnessing the power of a well-functioning market to support innovation that improves the function of these 5G systems, but also delivers new and better products and services that improve the lives of people around the world. The outcome will be more secure networks, and it'll be markets that reward innovation and provide higher quality, lower cost products and services to companies and to consumers. So the real question at this point is, how are we going to achieve this vision? As part of the national strategy to secure 5G I mentioned a moment ago, the administration, the Department of Commerce, and specifically NTIA, are focused on promoting vendor diversity. By increasing vendor diversity, we can reduce or eliminate reliance on untrusted vendors, and we can increase competition in this important marketplace. Based on stakeholder feedback we've received over the last several months, we know industry is eager to build and deploy open and interoperable 5G networks. We at the department understand that the move toward open architectures can and should be industry-led, but the government has to help. One way we're helping is working with like-minded governments to identify ways to collaborate on RDT&E. A second way that we're working on is to build off the success of the Prague proposals by exploring the development of principles for open and interoperable networks. These principles could identify further ways to foster vendor diversity and infrastructure resiliency, as well as to ensure open and competitive markets. They could drive rapid innovation, collaborative design, and interoperability, and they could facilitate the transition from our current situation and the challenges it presents to open networks and their benefits to consumers, countries, and companies. So with, with that, if I could ask everybody to mute their lines, I'm getting some feedback. And I'd like to thank everybody for all of your work and your attention on this critically important issue. This is one of the great challenges and opportunities for virtual conferencing, and I think we're working through some of the kinks sometimes. But we have a chance right now to build a telecommunications system that will help protect the very principles of freedom and openness that this country was founded upon. And I'm looking forward to continuing our partnership with the FCC, with the rest of the administration, because we really are at a seminal point in the development of these processes. Ajit is a great leader in this, and it's always a pleasure to work with him. Back to you, Ajit.
Hey, thanks so much, Rob, for rolling with the punches and for those very insightful remarks. It's been an honor to work alongside you here and abroad, as I mentioned. Now it is my pleasure to introduce a good friend to those in the technological innovation space, the Honorable Jane Harman. As I mentioned, the former ranking member of the House Intelligence Committee, the leader of the Wilson Center, and most stirringly to me, just a dedicated public servant who's dived into these issues for a long time and has worked on a bipartisan basis to advance the public interest. Madam Congresswoman, the floor is yours.
Ajit, thank you very much. I appreciate that introduction, and I also appreciate I guess it's 20 minutes of remote learning that I have just done on this very complicated and fascinating topic. I'm Jane Harman, recovering politician, think tank CEO, and digital adapter. Let me salute you, Ajit, for your leadership at the FCC, for your friendship, and for your bravery in inviting this grandmother of 8 to address a hot tech topic. I hope my grandchildren think I'm really cool by doing this. Anyway, even as a digital adapter, I'm not a total novice on 5G, the Open RAN concept, or even on the work of the FCC. I can even remember when 3G and 4G were just joining the alphabet. My congressional district, as some of you may know, was the satellite producing center of the universe in Los Angeles, just south of Santa Monica. So understanding communication satellites was a necessity. And oh, by the way, serving on the Intelligence Committee was too. And I was very proud to serve there for 8 years of my 400 years in the United States Congress. As a member of the House Intelligence and Commerce Committee, where Mike Pompeo and I overlapped for 1 month before I left to run the bipartisan oasis of the Wilson Center, my colleagues and I worked to improve radio interoperability after 9/11 for first responders. And by the way, at the Wilson Center, our Science, Technology, and Innovation program has just developed a microsite with deep dive interactives and briefs on key 5G policy challenges, both security and economic. Check it out at 5g.wilsoncenter.org. I'm not kidding. There'll be a test at the end of my remarks, so you better take a look. So here are some observations from my experience in Congress and from conversations with the many geniuses at the Wilson Center. First, and you've heard this from the other speakers, the U.S. Should be properly proud of our history of innovation, especially in technology. We sequenced the human genome, and today most anyone can access that technology for a few $100s. We haven't always been and haven't needed to be, let me underscore that, haven't needed to be first movers. Europe beat us at inventing the jet engine, but America was able to eventually lead the industry through efficient production and distribution, which is why the word race in the context of 5G isn't very helpful. The question is not who is winning, but how we can put ourselves in the best possible position to take advantage of current and future economic benefits while addressing security concerns. I totally agree with Secretary Pompeo, associated with this 5th generation of cellular networks. We have major advantages: the world's best academic training, significant sources of funding and industry, well-versed in research, development, production, and distribution. Second, it's boring to talk about setting standards. They matter. Firms need an industry standard so they are not at competitive disadvantage. Plus, if we aren't setting the standards, someone else is. We were traditionally the leaders in sitting in the front row of all the standard setting meetings, and now we aren't. That's a big disadvantage, which will only get bigger if we don't change course. Third, policymakers need to think outside the box. That's why the FCC is hosting today's session on Open RAN. I first saw a data center or VPOD built in the cloud. I actually did this on a study trip with congressional staff to the West Coast 3 years ago. I have some serious privacy issues, I do, with AI voice assistants, but was astounded to see one take a command and watch the code built in front of me. Even my grandchildren can't do that. I admit I didn't really know what I was watching at the time, but later it became an aha moment. The Open RAN concept isn't that different. Rather than needing hardware, we can take advantage of software, as many said before me, to do many of the things we used to need screws and motherboards to do. In some cases, software is better. And we in the West do software very, very well. In addition, the Open RAN moves 5G away from proprietary systems dominated by a handful of companies to a diversity of hardware and software players. Put simply, it allows carriers to shop around and then plug and play. While some worry that more software means more problems, others suggest that open networks will mean more eyeballs where it counts. I've always found that more eyes and more brain cells are better. It also means that we even the competitive playing field and give more startups a chance to create the next disruptive innovation we never expected. Fourth and finally, the elephant in the room, and Mike Pompeo mentioned it, China. Our discussions over Open RAN should not only be dominated by concerns over Chinese companies such as Huawei and ZTE. Its benefits are far broader. Open RAN isn't a geopolitical silver bullet. It's only one part of a broader set of steps necessary to shape a robust and secure telecommunications ecosystem. And there's more to do. But in our discussion of Open RAN and in future conversations, we can and we should dig deep into the logistical and technological weeds. We have to answer questions about integration and roles and responsibilities across a diverse network of players. We will also need to figure out, and I think this is a big part of today, how to help U.S. companies enter the market that Open RAN makes possible. In short, Open RAN is not the end of the 5G conversation, but it's a great beginning. It's a huge opportunity for the U.S. and the West. Let's seize it. Thank you very much.
Well, thank you so much, Jane, for taking the time. And I suspect you're going to be teaching your grandkids a fair bit more than you're letting on. I really appreciate your willingness to participate today and look forward to executing on your vision of a more prosperous, more secure future. Now it is my pleasure to turn to a friend to all of the commission, Commissioner Jeffrey Starks.
Well, thank you, Mr. Chairman, and thank you for organizing this important discussion. As many of those gathered here today may recall, the United States was once a worldwide leader in the telecom network hardware. Companies like Lucent and Motorola led the world in the design and manufacture of telecom equipment, and from radio antennas to the core. Unfortunately, that American leadership in this market has disappeared over time. And while many factors were at work, American telecom carriers were eventually left without a reasonable domestic option. And the timing could not have been worse, as the Chinese government's Made in China 2025 strategy decisively tilted the playing field in favor of its own telecom equipment manufacturers. And so Chinese governments supported artificially and lowered Huawei and ZTE's prices, assisted in their research and product development, and undercut international competition. This was not free market competition, but part of a strategy to leverage economic power into geopolitical dominance. And throughout this unfair advantage, the equipment produced by these companies has become pervasive around the world and even reaches U.S. networks. This is not just economic gamesmanship. According to our intelligence agencies, in exchange for this subsidization, Chinese corporations have siphoned data, allowed backdoor access to state agencies, enabled functionality for our networks disruption. And as a result, the technological foundation of our communication networks has been weaponized. Congress and the FCC have recognized the problem of untrustworthy equipment in U.S. networks and are working to ensure its removal and replacement. Open RAN networks are part of that solution. Almost exactly a year ago today, I published an op-ed advocating for the development and use of software-enabled virtualized 5G infrastructure to replace suspect equipment. Our country has long been a technology leader in software and wireless technology. Growing our capability to make secure infrastructure makes sense from both a security and economic standpoint. And so we need to invest in this technology. And we must do some deep and proactive thinking on the best policies to effectuate our goals of promoting secure telecommunication networks that benefit our shared future and get the best value for the American taxpayer, where we need to rip and replace insecure Chinese equipment. So here's a new idea. I recommend that we explore that each rip and replace carrier rebuilding its network be required to consider solutions offered by an O-RAN provider. That would achieve many of our goals, including encouraging global competition with Huawei, capitalizing on U.S. software advantages, accelerating the development of O-RAN both as a product and as a business case, and allowing for alternative vendors to enter the market and offer specific network solutions. While no carrier should be forced to adopt it, it would encourage carriers to consider a technology that might otherwise have been overlooked. O-RAN holds tremendous promise. Its growth could advance American technological leadership, enhance competition, and reduce our reliance on foreign vendors across the world, all the while bringing down replacement costs. It deserves serious consideration, and I look forward to the conversation that will happen today. Thank you, everyone.
Well, thank you very much, Commissioner, for your remarks. Look forward to working with you on this and many other issues, of course, under the FCC's bailiwick. With that, we will kick off the first panel, which is an introduction to open, interoperable, and virtualized networks. And we're starting off with a bang in terms of our panelists. We have Caroline Chan, who's the Vice President and General Manager for the 5G Infrastructure Division Network Platform Group at Intel. We've got Tarek Amin, who's the Chief Technology Officer of Rakuten Mobile. And we have Sachin Kutty, who is the VMware, who works at VMware and is also the co-chair of the O-RAN Alliance Technical Steering Committee. And last but not least, we have Thierry Maupelet, the Executive Vice President, Chief of Strategy and Product Management at Altiostar. Bienvenue, mon ami. But before we get into the panel, though, I have to issue a disclaimer for this and all subsequent panels. The presentations you're about to hear were voluntarily submitted by the presenters and are not contingent on and do not imply any expected benefits to the presenters. By hosting this conference and by providing a forum for these presentations, the FCC does not thereby endorse any device, manufacturer, vendor, or company described in the course of this conference. And with that legal requirement out of the way, I thought we'd just jump right into it with a foundational question, which I will pose first to Caroline. Let's start out by defining the topic of today's event. What is the radio access network? What is an open radio access network? And how does this O-RAN or Open RAN architecture differ from the traditional architecture? Oh, I think you're on mute, sorry.
Sorry about that. I think I was double muted. Thank you, Chairman Pai, and it gave me the opportunity to participate here. So let's start by saying what the traditional network architecture today is. It mostly consists of purpose-built solutions that based upon 3GPP standards, and it does utilize custom hardware to optimize the network functions. So these RAN solutions today, radio access network, both software and hardware are verified, integrated into an end-to-end system, typically delivered by a single vendor, as you mentioned in your opening remark. So before I go to Open RAN, let me first touch upon the virtualized RAN solution. About 10 years ago, a group of ecosystem, Intel's part of it, and we started developing RAN functions that run on software, on standard servers, like what you see today in some of the cloud and IT e-commerce. So really take advantage of the technologies like network function virtualization, NFV, software-defined network, SDN, allowing all the additional flexibilities. So then some groups, such as O-RAN Alliance, which Sachin is a co-chair, started developing interoperability testing specifications with open and interoperable interfaces within and between various subcomponents of the radio access network, and therefore referring to as Open RAN. So the journey looks like today you have several flavors. You have the traditional network still, you have the virtualized RAN, and going forward, you will have the Open RAN under the O-RAN specifications. Back to you, Chairman Pai.
Well, thank you for setting the stage for this conversation. I'll turn next to Sachin. One of the narratives that we often hear when it comes to 5G hardware is that as there isn't a US-based alternative, and some previous speakers have, of course, made that point as well. Can you discuss how O-RAN might diversify the marketplace in that regard, and how it might leverage America's traditional strength in software?
Thank you, Chairman Pai. So I think as Caroline referred, O-RAN is pushing the envelope along two dimensions. One is it is virtualizing the radio network, and the other it is opening up by specifying open interfaces. And this, I think, will really open the door for a tremendous amount of hardware innovation to come in, because by definition, when we virtualize, we are now able to run a variety of different hardware underneath and run the radio network as essentially an app, as a software on top of it. And this plays to American strengths on hardware innovation. So look at the amount of hardware innovation that's happening in cloud, in AI. There's a mushrooming of startups that's happening in the Valley now, trying to build hardware that does much better. I think the same amount of innovation will now be able to apply to the network because we can virtualize it. No one has to worry about what the underlying hardware is. The second aspect, because there are open interfaces, it means that I can now mix and match radio hardware from a variety of vendors with software from different vendors. Previously, it was very hard for a new hardware innovation to come into the market because everything was vertically integrated. And to really get your foot in the door meant that you not only had to build the hardware, but you had to build the entire software stack to get in. So the barriers to entry was so high. Now with opening up and disaggregation, you now open the door for innovative hardware to just focus on that, get that right, move the market in that place, and you will be able to get customers because they're adopting open interfaces. So I think the transformation that's happening because of virtualization, because of open interfaces between the radio hardware and the rest of the software, we will actually see an amazing growth of hardware innovation, both on the compute base station hardware as well as on the radio hardware side. That I think is a tremendous opportunity for American industry to take advantage of.
Well, it's certainly an exciting forecast for the future, one that we'd like to secure as well. And I know one of the companies in this space that has been actively doing, not just thinking, has been Rakuten. And we're pleased to have Tarek here as well. Tarek, you've shared with me both when I was in Japan and in my office in DC, your vision of the future. And I know that there was a time when Huawei was set to be the equipment vendor for Rakuten. What changed in that regard, and why did you go in a different direction?
Thank you very much, Chairman Pai, for inviting me to speak in this forum. And firstly, I want to congratulate you on a very well-executed, innovative CBRS auction. We've been watching this from Japan as well. I think to understand the present, it's important to also understand a little bit of the past. I had an opportunity in my life and career to work for a very innovative companies that wanted to change the fabric of society by disruption that they could do in connectivity. While I moved to India working for Reliance Jio, I've learned the value of $1, Chairman Pai. I mean, the average revenue per user in India was $1. I learned the importance of disaggregation. I learned the importance of having diversity in supply chain, but also the criticality of having the right component vendors. Then I met the chairman of Rakuten, as we discussed when he came visit us in Japan, and the pillars of Rakuten revolved around three big areas. The first area, I call it courage to explore. Courage to explore, which is an idea. Do we continue to build networks in the same fashion that it got built for decades. And in that context, Huawei was a choice, by the way. Huawei was, I think, almost was ready to be selected as a vendor. Or do we look in a brave world, a world in which cloud becomes part of the essence of how we think about future networks? So that is the first pillar, is the whole idea of courage to explore. To enable this, we realized quickly that the United States contain all the necessary ingredients. You just need the right, for lack of a better word, shift to put these things together. So we invited world-class leading companies. Nokia was one of them, Intel, Qualcomm, Cisco, and we decided that this willing partners could really innovate into the space. We did not want to take the risk, and our chairman and CEO decided that if there is any risk that could be had by selecting Huawei, that's something that we wouldn't want to do. I have, Chairman Pai, one slide, if you don't mind, I want to just share it to everybody. If you don't mind, can you please display that one slide? So when we put the network in play, I mean, I think in the beginning, a lot of people had many doubts about the ability of such an architecture. Can Open RAN scale? Can it really work? Can it work in dense urban areas? Is this only should be a technology that's secluded only to the periphery of network? And my belief is fundamentally, you know, I had a picture in my office, Chairman Pai, that shows the 2 rockets that SpaceX has landed on a barge. And I said, my goodness, if a human being has managed to put 2 rockets back on a moving ship, we certainly could really do an innovation around cloud technology and innovative. What you see here is a picture. What we committed to MIC, the equivalent of FCC in the US, is a build number that we have doubled. And every single site in Tokyo today is sitting as a cloud native Open RAN platform. Not only we have realized quickly the benefits and advantages of such an architecture, but we quickly realized that because of its simplicity, our ability to roll services and the agility we could deliver, I think, is unparalleled. So today, we have exceeded north of 6,700 macro base stations. We have committed that by March 2021, we will be at 70% pop coverage. We have launched fully this network April this year, and carrying double the amount of traffic that exists in Japan. But I will tell you what excites me the most is security. This is what I am so thrilled about. The security apparatus of Open RAN, I call it when you have full visibility, the possibility of what you could do on the network when you have full visibility, transparency, and transparency end to end, not just about software, transparency about where do the components come from, is really an unparalleled opportunity for the industry. And I want to commend you personally for the leadership that yourself, the United States government, are doing around this area. We are absolutely enthusiastic about the future and eager and willing to find a way to collaborate and support and create the linkage needed between Japan and the United States to advance this technology and to show that it is absolutely real. And I invited everybody to come to Tokyo, hopefully when this COVID situation is out of us. I would love now to show you the vision that we talked about being a reality now in Tokyo.
Well, thank you very much, Tarek, both for the hospitality last year, but also for your words just now. And I'll turn to Terry in a second, but I did want to focus on one of the comments that Tarek just made in terms of security. Do any of the rest of you have a thought as to the implications of ORAN for security? Do you agree with him that it is, by being open and transparent, a potentially more secure architecture?
If I may jump in there, I think Chairman Pai. So Tarek said it pretty well. And I think the other comment I'd add is open interfaces means that I can pick the best of breed solutions for each component of the network. And part of that best of breed definition is a secure component. So if you go with a vertically integrated architecture, your security model really is you trust that one vendor and they have to get it right. Here you have the ability to test, you have the ability to inspect, and you have the ability to replace when you find something's not working. And I think by definition, given the innovation that we see in the rest of the world in the cloud, how quickly things can get upgraded, bringing that same cloud flavor to the network, being able to replace and upgrade and in an agile fashion, innovate on the network, I think will ultimately lead to a more secure, more clean network than what we have today.
Terrific. Well, I did want to turn to Thierry. So one of the things I noticed from Tarek's slide, from that slide about Tokyo in particular, was the nature of their deployment. And that raises the question, we obviously have incumbent networks that are already built, and we are seeing the emergence of standalone networks being discussed or even deployed. How, in your view, does O-RAN play into whether it is a brownfield deployment or a greenfield deployment?
Good morning, Chairman Pai, and good morning, everyone. It's obviously something that we have seen in many other industries where you have innovation. You always have entrepreneurs who want to take advantage of this innovation in order to differentiate. And this has created an opportunity for such entrepreneurs as we have seen and we see in Japan with Mikitani-san, with the help of Tarek. But we see the same innovation being adopted in the US with Dish. And we expect to see the same happening in some other markets, such as Germany in Europe. So there will be a few, but the real opportunity for Open RAN is, as you mentioned, is about brownfield, meaning operators who have an existing network. And what is very interesting with Open RAN, because it's built on open interfaces, it is, in fact, it's not a technology, it's a 3GPP standard. So you can insert Open RAN, not just even for 5G, you can already take advantage of Open RAN in 4G networks. And there are different motivations to do that. And we call it, it's not either greenfield or brownfield. Any operator who has an existing network can do what we call green on brown, meaning that you can insert. And there is obviously a learning curve. I mean, it's not easy. I mean, I don't believe that even building greenfield is an easy task. But for a brownfield, I think there is also a different set of skills. So it's not just about inserting technology. It's about adopting what we have seen in, with the hyperscalers, the people who are familiar with the cloud. So it's all about DevOps, CI/CD, agility. And I think the major driver for brownfield to move forward is really because the 5G requirements are going to require that the network being flexible, being more programmable and intelligent. And this is what it does require, this new architecture. And I think there is also another motivation that we have seen and we hear from major global operators. And I will coin what has been mentioned by one of the major operators. It is a necessity. It is a necessity because you need to have not just a diverse supply chain, you need more choices, but you need a strong supply chain. So we need to change the economics of this industry. As it has been mentioned before, many companies have disappeared. So we have to make sure that as we are really at the beginning of 5G and the next G that will come after, we have a strong ecosystem. And this is where, for a brownfield operator, it's not just to take advantage of a new architecture, which is going to drive a lot of cost saving, CapEx, OpEx, the readiness for 5G or with all the use cases, but also to have access to more choices, a very strong ecosystem. And this is a promise of Open RAN.
Can I follow up on that key point in terms of green on brown or any type of deployment for some who have already built those networks? What do you see as some of the challenges to the widespread adoption of O-RAN? Is it the interoperability with the existing networks? Is it scalability? Is it just simply capital? And this is for you or anybody else who would like to comment on it. And also, as part of that, what do you see as the transition period? Is it a question of years to execute that sort of transition into a more textured network, or is there some other time frame?
So what we have seen, again, which is not really a surprise, like any innovation which has some disruption with it, there's a lot of, at the beginning, it's a lot of denial, and then there's skepticism before you see really acceptance. I think what has been helping the whole industry is the fact that Rakuten has taken such a, making very bold decision to build this network with this new ecosystem, the Open RAN, is now proven that, as Tarek just mentioned, it does work. It is fantastic technology in a very dense, challenging. Tokyo is a very, very demanding environment. So the level of confidence that we have been able to create now is helping other operators to embark on this journey. So that's, for us, what we see is a major change we have seen in the last 3-4 months, amid the COVID-19 that we are all experiencing, is in fact that many operators now are either, not just evaluating, but planning to deploy Open RAN in their network.
Chairman, maybe I could add one more thing.
Sure.
I think if you ask me what is the last 2-3 years learning experience in Rakuten, it's not a green field. It's more like green mines. So we focused a lot on the organizational fabric and the organizational structure. By the way, if you go and converse with the likes of web-scale companies in the US, Amazon, Facebook, Google, you will find the same type of caliber of talent that we focus on building such a platform and such architecture. Maybe this is a challenge. You've asked what are the challenges on scaling this? I would say skill set and organization is a challenge. And the second challenge that I would really see, and this is something I've talked to various different US agencies on, because the question was asked, what is the role of government as well that could play in enabling such disruption? And I look at the US having what a momentous opportunity, really momentous opportunity. The commissioner that spoke a bit earlier mentioned about the US leadership that it used to have during the days of Motorola and Lucent. I would tell you truthfully that the US could seize that opportunity again if it realizes how to put the pieces of the puzzle together. And the good news is you guys have everything you need and the right allies to support this journey. For me, I know what the challenge is to really make this successful. For me, it's about encouraging a good supply chain of components and silicon. And unluckily, we have enough good software development companies in the US and in Japan that are able to help us out. So maybe the challenges that I see is slightly simpler. It's about skill set, organization, and the creation of a healthy ecosystem around silicon for the remote radio head and the massive MIMO products that needs to be created. And I think most of the silicon anyway, most of it would come from the US.
Okay.
I just want to add, Chairman Pai.
Yes, please do, Carolyn.
Yeah, green on brown. Just recently, Verizon, the most, the leading, one of the leading operators here in the United States, announced a pilot of a 5G cloud native end-to-end network built on virtualization, including the RAN piece. You could not get more proven than that. It truly is here in the United States, a green on brown situation. So it can be done. I think that's what everyone is trying to say.
And Caroline, if I could follow up, as I mentioned, interoperability is one of the things that I was curious about. And I know you've done a lot of work in this space too. How important is the standard setting process in establishing or enabling interoperability between and among different suppliers? And what role do organizations such as the O-RAN Alliance or the Telecom Infrastructure Project play in that process?
They're foundational. Industry standard bodies and groups are the foundation to drive interoperability between different suppliers. And we've seen that time and time again in 3GPP, but especially with the Open RAN, both organizations, O-RAN Alliance and TIP, our Telecom Infrastructure Project, play a key role. While the O-RAN Alliance defined the standard interface between disaggregated RAN components, the TIP, Telecom Infrastructure Project, focusing on prototyping, integration, and testing. In fact, T-Mobile is hosting a TIP 5G NR Open RAN lab right in your home state, Kansas.
Oh.
So, yeah. So O-RAN Alliance and TIP have announced a partnership in February this year to develop interoperable 5G RAN solutions. One of the first output will be the release of Open RAN 5G NR base station platform requirements document. It provides a blueprint for the suppliers to test against. And it's not just a one macro solution. People can add in a different modules to that as well. It's back to what Thierry talked about. It really truly leverages the fact that the US ecosystem has a proven software innovation. We have been in the cloud technology, server technology for a long time. It really is the standard body plays an important role to put all the Lego pieces together and make sure they're interoperable.
Just to add to that, Chairman Pai, so as chairing the O-RAN Alliance right now and involved in the founding of the O-RAN Alliance, I think one of the lessons I wanted to highlight, which is very important, is this was this is, as Caroline said, it's foundational, and it's foundational also because these are new organizations that are giving operators a voice in the standard setting process. So historically, the standard setting process has been dominated by the incumbent vendors, and it really was, what do telco operators want to innovate on? How do they want to disaggregate, build out their new 5G networks? And so both these bodies were about how do we give operators a voice, get them to specify what would their requirements be, how would they like to see the platform change? And I think that's why they are very critical as we go forward.
That's great. And I will note that with all due respect to Silicon Valley, I'm not surprised. Kansas prides itself on being on the leading edge of technological innovation. So thank you,
Sure
Caroline, for pointing that out. Sachin, in one of your earlier comments, you said something that piqued my interest in terms of picking the best in class or best grade components. That raises the question then of integration. And what do you see as some of the challenges and opportunities in terms of integration from an operating perspective for you or anybody on the panel, since all of you, of course, have expertise in this area?
Sure. If I may, I would like to share a slide.
Sure.
Can you see my screen?
I can, yes.
All right. So great question, Chairman Pai. So I think the dilemma is the following, right? You want the benefit of choice without the pain of integration. Because historically you have been able to get one solution and have that deployed everywhere. And I think this is really where actually there's an opportunity for innovation for US companies. If you look at how cloud services are delivered today, there is basically, as a developer, you go and mix and match several different services, and then you can build a brand new service within a matter of days. Why can't that be true for telco? So this is what we are trying to now realize in the US with Dish. And this is going to be a great proof point for an Open RAN network, an Open RAN 5G network in the US, which is going to be running at scale. But really this idea that you can build an automated way of continuous integration and continuous deployment. Thierry was talking about CI/CD pipelines, but really leverage the best of cloud tools and have essentially an app store concept. So when you talk about network, its network is a collection of network functions delivered as software. In each one of them, to oversimplify this, is an app. And so really the vision here is that you can build an automated way of doing continuous integration and continuous deployment, and then let cloud technologies manage the deployment of these functions and software across all of the different clouds in the country, and figure out how to stitch them together and deliver a mission critical service like a 5G network. So I think this actually system integration should not be seen of as a challenge, in my opinion. It's actually an opportunity for US innovation, because this is what we have done really well. We mix and match things. This is how we innovate, right? We mix and match a bunch of different things and produce new products. I think this is exactly the approach we need to follow for 5G. And this is what we are doing for Dish. And I think it'll be a fantastic proof point for US innovation.
That's terrific. And Tarek, I don't know if I thought I saw you were looking to jump in as well, or maybe I missed.
Yeah, I just want to add one additional thing, by the way. I think, as engineers, to be very honest with you, it's just kind of fun, by the way. It's fun. So, in the early days, if there is any definition of what we went through is a really out of this world science project in the beginning. And the idea of take a hardware-based baseband, and all of a sudden you move this thing into a virtual machine, and the magic you discover once you move from proprietary hardware to the VM. Chairman Pai, that's what this industry does not understand about what is the benefit of Open RAN. Luckily, as we understand it, because we're living it every day, and I keep saying in every keynote I speak about, we're scratching the surface of what's possible. Because the level of automation that you're going to realize when you discover how you could really manage these VMs, and today it's VMs, tomorrow it will be containers, is just utterly elegant. Elegant when you start to think 4G and 5G networks have the potential to be like managed Wi-Fi service. Then that's what I would consider to be the North Star that all of us should be working towards. We have taken actually an advanced an entire telecom app store concept, because we think that's what we're heading towards. And, in our approach to Rakuten Communication Platform is all about driving this innovation. But I don't think we could do this alone. We need collaboration. We need industry support. We also have really solicited not only industry support, but we also think private as well as government, could really work on this initiative hand by hand to drive such a industry transformational event. And I always say it's not revolution, it's not evolutionary architecture. It's absolutely revolutionary. Once people to start to understand why the enthusiasm and excitement, I only would tell people, wait till you start operating a true cloud network. You will discover the benefits.
That's terrific. One of the things I find very interesting about this space is that in a way it exemplifies what the late Professor Clayton Christensen called the innovator's dilemma, in particular disruptive innovation, and the ability for new firms, smaller firms, to enter the marketplace and really drive some of the technological change. And so, Terry, I thought I'd turn to you. Altiostar is one of the smaller companies, of course, in the space compared to some of the larger companies that we've all heard of. What do you see O-RAN portending for smaller players, and how do open networks enable their participation in this ecosystem in a way that might not have been the case in the traditional network architecture space?
Yes, we really consider that it's absolutely essential that this industry, as I mentioned before, is going to be more diverse and be able to attract other companies to participate. It's all about innovation. And the fact that now we are able to build networks, this next generation of networks on software and leveraging the cloud and other things, is creating a new entry point. We are removing barriers which have been in place of the incumbency coming from the traditional vendors. So having this open supply chain, and it's open because now if you are using open interfaces, you have enough confidence that what you are going to develop as an entrepreneur can be deployed with other network elements, but you can participate. And it's very clear that not one single company can pretend or claim to have the best technology for all elements of the RAN. So it's extremely important that we unleash this innovation. It's, in fact, very good news for this country, because we have a lot of assets, a lot of intellectual property that we can now leverage. And that's very much what should be the new definition of content. It's not just where you manufacture your product, it's where is the intellectual property coming from. So there's a lot of intellectual property which now can be really put in the market. And it is because the network is becoming a platform. And if you want to really realize the promise of 5G, you need to attract a lot of application developers who will be able to write and add their value on this platform. And that's, for me, a very fundamental aspect of Open RAN, that the network is becoming a platform for the operator themselves, but also for other application developers. It's absolutely essential for the success of not just Open RAN, but for the industry and to deliver for all the different 5G use cases. And as Tarek said, we're just scratching the surface, but we need to create the foundation. So this is the foundation that we need.
That's great. It sounds almost, to use a rough analogy, to the mobile app economy that developed on the 4G LTE platform. That's once you made that platform available, all kinds of apps sprung from that. And you also talked about the fact that a lot of these intellectual property and other assets are U.S. based, and that leads to a question I was hoping to pose to Caroline, which is, how do you see O-RAN or Open RAN solutions leading to American leadership in 5G and other types of wireless technologies?
So I'll just, we talked about it quite a bit, right? The standard interface defined by Open RAN really creating opportunities for innovations to come to the market. You alluded to that, like during the 90s in the .com area, when you put up the platform, you drive a lot of software innovation. Now the US ecosystem, as we kind of discussed, we've been investing in this virtualization technology for a long time. We have a thriving e-commerce and cloud and IT business. So in the last 10 years, Intel, for example, has been investing in the Open RAN technology over a decade. So we truly started having a lot of these intellectual properties, like you said, like Thierry mentioned too, the cloud native architecture, the server technology, software innovation. And because 5G really marks the true convergence of communication and compute capabilities, not just bringing benefits to consumers, but also transform many verticals like industrial IoT, healthcare, precision agriculture, retail, and so on. we need software innovation to develop great use cases, and operators need the technology tailored to the requirements of these use cases. In fact, Intel, T-Mobile, NASA, Microsoft, and Dell VMware, we actually part of a 5G open innovation based in Seattle. That's a very good example. When you make that platform open, when you make that platform agile, you are inviting the innovation that comes in. So while Open RAN is not a panacea for US leadership, I do believe it sets a really good foundation for leadership in 5G and wireless technology. Of course, let's not forget all these great use cases need spectrum. So we need the FCC leadership under Chairman Pai.
I mean, to add to that.
Oh, sorry, please do, Sachin. Yes, sorry.
I'm sorry, Chairman Pai. So to add to that, what Caroline said, I think if you look at the last decade, there's been a tremendous amount of innovation in applications that run on top of the network. I think the next decade will be innovation on applications that are programming the network, right? That where the network is actually allowing the application to deliver a differentiated experience, like a self-driving car, like a VR, AR experience delivered over the network. And I think that's really what Open RAN will enable, because it's enabling programmability in the network with open interfaces. So applications can actually program the network and deliver capabilities that you could not do before. And this actually is critically important for the economic success of 5G, because if 5G is going to be yet another unlimited data plan, I think the operators will struggle to make the economics work of a brand new network upgrade. So how do you build services that even the operators can monetize? It's by giving programmers the ability to program the network and deliver these new innovative services. And that's where I think Open RAN and open programmability, open interfaces are a critical building block.
I'd be curious then how, in terms of programmability and what that might imply, do you see a role for adjacent technologies, artificial intelligence and machine learning, and in particular, to play a role in optimizing these networks?
Yeah, just like a self-driving car, how do we build a self-driving network, right? So the vision that with 5G, and you touched on this question on integration earlier, which is disaggregation is going to lead to more complexity because you have a lot more components to tune and program and put together. And we want to tame that complexity by leveraging technologies like artificial intelligence. But AI is not going to be that useful, that applicable if the network is closed, if those interfaces to program it don't exist. So I think the way it's a two-step, right? So which is you open up the network, have the interfaces, have the programmability, and then AI comes in to figure out how to program the network to actually deliver on this open disaggregated vision with all of these new services. So I think AI is kind of a critical building block to tame the complexity of rolling out a new 5G network, and also being able to leverage all of these new capabilities for delivering these new innovative services on top of the network.
Let me add just to that one more comment. I want to give you a practical example of the power of when we talk about Open RAN and open interfaces in our network. So we have taken an approach. There's an amazing creative smaller entity, 11 people entity in San Diego that provides what is called in this industry self-organizing network. Now, in any traditional legacy architecture, if you ever asked a big vendor, can I please integrate a small little agent software footprint in the eNodeB software, it would be absolutely impossible. So in our network, through open APIs, we've taken a very powerful AI machine learning algorithm that does, the auto configuration for the network, the zero touch configuration, self-healing, integrated through API, an 11-man company delivered on a spectral efficiency gains that are just unprecedented by just this concept of being open. So we've taken, Altiostar software, and top of Altiostar software, through API integration, through the apps that the industry dreams about, is this interoperability of application. I mean, you want to talk about the power that you don't have to create everything by yourself. You just have to provide a platform. And on top of the platform, the innovations will come through many, many startups that exist already in the industry.
It's incredible. Well, I noticed that we have about 5 minutes left, so I want to be respectful of your time and close with the following question. This is a very exciting look at where we are going and where we are in some cases. What do you see as the role of government, the FCC in particular, but not exclusively, in encouraging the growth of the Open RAN environment?
Yes, and if I may start. So obviously we have a responsibility as an industry to educate. And when I say to educate, people don't know what they don't know. And we have discovered, certainly in the last 2 years, that Open RAN as an emerging option needs to be explained. We need to explain what is all Open RAN about. And there was a lot of, we are living in the world of fake news. So we understand that a lot of information has been communicated that was not true. Obviously, now having real network deployed is the best way to educate and to say that this is real. But I think what is important here is, especially from a US point of view, in a US perspective, is really we are looking at the government and the policymakers to facilitate the adoption of Open RAN. And I have heard this many times when we are competing outside of the US, that everyone expects that the US being a showcase. A lot of the technology is coming from the US. Obviously, we have a lot of trusted partners participating in the broad ecosystem, which is great. But I think it is a unique opportunity for the US really to take advantage of the innovation. There's tremendous level of innovation, not just from Altiostar, from other companies. In fact, we can mention that VMware or Cisco and others were not able to participate in this part of the network. Now they are. And so this is extremely important that we have the opportunity to show, and Dish is going to deploy. This is great. I think there's a unique opportunity where the FCC is obviously very much driving this transition for the real carriers. Wouldn't it be great that the real carriers are going to be able to take advantage of this innovation? Isn't it really great that maybe with the same dollars that we are going to use for the US taxpayer, we can do more? We can, really reduce the digital divide. So that's the kind of thing that I will believe that the US government and policymakers can help us. And when we compete outside, obviously we need to have a level playing field. When we compete against, untrusted vendors, as a startup, we can only compete on our own merits, that we have better technology. It's competing with innovation. And in fact, we have to compete with innovation. That's the only way you win. But we have to make sure there's a level playing field. And we need the support of governments to do that.
Terrific. Well, Sachin, did you want to close this?
Yeah, no, so just to add to that, I think this may be in terms of what role could government play. I think the government has especially a very important role to play with, to pardon my pun, how do we make green shoots grow in a brownfield environment, right? So essentially, I think the way as new spectrum comes out, and there have been so many spectrum auctions that have been successful recently, and carriers are going to deploy new networks, I think incentivizing them, nudging them to deploy open radio interfaces. Because one of the biggest challenges is if you deploy a proprietary radio now, you're stuck with it for the next decade, because it's really hard to send people out there and replace radios on cell towers. Deploy open radio hardware and then virtualize the software, because then you gain the flexibility of making the right choices in the future, and you're not locked into a particular choice, because hardware is the one that really locks you into a particular choice for the next decade. So the government could play a great role in making sure that both of these, as we transition towards 5G with this new spectrum, that we make sure that we get the deployment architecture right.
That is terrific. Well, I'm afraid we are out of time, but I just want to thank again all of our panelists, Caroline, Tarek, Sachin, and Terry, for lending us your expertise. I've learned quite a bit in the last hour, and I'm sure there's much more under the surface of the water, so to speak, for me to follow up on. Thanks to each of you for taking the time to be with us today, even in a virtual environment. I thought the conversation was quite lively, and hopefully some of the viewers thought so as well. With that, we will begin the second panel after a short break. So stay tuned for the folks who are watching on the live stream. We'll be back in a few minutes. And thanks to you all again. Appreciate it.
Welcome everyone to our second panel of the day. We have a great lineup of speakers for the Benefits of Deployment / Driving Innovation panel. But before we begin, we will hear remarks from FCC Commissioner Brendan Carr. Commissioner Carr, take it away.
Thank you so much. It's great to get to participate in this event. Thank you to Chairman Pai for convening such a great group of academics, researchers, and industry professionals. And thank you as well to Secretary Pompeo for the remarks that you delivered today and for the leadership that you've been providing really around the world in furtherance of clean, secure 5G networks. You know, this transition that we're doing right now to O-RAN is really a big deal. And to me, when I think about this transition, I think back to one of the great unbundlings that we saw, which of course is the PC market back in the 1980s. As someone that was born in 1979, I remember fondly those early 1980 days. If you think back to that period of time, you know, IBM was just dominant in the PC market, and it was dominant in a way that was completely vertically integrated. Everything from the hardware to what we think of as the OS to the software was all packaged together. And with respect to the IBM of today, which is a very different company, and I will hear from some of them to come, the upshot of that back then was a product that was clunky, that was expensive, and that really was only affordable from highly profitable corporations. And in the 1990s, Microsoft came in and completely disrupted that vertical integration. It unbundled the PC market. It separated out the hardware from the OS, from the software. And flash forward, we all know what that produced. That dramatically drove down the costs of laptops. It enabled a lot of different competitors to enter the market, from Dell to Gateway. And for consumers, it meant that they could actually afford to buy a PC. And that unbundling of the PC market coincided with the build out of internet infrastructure across the country. And you put those two together, and that's why I think we saw Americans getting onto the internet for the first time in the 1990s. And that exact same dynamic, that exact same type of unbundling is about to take place in the wireless infrastructure market. And so for those of us from a policy perspective, I think that's attractive for three main reasons. One is improvement in service. The other is improvement in security. And the other is jobs. And from the service perspective, this unbundling means that everything went from consumers to wireless carriers themselves are going to be able to mix and match components and pick the best ones that meet their needs. We're going to see competition, you know, across what used to be a vertically integrated market. And that's going to improve performance. We're already seeing pieces of that today. Right now, there's one rural carrier that's been working with an O-RAN vendor, and they're seeing a throughput increase by about 40%, and they're seeing their costs cut in half with a virtualized core plus O-RAN. So that's some of the reasons why this is going to be important. And we've been working at the FCC for a number of years now. I've been leading the effort to reform our wireless infrastructure rules to make it easier to swap out, upgrade, and add new equipment. And I think that's going to coincide with this desire to build out this O-RAN architecture. The other piece of this is jobs. So by unbundling, we open up the marketplace to smaller providers, for ones that are expert on software, and that happens to benefit a lot of US companies, which I think is a great thing, particularly when we're talking about build outs that might be supported by universal service dollars. A lot of these companies are represented here today, from Altiostar to Mavenir, Parallel Wireless, and many others. So I think this unbundling is going to help spur investment and high-paying jobs here in the US. And the last piece, of course, is security. More than 2 years ago, the FCC launched this effort to make sure that universal service dollars aren't going to insecure network equipment. And a lot of smaller rural carriers felt like they had no option other than expensive, bespoke pieces of Huawei gear. And that Huawei gear was relatively affordable for them for a lot of reasons, including subsidies from the Communist Party, and including what we perceive to be some security threats that are there. So the question for them is, how do we make sure that they feel like they have more choices and more affordable choices for secure equipment. And that's where O-RAN is going to help out as well. You've got a lot of US-based providers that are expert on software that can create a secure network environment virtually, something outside of a vertically integrated and what we would view as insecure Huawei gear. And so looking forward, I think the big challenge for us and the opportunity from Chairman Pai convening this forum is to accelerate this transition to O-RAN. And we want the private sector to have confidence that they can put this equipment and this software into their networks. One backstop that we have in mind, of course, is this rip and replace that we may engage in here in the US, with it costing roughly $1 to $2 billion to make sure we have all subsidized Huawei gear out of the network. We as policymakers need to accelerate this transition to O-RAN so that these smaller providers, when they're looking to use those rip and replace dollars, feel like they have a real choice, and O-RAN vendors have a fair shot at competing for their business. So that's one backstop in the back of all of our minds for accelerating this transition. And we are really excited about the disruption that's going to come from unbundling the network. And so really look forward to hearing from the panelists today. Thanks.
Thank you so much, Commissioner Carr, for those remarks. We have a great lineup today. Panelists, please turn on your cameras. And in alphabetical order, I'd like to introduce them. We have Cristiano Ammon from Qualcomm. I hope I pronounced that correctly. Craig Farrell from IBM. Peter Gamble from Global Foundries. Morgan Kirk from CommScope. Diane Ronaldo from the Open RAN Policy Coalition. John Rose from Dell. Mariam Sarund from Cable Labs, and Soma Valayutham from NVIDIA. And if you'd like to read more about those panelists, you can go to fcc.gov/events, click on the O-RAN page, scroll to the bottom, and we have their bios. But we want to take time today to focus on questions. So let's kick things off. We've heard a lot about O-RAN in the previous panel. We got an introduction to the topic. Morgan, let's start with you. What changes does Open RAN introduce into the current business model for telecom infrastructure?
Yes, well, thank you for having me here today. The current business model has not changed in at least 20 years fundamentally. This has limited the opportunity for innovation, global competition. In the current system, competition is really limited to a once-a-decade competition during a transition of a cycle between 3G and 4G, 4G and 5G. After which the small winners, there are usually two of them, are locked in for that full cycle. This concentration provides a level of stability, but it has a protected and incremental limit to innovation. And there's little opportunity for cost reduction. So what Open RAN would really do is change all of that. And if I could have my slide popped up, it's probably easy to discuss it based on this. What you see in this slide is effectively a number of interfaces being defined, which allows for competition in each one of the subcomponents, whether it's the central unit, the distributed unit, or the remote unit or active antennas. In addition, what you see on this is an opportunity to change something which has previously been monolithic, in other words, integrated entirely in both hardware and software from a single company, to being disaggregated or open. And that's really the key to all of this. You can have a variety of competitors competing both on cost as well as on innovation in each one of these components. And as we know, when companies are able to compete, they're able to innovate more rapidly. I have here a example, just so that people can see this, of a CommScope remote unit with integrated active antenna. And this particular remote is an indoor remote, but it fundamentally is compatible to O-RAN and would work with other parties' DUs or distributed units or centralized units, thus enabling a company like CommScope to compete in an area which we happen to be good at and have somebody else compete in an area that they're particularly good at. And when you have a full industry that is competing in all these various areas, you will end up creating a more stable, more fast-moving, more dynamic infrastructure that ultimately not only benefits the consumer, but the industry and US manufacturers like CommScope. I like to say that if companies in the United States are given the opportunity to compete on an open playing field like ORAN, we do very well across the globe.
Thank you, Morgan. Diane, I want to move over to you. Morgan talked about, diversity, competition. His slide shows how when you disaggregate the network equipment from the core to the edge, from hardware to software, you necessarily are going to introduce new names into the mix, maybe names that were not previously associated with network equipment. So your organization, the Open RAN Policy Coalition, has a diverse membership that kind of represents that dynamic. What does your organization say about the diversity of the radio access network market now as opposed to maybe 10 or even 5 years ago? I think you're on mute.
Of course, it's always me. I'm the first one to leave it on mute. Thanks, Evan. I appreciate the opportunity to be with you here today. And just to say to the chairman's remarks, I hope at some point we can all have lunch at the FCC building. It would be good to connect everyone face to face. Absolutely. We are all here today. You have assembled such an impressive group of government folks as well as private sector experts to talk about how do we drive more diversity in ensure a more robust supply chain. And that's what we're talking about at the coalition. When we first launched on May 5th, it was twofold. It was one, first and foremost, to educate policymakers on what is occurring in this space. With Rakuten, Reliance Jio, Dish Networks in our own backyard, they are building out their networks to ORAN specifications. It's here, it's occurring. And so what can we do as private sector companies? How can we work with the government to help promote policies to ensure that we have scale and we can continue to promote that innovation that's driving at the component level? While Open RAN itself is a specification and it is not a technology, the technology and the technical evolution is going to occur at the component level, the radio, the hardware, the software. So it's great to bring together such a diverse group of folks here today to talk about what's happening today and what we foresee for the future.
Well, speaking of new names in the network equipment space, John, your company Dell is a household name, but not necessarily because of ORAN. While I would really hope that the vast majority of Americans know about ORAN, at least after this event, they might not think of ORAN when they think of Dell, but you're here for a reason. And you've talked about the changing ecosystem in network equipment. The makeup of this panel is certainly an example of that. How do you see these changes evolving?
Yeah, no, thanks very much for having us. Hopefully people are familiar with the brand Dell. We're a little more than PCs these days. We're, I think, the largest infrastructure technology provider in the world, but and we do have a very large service provider business, but we aren't explicitly a player in the legacy of telecom, the radio side. What attracts us to this new ecosystem, and I'll talk about that in a second, is that it isn't just about building the next generation mobile network in the image of 4G, which was primarily driven by consumer consumption and mobile broadband packets over the air. It is, to us, the digital fabric that's ultimately going to sit underneath almost every digital transformation, whether it be smart manufacturing, next generation of transportation, the healthcare, or education ecosystems. Those are areas that Dell has historically been extremely visible and present in and helping those companies and industries transform. And when you think about where they're going, their users are distributed, their data is distributed, connectivity is critical. And when we look at 5G, if you look at the full promise of it, it is the fabric underneath. Now, the challenge we have right now is that if you look at other big IT and cloud transformations, the ecosystem in 5G is relatively small. If you compare even the number of semiconductor companies emerging in the AI space versus the number of new semiconductor companies emerging in 5G, it's anemic. If you look at the software companies, while there are some great small startups that are doing great work, if you compare that to the cloud ecosystem, it's 1/1000th of the companies participating. And so our view is in order for 5G to really hit its promise of an open, integrated architecture that is this underpinning of the digital transformation, we have to attract the entire cloud and IT industry into this ecosystem. We have to pull in more semiconductor companies. We have to pull in big system companies like Dell. We obviously have to have software startups, investment in new ecosystems. Academia has to scale. Just across the board, whether it's supply or demand, the ecosystem has to get larger. And one of the things we like about things like Open RAN is by decoupling and by allowing modularity and replaceability in the architecture, it introduces white space where innovation can happen, whether it's at a very low-level interface like eCPRI or whether it's at a very high-level abstraction like virtualization. The minute those layers exist, it attracts technology companies to try to find a better way to make that interface work or to make value created at that point. So for us, it's a strategic decision to be part of the 5G ecosystem because the entire IT industry depends on it. But it's also an opportunity to help bring that ecosystem together and turn it into outcomes, which is something Dell does probably better than most people in the world.
Well, thank you, John. And based on your background, it looks like you've literally merged with technology. So congratulations on that achievement. And speaking of backgrounds, we have Miriam joining us from a soundproof studio. So very well done on that front. That's video conferencing. That's a video conferencing super move. Miriam, you've been following this ecosystem for a while. So I figured you'd be great to piggyback on some of the things John said. And when we hear about Open RAN, we almost necessarily associate it with 5G cellular networks. But wireline and wireless are, of course, inextricably linked. And there's a reason that the FCC's 5G Fast Plan has such a emphasis on fiber. So what do wireline networks, whether it's cable or fiber or other wireline networks, see in ORAN?
Great. Well, thank you, Evan, for inviting me to speak at this panel. Certainly exciting. So first, as you correctly alluded to, a wireless network is what transports a total network, is what transports traffic from the wireless part of the 5G radios to the 5G core. Therefore, a network must be looked at end to end in order to design for innovation and future use cases. For example, take low latency, which is one of the pillars of 5G. That needs to be viewed end to end. Solving for the wireless part is not enough. Second, let's not get stuck on 5G itself. 6G, the future generation of 3GPP, is around the corner, and also there are other wireless technologies. So in general, when we're looking at the future network and the future of innovation, we must take into account the convergence of the wired and wireless networks. So what Open RAN, along with virtualized RAN, does is to, as my colleagues have stated before, to decouple software and hardware, break down the radio components into smaller pieces, and therefore this makes it easier to bring together and interoperate the elements of a wired and a wireless network through the use of common hardware platforms. And this is exactly where our members will play a critical role and will leverage Open and Virtual RAN to deploy wireless very efficiently and surgically on top of their existing very robust wired networks.
So we've heard why Open RAN might be good for the network. The title of this panel, of course, is Benefits of Innovation. And what does that mean for the consumer? You know, what does the end user get out of this in addition to the network operator? So Soma, I'd like to turn to you. One of the benefits we associate with 5G is network slicing. This idea that you can have multiple networks within a network. Maybe it's one network for gaming. Maybe it's one for smart cities, one for public safety, et cetera. All the same radios producing different networks, different needs in terms of geography and density. Do open networks, or particularly virtualized networks, make network slicing easier? And what does that mean for the consumer?
Yeah, thanks, Ivan, for having me in the forum. Definitely, as my previous speaker spoke, network slicing basically is about software-defined operations, right? And virtualized RAN makes it definitely easy because you are basically creating, network functions are expressed as building blocks, software building blocks, and and abstracted from the hardware, so you can actually pick and place. But there are three components that actually make up network slicing. One is you need to have software unbundled from the hardware. The second thing is you need to have very good orchestration layer. So you need to be able to make that orchestration because it's already unbundled, so you need to coordinate it. And the third thing is you need to really have very high compute to be able to orchestrate this complexity. So it's almost like you unbundle it, but then you need to be logically one, but physically disintegrated, and that's a lot of coordination, right? And that's what network slicing is all about. And virtualization definitely is it's in fact, it's not makes it easier. It's a requirement. It's a prerequisite to make network slicing. What's interesting is O-RAN takes it to the next level, because O-RAN proposes certain interfaces like O1, A1, and E2, which basically it's a part of what they call as a radio intelligent controller. And these interfaces in the radio intelligent controller unbundles it to another level. You don't have to be tied down to a network vendor or someone specific, but you actually can really use the open interfaces and run machine learning and deep learning to further orchestrate it. So let me recap. So I think network slicing, in fact, virtualization is a prerequisite, but Open RAN takes it to the next level. It unbundles the logic from a rules-based to potentially an AI-based logic.
And another benefit that the FCC looks for when we think about innovation in networking is spectral efficiency. The FCC has pushed aggressively to make as much spectrum available for commercial use as possible. In Chairman Pai's opening remarks today, he touched on the 5G FAST plan. But it's no secret that there is very little greenfield spectrum left, essentially spectrum that's not currently being used, and that creates challenges. So how do the technologies you just described help with spectral efficiency through deployment of things like software-defined networking and virtualization? The goal here is essentially to squeeze more juice out of the same lemon. And how do we do that?
Yeah, I think that's probably the best expression of spectral efficiency, right? To squeeze more juice out of the lemon. So I think the number one technology that is being looked at in 5G and beyond is massive MIMO. And massive MIMO truly in a sense of 64 antennas, transmit, receive, maybe even higher. And massive MIMO is very promising, but at the same time, it does have front haul requirements. There's a lot of traffic that you need to go back and forth. So massive MIMO, just massive MIMO alone is not good enough, because you need a lot of rules in order to coordinate that. And the idea is, if you can have virtualization and open interfaces to your antennas, to your open RUs, then the rules engines can be very advanced. So today, the massive MIMO is based on a certain logic and rules, and it's probably written by a handful of people. I would say no more than 100 engineers in the world who understands beamforming and MIMO and coordination and so on. But by really unbundling and opening this up, you are able to use AI and deep learning to do beamforming algorithms, to do multi-point coordination. So these algorithms are very advanced. And one analogy I would use is, if you think about cellular is actually an organic beast, right? It's more of a chemical reaction than a logical expression, right? So it's like making beer with yeast. You don't have a logic. You need to be very reactive and optimize your network based on that. And that is very well suited for AI and deep learning. And that's why we are very excited in NVIDIA, because we have a huge heritage of AI and deep learning, and bringing this into telecoms and 5G and getting the best out of the spectrum is fantastic. So again, Ivan, I would say two things. One is beamforming, one is massive MIMO as the technology, but beyond massive MIMO, using AI and deep learning to make the best out of that, that's the most exciting thing.
Thanks, and that tracks with some of the things we heard about artificial intelligence being enabled by open and virtual networks in the previous panel. Craig, we've also heard a lot today about the importance of integration. And integrators will be an important aspect of O-RAN in terms of assuring that equipment and software from diverse suppliers can work together. And can integrators replicate the ease and convenience of a full stack solution, essentially the network in a box that traditional OEMs offer? Do you see an established company like IBM supporting the smaller upstarts in the market that do not necessarily have the scale of the larger companies that we're more familiar with?
Yes, thank you, Evan. And in fact, a number of the speakers today have talked about the importance of the end-to-end integration of a solution, and this will be a critical component. As we start to see an end-to-end solution that's really made up of a number of components from diverse suppliers, this whole idea of interoperability testing is going to be critical to seeing the widespread adoption of O-RAN in general. So suppliers like IBM, we have a long history of doing end-to-end integration testing for services in IT, particularly software services in IT. So as O-RAN opens up for us a new market, we look forward to bringing this sort of expertise along. And we have entire practices, around testing and certification. We even has, as a number of people have talked about today, how important security testing will be. We have practices around this sort of thing already. So we really do look forward to this sort of opportunity to bring all that expertise to a whole new market. And this is going to be, very, very important, for the integrity of end-to-end solutions to be maintained, because we all want component vendors to be able to innovate and bring the best of breed solution for their particular area. And the idea of bringing best of breed solutions is the sort of thing, I've been doing for a long time. So we want to do that, but it's absolutely critical that system integrators take the components, do the testing, and ensure the integrity of the end-to-end solution. And just in answer to your second question about, will IBM be working with smaller companies to do this? The answer is absolutely yes. In fact, we already are. There are a number of examples, indeed, some of the companies on the call today we're already working with, at customers. So yes, indeed.
Well, it's now my pleasure to introduce my co-moderator for the panel, Charles Mathias, Associate Bureau Chief of the Wireless Telecommunications Bureau, and he will have some questions for you all. Thank you.
Good morning, everybody. It's a pleasure to see you all. Thank you for participating. I'm glad to emerge from the cloud for this purpose. And one of the things that we are looking at as a potential benefit for O-RAN is innovation in the chip market. And Cristiano Bomgia, I was wondering whether we're hearing a lot about the importance of chips, and I'm wondering whether both for the U.S. economy and from a national security perspective, you have some comments and thoughts about the role that chips will play, the chip market will play in O-RAN, and also how do you see this evolving as the technology develops? I think you're muted. It happens to us all. Still. Cristiano?
Can you hear me? Can you hear me now?
Now we can.
All right, perfect. I'm on a studio, so I had no control of the mute button. Very happy to be here. Thank you for participating in this event. I think this is an exciting time for the industry. And I want to start answering your question by going back on some of the remarks I think that was made by Commissioner Carr at the beginning. Look, in this industry, what we have seen in everything that got scale, especially when you think about consumer electronics or everything that has, digital and processors on it, it really scaled to disaggregation. And I will say that the American companies did well overall by embracing innovation and disruption. And it's actually a moment we have right now in front of us. I think an example was provided on the PC. I'll give another example, which one is very near and dear to us. When you look at the phone industry, you look at the phone in itself was vertically integrated. You look at companies in the beginning of cellular like Nokia, Ericsson, Motorola. Then a company like Qualcomm created a platform that you can put change computing from a desktop to the palm of your hand with the silicon and semiconductor horizontal platform. And you look at what the smartphone is today. And in many cases, the smartphone has been the first time that many people in the globe had access to the internet. And it's cannot even measure, I think, the amount of innovation it created. The smartphone today, it's mankind's largest development platform. But the internet also evolved exactly the same way. If you look at the data center today, it's the same thing. And I'll say, by American companies embracing innovation first, I think American companies done very well. Look at the role of American companies in the horizontal personal computing platform, both in the OS as the semiconductor and the processor. You look at that in the phone space. You look at that in the cloud, and it will be no different in the network. The network is going through a process of disaggregation. And I think what's great about this panel, what is great about the FCC initiative, it's about not only bring awareness, but a huge drive for, American companies and companies around the world to embrace innovation and going to what the infrastructure 2.0 is. And with that, I'll start answering your question to say it's fundamental for you to create a horizontal semiconductor platform for that to happen. So we're excited about this opportunity, especially for a company like Qualcomm that has been super focused in wireless communication. Assets that today you only see companies like Ericsson, companies like Huawei for their markets that you have on the digital side and on RF side. A company like Qualcomm that has done that for the device space. It's our number one core competence, and we can create a horizontal semiconductor platform that touches on not only the baseband, for the digital units, but all the way on all of the solutions for the remote unit, and then allow this entire industry to innovate by building new hardware and software and drive this transition to what we call the infrastructure 2.0. So we're very excited about this. We have started early with this vision. I think Rakuten, I think Soteric in the prior panel was the world's first public, network, which is based on a vRAN and Open RAN architecture, enabled by our technologies. And there's a lot more coming from Qualcomm very, very soon in building a very competitive horizontal, platform to enable many companies to innovate in the space and drive this disaggregation of the RAN in the same way that was successfully done within personal computing, the smartphone, and the cloud.
Thank you. Peter, I wonder whether you have share that perspective or have a different view.
Thank you, Charles. First of all, I think with the speed of innovation, I look forward to joining the next panel by my virtualized avatar telepresence. I know that we can do this. In fact, even though we're talking about Open RAN today, the innovation speed is not where it needs to be. Our current forecast is only 10% of the network will be Open RAN by 2025. We all need to work together to accelerate that. And I know that's what's common to a lot of the panelists. We're seeing an explosion of companies optimizing their hardware by the specific function in the network. Many of them are represented today. Two specific examples we already heard are beamformers, where there are a variety of US companies looking at both analog and digital beamformers. And also on the networking side, the explosion of silicon photonics to interface directly to the cloud. At GlobalFoundries, that really allows us to optimize the technology to meet the segmentation in the network. And the second thing we need to do where we're not quite there, we talk a lot about the interface standards, but in many of our chips, the interface standard itself is provided by a third-party IP provider. The stability of those interface standards and the availability of them in specific technology nodes also needs to be accelerated, and that's something that we're very, very eager to work with our partners on. Once you have interface standards, one of the things we can offer and hardware companies can offer is a root of trust or physically unclonable functions. One is concerned when you have hardware coming from many vendors that will be less secure. In fact, with PUF and root of trust, you can actually have those functions be more secure. The final thing I'd like to just mention is also the opportunity and the role of the US government. We talk a lot about security. Many of the hardware companies are US companies coming in. We have many of them represented today. But if you take it one step lower and look at the chip making industry, right now, there's only one US supplier of chips. That would be GlobalFoundries. The rest of the chip making industry is offshore. And we have been working with the US government to ensure that there's a robust supply of silicon from onshore suppliers.
That's great. And thank you very much all of this sounds like this is going to require a staggering investment. And Diane, I'm curious, at least recently, I think it's fair to say that telecom equipment hasn't attracted a lot of attention from the venture capital market, especially when you compare it to the kind of money that we see going into software startups in the Valley and in other places around the world. Do you see O-RAN changing that? You did it again.
Sorry about that. Absolutely. With a closed proprietary system, the barrier to entry is just so high that we haven't seen much venture capital money in this space. To be a startup company and to make an investment of time, brain power, funding to get a product ready and to only be able to sell to a handful of companies, it was just too risky of work. But when you open up those interfaces, you're injecting that additional competition, which is going to drive innovation. It's going to bring more VC money back to the telecom space. We're moving to the next generation of networks based on the open interfaces and protocols. So it's pretty amazing to watch unfold and in such a short period of time.
Can I comment on that as well? Because certainly in the Foundry, we are seeing quite a few US-based startup companies that are focused on specific segments of the network infrastructure. And as I said, as was said here, made available because now you're allowed to optimize your solution for a particular piece of the segment. So many of the networking companies, beamforming companies are very much startup companies, and we're seeing quite a few entrants from the U.S. venture-backed community within some segments of the network, and again, accelerated by the Open RAN standards.
Mariam, would you agree from your perspective? Is this what you're beginning to see as well?
Look, I mean, let's say there's three things that today are bringing us all here together, right? And that's where we're getting all this diversity that everybody is talking about. It's the disaggregating the network into the smaller pieces. It's the opening their interfaces. And the third one is the decoupling of the hardware from the software. So the makeup of this panel and all of today is a testament to that, right? So basically, I'm very encouraged by what I see so far. I see the smaller companies joining the ecosystem. This will definitely foster healthy competition and drive innovation. This will definitely, you'll see a lot of movement in the economics and investments around this. And I'd like to see more more focus on converged networks, but yeah, I'm very encouraged by this.
Thank you. John, as you know, one of our jobs at the FCC is to help facilitate 5G network deployment. This is one of the things we spend a lot of time on so that consumers can reap the benefit of the new applications and use cases that will run the network. And I think you're in a unique position to tell us whether you see a startup environment developing around 5G and what do you think the role of O-RAN will play in that?
Yeah, I think not to be negative, but maybe to be realistic, we are not where we need to be. The U.S. vacated the wireless industry with the exception of some semiconductor companies and the actual operators over the last decade. We have now woken up to that and realized this is a strategic technology. And it was, I think everybody's got that message in the opening comments. And now we're in the process of rebuilding an industry. We're not just tweaking it. We're literally have entire areas like large-scale systems integration or the ability to put all of these pieces together into a system that, quite frankly, existing companies and new companies have to step into those roles. And so there's quite a long journey in front of us. So I think we're moving a lot faster than previous generations. But in order to do that, we have to recognize that there's kind of two paths. There's a path to rebuild the legacy of telecom. Wrong path. I was there before at Nortel and other companies, and that's not going to win. Or the other path is to take what we've learned in the cloud and IT ecosystem and build the ecosystem that way. And if you look at that ecosystem, it requires a number of pillars. It absolutely requires at-scale players to put the pieces together. That's what companies like IBM and Dell and Microsoft and many big companies do. By definition, we thrive when there is an ecosystem of innovation that can feed into those engines. But the second piece is we still have a lot of work to do to reestablish the startup ecosystem. About 2 years ago, I went out and talked to VC firms and asked them, well, what are you doing in 5G? And the answer uniformly was nothing. And the main reason was there were no exits. I can invest in this company, but even if they build a successful, radio resource algorithm, who do you sell it to? Where do you use it? And so I think O-RAN has started to open up some of that avenue, but it's insufficient by itself. We will need anchors, meaning large companies that can deliver the systemness of 5G. We will need open interfaces and access points, the three that Miriam described that I think are very accurate. And those are happening, but they will take time. And then lastly, we're going to have to catalyze an industry of startups that will take advantage of them. Now, there's promising early indications. We have seen a number of very interesting kind of radio resource management companies. Every one of them we ran into were so happy to talk to somebody other than an incumbent when we talked to them, because they felt like, well, I only like 3 types of networks I can use this algorithm in, and the interfaces aren't open, so I can't do this cool stuff I've come up with. A lot of it around advanced beamforming, holographic beamforming, new algorithms, fascinating stuff, but not a lot of them. But now I think they're getting the message that there can be more. On the radio side, we track about 20 open radio suppliers around the world. About half of them are in what we'll call friendly countries. But that's going to be insufficient, because if the FCC continues to do the job it's been doing, which is pretty good, about finding and refarming and reallocating spectrum, we're going to need more radios. Let's assume we figure out what to do with 12 gigahertz, for instance. That's a whole new adventure. We're going to need a whole new radio ecosystem around it, and we're going to need startups that provide that innovation to take advantage of those bands. So I'm optimistic, but I'm also realistic to say that we have just begun this journey, and it's actually quite hard for a rural operator to assemble a turnkey outcome in the Open RAN ecosystem today. The good news is we have pretty much everybody at the table. The bad news is we have a lot of work to do. The opportunity for government, however, is to help us do that, to invest in that outcome as opposed to the individual components, to really focus on the prize, which is when we're all done, there's a US ecosystem that is dominant around the next generation of wireless. And we don't have that today, but if we all focus on that, we will get to a very interesting place, and all the tools necessary to do it exist.
And I can just pick up on this for a second on John's point. One of the dangers we face is that if a number of small, highly innovative companies get together but are only loosely compliant with the O-RAN standards and specifications, we run the risk of making the interoperability problem become significant enough that we don't get the widespread adoption that we all absolutely need. So it's very important that we all look at this. We work very, very hard to not allow this this market to fracture into a whole bunch of sort of loosely compliant component vendors, because then what we all want simply won't happen.
So it's an interesting and I think important point as you sort of look back at Unix and where that went and other things. What do you think are the Craig, are the areas, the key U.S. technologies or areas of leadership that are likely to be most advanced by O-RAN?
Well, there are a number, and in fact, in all deference to my fellow speakers, and there's a lot of today who are all working on some really important technologies that I think will advance. But from my perspective, I actually think that we'll see a lot of advancement in and around cloud technology in particular. Okay, we're already seeing things like data plane development kit, DBDK and single root I/O virtualization, this SRIOV thing. We're seeing non-uniform memory access, this NUMA thing. We're seeing, and of course, a number of security features being added around virtual private clouds. I mean, I think you're going to see cloud platforms, certainly from my perspective, which is a key US technology. I think you are going to see that really evolve to support the sort of requirements that networking on a cloud and indeed virtual RAN networking is going to place on those cloud platforms. This idea of high-speed packet processing and high I/O data rates. I think we will see cloud in particular evolve to support those sort of requirements.
Thank you. And I'm curious, are there any particular barriers, and Morgan, I'd be interested in seeing what barriers to O-RAN adoption you've seen, and what you think. We've alluded to this in several different contexts before, but what is the role that the U.S. government, other governments can play in promoting it if you think that there's a need to do something?
Yeah, so there's a lot to be done before O-RAN becomes, I'll call it the de facto deployment methodology. I think what was said earlier by John was right now we're on a run rate of only 10% of networks being O-RAN compliant by 2025, halfway through the decade. And this really has to do with incumbency, maturity, and continuing development costs, I think. Networks cost billions of dollars to roll out. They take a decade to roll out, and they are kept for at least 2 decades. And so an incumbency position is incredibly powerful and keeps people within this sort of ecosystem. The other challenge that people have is that the standard being not quite the standard, sort of this breaking up of the standard so that you don't truly have interoperability. And I think for that to be successful, we will have to have, I'll call it plug fests. We'll have to have system integrators in ways that we haven't had before, the likes of IBM and Dell on this call, in a way of de-risking the situation for the operators or the network owners in general, because they're going to be both operators that sell to others as well as folks who run networks for themselves. I think that in order to be successful, governments can do a couple of things. They can put their money where their mouth is. So as was discussed earlier, we can have federal agencies, we can have dollars that are taxpayer dollars required to be part of an O-RAN compliant network to sort of start this cycle going. The second thing that the government could do is offer investment credits, de-risk the risk of developing all of these various pieces to jumpstart the ecosystem as a whole, from very small companies to larger companies. Because it's a very expensive proposition to develop a lot of this, and if you're going to have relatively small market share for years, that makes it challenging to have the return on investment that you need. I think that other countries will typically do the same thing. They can support open R&D investments and encourage the adoption of Open RAN compliant networks in their jurisdictions, like we've seen in Japan, like we're likely to see in India and other places in Europe, along with the US. And I think that I'd make O-RAN analogous to the free market and the promotion of the free market. Each country can stimulate this free market, this O-RAN, slightly differently, as long as everybody is working toward that common goal of a level playing field. And what we've seen with the free market, and I expect to see here, is extraordinary results as long as that playing field remains open, because you can create an ecosystem that is better than any type of monolithic ecosystem that can exist.
Thank you. You know, it's interesting because a lot of the time at the FCC, we hear people say, government, keep out of our business. And what you have described is a little bit of tension, because you're saying take a more proactive role, but also step back. And so I'm just, is there consensus on the panel about this?
If I could just add on that, if I could just add one thing before you put it the rest of the panel. I think that's because the playing field is not level with a variety of companies or countries supporting specific vendors. If no one was supporting anybody, I would totally say your former case, stay out in effect.
Cristiano.
Yeah, I would add to that. This is Soma here. So what I would definitely agree that, you know, the FCC needs to take, or government needs to take a more active role. One, it's a strategic industry. It's just not any industry, right? This is a fabric of the next industrial revolution. Everything that we do is going to be connected. So it is a strategic industry. And the second thing is, you know, spectrum is a national asset. Whether we like it or not, government is already involved. It's a national asset, and we want to make sure that it's utilized to the best. So one of my wish is that if FCC and the government would have an incentive tied to the spectrum saying that if you want to have these spectrums, either you get credit for using O-RAN or some kind of alignment and incentives, because it's not a level playing field, as Kurt was saying. You're actually against a 40-year-old industry, 40-year-old incumbency, and you need to help get over that hump. But once we are there, I mean, ecosystem is hard to beat, but it's also hard to create.
Cristiano.
Yes, no, I like to, this is an excellent, I think, conversation, and I like to make a few points, and I think it's consistent. I think some of the conversations, I think that John mentioned, and also, this issue about, was discussed about having a system that is consistent. And governments can play a very important role. This is a different thing than building, a new consumer electronics device, right? So the nature of the telecom network is no different than the power grid. And more important than ever, 5G is actually enable a lot of mission critical capabilities. So we need to look at the following way, especially to drive investment to the sector and for the companies, the key public operators, they have to operate a network. So I think we do this in two ways. One, private deployment of 5G vRAN, that can happen. It's already happening. It can proliferate to the enterprise, no different than the enterprise building its own PBX and Wi-Fi access point, and drive a lot of cases. We can start with that right now. And then government should put a milestone and seek alliance in about a number of countries. They have the same vision, and in the process of upgrading their telecom infrastructure, whether the United States, the UK, other European countries, the Japan, Korea, and many that align with this view, to put a milestone that will drive the operators to specify the system that is going, or the platforms that is going to enable those open interfaces. And the risk of doing it prematurely, if you want to do it like today, the risk is you end up with a non-compliant Open RAN. And you start, because those ecosystems take time to develop. So the way we look, usually if you want to change that stat to have more than 10% of all base stations and radio units with Open RAN and vRAN, capabilities in 2025, I think when you start thinking about as soon as 2023, it's to basically drive requirements and timelines and incentives for the public operators to specify right now, as they get RFP outs, their next generation infrastructure that will come in with, and then with all the right interfaces, and that get done by the tier one global operators in an organized and harmonized way. And governments can play a very important role aligning that timeline and driving the requirements, because then, as John outlined, you're going to create a huge ecosystem that's going to be investing towards 2021, 22, started to launch those systems in 23. There's going to be a lot of exit opportunities for a lot of startup companies to build all the pieces together, and then you have the major operators in the world driving this. If we don't do this in an organized manner, I think we can start with a very fast innovation now in the private sector and private 5G networks. That's going to be incredible starting right now. But then we need to use this as a subsidy to drive the next generation networks, and then we're going to end up with a true, the private sector is very good about doing standards like the 5G standard is a great example. We're going to end up with a true Open RAN, even RAN innovation. So very important, I think, to have that coordination and to drive that, because this industry is like the energy sector. The airplane is flying, and you have to do this changes midair. So and we can get there by acting in that way.
Go ahead. Yes.
Cristiano, I think that's a fantastic timeline. I honestly think, even 2023 it's probably the fastest you could do, but it's going to be challenging. What we haven't discussed today is the wide range of companies who are starting to deploy non-terrestrial networks, including low Earth orbit satellites and another variety. The need to get those into the Open RAN infrastructure is imminent. And again, usually people talk about Open RAN within the traditional wireless network, but the excitement around non-terrestrial networks is quite palpable in our industry.
Cristiano, would you agree? You know, one of the things I noticed your focus was on working with the major national network carriers, but we've been making a lot of spectrum available at the FCC that analysts say could be used by private networks or for Internet of Things. Is there a role there for pushing O-RAN principles, or is that really too sliced, as you might say, to make it a relevant force?
No, absolutely. It is happening right now. And I think that's what is going to drive a lot of the development and innovation, as I said in the prior comment, which will then enable this technology to be, mature for a major shift of the tier one operators to their next generation Open RAN. And I think the key to that technology development is to accelerate into private networks right now. I think, governments around the world are making spectrum available for private users. I think the FCC has done a great job with the CBRS spectrum. I think we have, the PAL, the GAA, and those are going to enable private deployments. And private deployments is very important because actually it's the true promise of 5G. For digital transformation of enterprises. It's easy to see, when the pandemic, happened, we all went home and started to get connected to like Teams we're doing right now. And we're very fortunate in our company because we drink our own Kool-Aid, but many other companies realize a lot of their assets, other than people, were not connected. And it's accelerating digital transformation for you to connect everything. And that happens as you bring 5G to the enterprise. I'll give you a very simple example. If we're doing Teams right now and people are collaborating in OneDrive and you don't have access to your papers, right? You're starting to see more and more that the hard drives move into the cloud, the IT infrastructure entirely is moving to the cloud. You're connected 100% of the time. You don't have access to workstation. You use a high bandwidth to do that on the cloud, so we're gonna see 5G going not only to a manufacturing robots, but to the enterprise in itself. And that it's going to happen to private networks and spectrum available for those private deployments.
Thank you. Mariam, are you just gesturing?
Oh, sure. Sorry. No, I could add to that. I mean, I think I completely agree. That's my earlier point, that networks need to be looked at beyond just what we're calling 5G today, whether it's the satellite, whether it's the wired network, it's an end-to-end. I mean, look, so I've been a fan of Open RAN and virtualized RAN since the early days. I just want to note that when I came to CableLabs a year ago, I could tell you that the first thing I realized that CableLabs has been at the forefront of developing multiple generations of open and interoperable communication. So this is not a first. Okay, it's just a first maybe for RAN. The core network was done before. So we've done this before, and we know that Open RAN is not only possible, but it's also an evolution of the radio access network. So I just wanted to mention that every innovation is going to have its early stage. This has its early stages, but it will definitely happen. And we need to look at a broader view of how these open and interoperable infrastructures and specifications will help the entire communication system.
Thank you. Diane, we've been talking about, John, would you like to follow up on that point?
Yeah, just one, maybe snarky point. Not only have we done this before, but the telecommunications wireless industry is the last one we haven't done it to. We have done this to compute, to storage, to networking, to virtualization, to application delivery, to software development. The one that's the outlier that isn't in this modern format is telecom. It is things like wireless. So not only have we done it, but if we didn't do it, this would continue to be an anomaly. And so it's very likely we've figured out how to do this, and we will do it. And then we'll have what I describe as wireless as a first-class citizen of the cloud era, which it is not today.
That wasn't too snarky.
Yeah, well, some people might do it that way.
Diana, so we've talked about all the positive things. I wonder whether you have a sense of the things that we would lose out on if we don't promote O-RAN and move in that direction.
Sure, and I think the one theme that we hear time and time again is we're jumping to that next generation of networks. It's the optimization, it's the customization, it's the things we haven't even thought of yet. whether you're building out a network in New York City or my small hometown of Rumford, Maine, which is population 5,000, you really need a network that's going to be best for the customer base. And that's what we're talking about here. We're talking about opening things up, driving competition, driving innovation. We are taking a leap ahead. And just to go back to your last question about how governments and the private sector can work together, that's why the coalition came together. We came together to promote policies and initiatives that help take that next step, whether it be public-private partnerships, research and development money, or education events such as these that helps bring together a wide swath of the private sector to discuss what they're doing in this space and how they're taking networks to the next level.
Go ahead. Yeah, if I could add to that, I think that if this is not done, we're missing this giant opportunity. The next generation of wireless is all about efficiency. It's driving down the cost per bit per area, if you like, covered. And without driving that down, all of those use cases that we have that we can consider today, or the things that we might not have considered yet, simply won't exist. I think this is necessary beyond what we're thinking about today. I mean, can you imagine 20 years ago if we would have thought everybody would have been streaming today, and all of the opportunities for additional channels like the one we're on today being available, this sort of democratization of, I'll call it, television content. We have so many things that get enabled by an opportunity to innovate and an opportunity to really take an ecosystem that was closed and fairly slow moving and create a very, very fast moving ecosystem. I just think it's an absolute necessity to happen if we want to enable what the future of wireless is going to be.
Soma, you had a point?
Yes, I do. It's not just about cost and efficiency. I think it's really the new innovation that's going to open up. I call it, this is the iPhone moment of cellular networks, right? We are just about to cross over. I mean, just imagine the things we can do with all the things in the iPhone, and the same thing we could do with the networks. And when you say what would we lose out, I believe that AI is the next industrial revolution. I think everybody agrees to that. This is about national productivity. How could you have a car factory being highly optimized? You do not have to outsource jobs. When you have AI, you do not have to outsource call centers outside the US. And bringing all AI and 5G is going to work hand in hand. This whole next level of productivity and automation is very dependent on AI and 5G. So that's why I think, it's not just about the next level of connectivity, it's actually the next industrial revolution really depends on AI and 5G. So that's why we really have to take a proactive approach in this.
Thank you. So go ahead.
Just to pick up on Soma's point there, we heard an example this morning from Tariq of what AI was able to do with some spectrum efficiencies. But if you start to see how AI could be sprinkled into all the different components along the end-to-end solution, we barely touched the surface of what AI is capable of doing in every one of these components. So if we miss out on that opportunity, it will be expensive, and it will be less efficient, and frankly, we won't realize the sort of potential that so many of us are looking forward to from this.
So this is a great way to end our conversation. We're almost out of time, and as a lightning round to conclude this panel, I wanted to ask, as it's an all-play opportunity, what are the top potential innovations that each of you see resulting from O-RAN? Go ahead.
You want me to go first? I'll go first. So I talked about convergence, earlier. Now, what does that do? It solves both practical and interesting use cases as I was sitting here and talking to you guys and realizing what's happening. So the practical problem is around the seamless user experience. Simply, if I can take this call from my desktop right now, transfer it to my mobile device seamlessly so I can run upstairs and tell my kindergartner who's sitting through a virtual class once again how to unmute her audio and seamlessly come back down here and talk to you guys, right? That's the practical solutions, not very in anything fancy. But it will also, this convergence will also enable the future of things like we talked about today, autonomous vehicles, which require ultra reliability, AR and VR, which require end-to-end low latency. That's what excites me about it.
John, you had something.
Yeah, there's all the normal ones, but the one I'm excited about is this idea of collaborative compute. As we smartify the world, as we make devices intelligent, they have finite power and finite compute capacity. And they, in order to do just spectacular things, they need access to abundant resources. Today, those abundant resources are somewhere else. They're often public clouds far away and out of the real-time boundary. But as we build out edge environments, as we build cellular environments that have mobile edge compute and other capabilities, and more importantly, are open, that we can innovate in that ecosystem and add functionality to the network that is literally within 1 to 5 milliseconds of the compute device, we can do things like have collections of cars and roads work together to see around corners, to do smart agriculture where backhaul isn't the problem because the AI engine is actually in the cell site near the devices. All of these things are exciting. I mean, we're the largest provider of compute devices in the world, I think, today. And we're excited about this idea that if we have this kind of network innovation going on, and we can land compute close to all of those devices, they can exceed their raw potential in really interesting, innovative ways. And so, that is a super high demanding requirement, but it's super important for the 5G environment to be a party of that ecosystem, not an independent ecosystem.
Peter, Morgan, and then maybe who else? We'll see who else has it.
Yeah, I'll start by saying, obviously, the Industry 4.0 is one of the things in the semi industry we see as a tremendous opportunity for 5G and Open RAN and 6G beyond it. Already our demos in the clean rooms with operators using AR goggles to completely free up their hands and service equipment. It's unbelievable what you can do, and the opportunity to bring manufacturing back to the US as you put more intelligence onto the factory floor. That said, I'll quote the previous chairman of the FCC, Tom Wheeler, who said, really our goal is to deploy an agile, fast, and low latency network. No one envisioned Uber when 4G was being deployed. I think the opportunities are going to be in places where we can't even imagine it. Once you put this kind of flexibility in the hands of app developers, software developers, and hardware developers.
Thank you, Morgan.
So I'll bring it a little bit closer and then go far out. I think this is an opportunity to help close the digital divide, making these systems available to you wherever you are, whenever you are. And in a more future sense, and it kind of ties in with where you are in creating an environment. And I say this not just because I love Star Trek and my last name is Kirk, but I think there's a step well beyond, a VR or an AR goggle to light fields, to hollow rooms, to things that we haven't invented yet today, but will fundamentally change the way we work and interact with each other and collaborate, not just within the wireless industry, but across all industries in new and meaningful ways, specifically when we are geographically separated, as we are, in fact, in these times.
Thank you, Cristiano.
Yeah, I would like to answer that question maybe with a different angle, right? I think there's an incredible amount of new services, opportunities, and some yet to be invented with 5G. When we develop a technology like 5G, we know it has to last a decade at least, and there's going to be huge potential for innovation. What I'm going to answer your question is, we saw that a lot of innovation came to the telecom space in many cases to applications. And I feel that what's going to happen with Open RAN, it's an opportunity back for the telecom sector and the telecom players to innovate. What the thing that Open RAN will do on innovation, it will change how development is done. So it will change the paradigm shift from having maybe one software release per year that all features get prioritized by the vendors. And then once you finally get the feature, you cannot commercialize because the billing system doesn't support it, right? That's what happens in the telecom sector today. And Open RAN is going to change that. Open RAN and vRAN is going to change that and allow innovation to happen, like it happens on the cloud, how it happened on PCs and smartphones. And that great news, I think, for the telecom sector, and all of those features and the full potential and the vision of 5G will be able to be realized.
Yes, sir. Soma.
So I would end with saying 4G was about smartphones, cloud computing, and and of course 4G connectivity, mobile broadband. 5G is about IoT. It's not just smartphone, but smart everything. Your smart cars, your smart factories and smart robots, but not smart everything, 5G connectivity and AI. So these three things, as previously John said, the whole ecosystem is going to take it to the next level of productivity and automation.
So I'd like to, we're cutting into your lunchtime, and I'm conscious of that. Thank you all for a very stimulating and exciting panel discussion. Appreciate all of your input. Now I'd like to turn it over back to Evan to conclude. Thank you all very much.
Thank you.
Thank you.
Thanks, Charles.
Thank you. Thank you.
Well, thank you all for participating in what was a fascinating panel. I didn't think I could be any more excited about this technology than I already was, but you have all achieved that. So you have at least one fan here. So please enjoy your lunch. I hope it's a physical lunch and not a virtual lunch. This is one thing that we should not virtualize, which is food. And there's your dad joke for the day. At 1:40 p.m., we will have another fantastic panel, lessons from the field. Where do we go from here? We'll hear from operators who are currently deploying this technology in the field and what they've learned and how we can take those lessons going forward. And that panel will be moderated by Chairman Pai, and it will begin with opening remarks from Commissioner O'Reilly. Thank you all.
Welcome back, everybody, to the FCC's 5G Open Radio Access Network Forum. We've had a great series of panelists and speakers already today, and we're kickstarting the post-lunch speaker series with another series of panels. I want to start off by recognizing my friend and colleague, Commissioner Mike O'Reilly, for some remarks about this topic. Mike, the floor is yours.
Good afternoon. Many thanks to Chairman Pai for establishing this forum and for inviting me to provide a few comments ahead of the next exciting panel of experts. This has been a fascinating discussion so far, and I've no doubt this upcoming group will provide further insight into the important technological innovation. When the pandemic disrupted the original plan for this forum and the suggestion was made to convert it to an online event, I enthusiastically welcomed the move. Nowadays, there are few, if any, commission functions that must be done in person. I hope future commissions readily embrace this reality and cut back on forcing people to travel to the new headquarters for each of these opportunities. As a technology-centric agency, it is imperative that the FCC reside on the leading edge of technology. Technology adoption starts at home, and maximizing our own use of advanced communications will lead to more sound policy outcomes. Turning to the topic at hand, there should be little doubt about the importance of wireless communications and devices in today's society, both for consumers and businesses. Almost every American uses and interacts with wireless services in one form or another in their daily lives. The question becomes whether these wireless communications, especially those prevalent in the envisioned future of 5G licensed services, are sufficiently protected from certain nation states, rogue organizations, troubled individuals, or a combination thereof, each of which may be intending to engage in nefarious or harmful activities against Americans and the rest of the world. The advent of Open RAN provides one path of potentially minimizing exposure points. In its simplest conceptual terms, Open RAN can be considered analogous to secure interoperability. By breaking wireless networks into components and moving away from end-to-end product lines, overall security can actually be improved. Whether it is reducing reliance on foreign manufacturing or providing incentives to harden physical infrastructure and protecting corresponding software from intrusions, Open RAN can reduce threats to overall network security if done properly and give users the necessary confidence to transmit even the most sensitive data at any time and from any location. Let me lay down 3 conditions that I believe are essential to ensure the success of Open RAN. First, it must be done without any technological mandates imposed by the US government or any other government or intergovernmental body for that matter. The FCC and certainly other government entities lack the capabilities and requisite knowledge to impose specific network design requirements or other such directives on the private sector. This point has been proven time and time again, but bears repeating here. Second, we must maintain vendor neutrality. That means no single company or select set of companies should be blessed or favored by the government over others that provide similar functionality. We must not pick winners and losers, especially since doing so can stymie the advancement of ideas and innovation. Third, and related to the first 2, the process must remain voluntary. Certain companies may have nuanced views of how to develop and implement the new technology, and they should be permitted to proceed as they see fit. The market will sift the best ideas and ultimately determine which approaches work best. With that said, I want to extend my thanks to all the expert panels and express my appreciation for being part of what is truly the best panel of the day. Over the next 70 minutes, panelists will explore various ideas and discuss the current state of the marketplace and what is being done in the field. The discussion will likely examine the practical experiences and case studies of equipment manufacturers and software providers in the development and advancement of Open RAN. What is being done today? What have been the most significant successes and failures? What are the major obstacles going forward? And what does this mean for the future of Open RAN? I thank everyone for their attention, and I turn the floor back over to Chairman Pai.
Well, thank you very much, Commissioner, for your remarks and for framing the focus of the next panel, which is indeed lessons from the field. We've talked already about an introduction to O-RAN. We then moved to what some of the potential benefits were. And now we're going to move to, ideally, to some of the practical. What are some of the benefits that companies here and abroad are seeing in terms of the deployment of O-RAN technologies? And to help illuminate that topic, we've got a truly incredible and broad subset of speakers. In alphabetical order, we start with John Baker, who's the Senior Vice President of Business Development at Mavenir. We also have Lori Bigler, the Assistant Vice President of Access Analytics and Systems at AT&T. We've got Stephen Bai, who is the Executive Vice President and Chief Commercial Officer at Dish. We've got Marie-Paul Odini, a Research Director at HPE. Matthew Oomen, who's joining us as the President of Reliance Jio. Steve Papa, the Co-Founder, Chairman, and CEO of Parallel Wireless. And last but certainly not least, Marcus Weldon, the Corporate Chief Technology Officer and President of Nokia Bell Labs. Thanks to each of you for taking the time to speak with us today about these important issues. And I thought I'd kick it off with Matthew. Obviously, Reliance Jio has done some incredible things in India to dramatically disrupt the wireless ecosystem. And arguably, nothing has been more interesting and more pertinent, of course, to our deliberations today than what you have done in the virtual or open radio access network space. India, of course, being a very vast country with both densely populated urban areas and sparsely populated rural areas, similar to the United States. And so I thought I'd turn to you to see, was virtualizing the network a challenge for you in both urban and rural environments? Why did Jio choose the standard, and what have you learned in the process of deploying this new network architecture?
Well, thank you very much for having Jio. Thank you very much. It's a privilege to have myself here. It's always a pleasure, Chairman Pai, to hear from you, as I would say you continue to push the ecosystem to a path that is unlike the traditional, if you will. And when we hear ourselves talk about open, O-RAN, Open RAN, I think each one of us have our strong perspectives, if you will, of what these are, where this is, and how and what is the right approach to deliver towards operationalization. Now, I think it is important to get to a common reference definition. Very important to get to one standard that is clearly interoperable, because we have TIP, GSMA, O-RAN, Open RAN, like I said, many different formats. Now, having said that, when you look at Jio, everything that Jio has done and will continue to do, in my opinion, will be certainly unorthodox. What I mean by that is, the whole world is talking about open, and I am not yet sure of any other network yet, I would say. And I know it could sound a tall statement. That is all IP and all VoLTE and all IP version 6 anywhere else on the planet. And why I say this is important, because without all VoLTE, and when I say all VoLTE, it is not about downloading an application onto a phone. This is natively available, right? So that means VoLTE evolves to 5G VoNR, right? So that's a fundamental building block. And you need all IP for interoperability. And you need IP version 6 for its embedded security. And I believe these are essential and critical building blocks. Now, in terms of where we were or where we are in terms of delivering not just the lowest cost per GB or lowest bit per cost for any other LTE network, if you will, from a cost per GB, but we also believe we have the most economically viable GB because we are delivering it at about 44% EBITDA, which I think is pretty good in the industry. And when we launched our network, Chairman Pai, we launched it in one city. Just that one city happened to be India, the whole of India. And we looked at it from the whole of whether it was not about rural to dense urban or metro or neither metro to rural. It was all across because we believed in an inclusive India and an inclusive launch. And when we did that, of course, there are performance metrics, intersite distance issues, right-of-way issues, et cetera, that need to be done differently for each each area, as well as from a morphology perspectives, et cetera. But the biggest urban challenge, in my opinion, continues to be ROW and site acquisition.
Yeah.
And how did we resolve that? We were doing 780 sites per day. The only way we could do that per day, and the only way we could do that in a democracy, it is not the easiest to bring a site up, right? And so when we did that, we built our own ground-based mass. Why I say ground-based mass is very important, or technology to have your own efficient and effective infrastructure. And the reason is because that you need to make sure that when you implement massive MIMO, because without massive MIMO, O-RAN does not give you the benefit that you need, right? Especially from a G-Node-B perspective. So massive MIMO is important. The utility cost is important. So having the right utility solution, whether it's Manhattan to Mumbai to Kashmir, right? You need the cost of utility power is very similar. So a low-cost infrastructure and a very highly efficient backhaul/friend haul is also important. So without the right wireline or without the right backhaul, 5G, along with the low-cost infrastructure, I think it's very important. One more point I would add as a challenge, as well as an opportunity, is handsets. We knew handset was a very critical component, especially when you go to the rural market. So we solved that problem when the world told us the lowest handset we could get into the market was $84. We came up with a $22 handset, and today it's more than 105 million of that single SKU. Similarly, I think in the 5G ecosystem, it is not just about the O-RAN from a network, but we also need to push hard in terms of getting the device ecosystem, not just from a cost effectiveness, but the type of devices as well.
That's terrific. No, thank you for that background and for your vision. Certainly in terms of inclusiveness and reach, that is something that we share here in the United States. And speaking of vision, I thought I would turn to Stephen Bye at DISH. Obviously, DISH has been very involved in the O-RAN space up to and leading up to today, and including today, as a matter of fact. And I was wondering if you could speak about how O-RAN informs DISH's vision for becoming a wireless competitor in the space, and what lessons learned from building a standalone network have you learned thus far, and do you expect to learn into the future?
Yeah, thank you, Chairman Pai, for the opportunity to be part of this forum and your questions. As you know, we're very excited at DISH to now be in the wireless business with the acquisition of Boost. So, we've talked a lot about being in wireless for a while, but now we're in the business. And as you know, we're committed to building a greenfield nationwide network, that's cloud native and 5G, but based on O-RAN capabilities. And we're well underway towards meeting that build out obligation. So, very excited to be here and very excited to be part of this panel. When we look at sort of O-RAN and the innovation around O-RAN, we think it's important, but it's, really only one step. And I think, from the earlier sessions as well, what's really important is the openness. It's an open ecosystem, which we think, unlocks the potential for US vendors and US technology companies to innovate around an open architecture and open platform. So we think that's really, really important. And I think Commissioner Carr's comments about the analogy to the PC industry is very important. And there's a lot of lessons we can look back on as we look at the opportunity going forward. And for us, it really starts with 5G. 5G is a great platform, and O-RAN is part of that. Fortunately, we're in a position where we don't have any legacy. We don't have 3G. We don't have 4G. In fact, we don't even have, sort of antiquated OSS and BSS systems that we're having to sort of retrofit into this architecture. So, we look at this as a tremendous opportunity. And, with O-RAN comes virtualization, the disaggregation of the hardware and the software. But really, I think, a lot of things that we see unfolding around sort of cloud native networking are really vital to unlocking the potential that O-RAN provides. So to us, O-RAN's an important step, but one step. And it's really sort of this cloud native capability in the open environment that really is important. And, timing's everything. We're coming into this environment where we're building a network, being able to take advantage of all the great work that's been done to date to get us to this point. So, we're combining all of these capabilities to do something very unique at DISH. And I think, with this platform, it's going to unlock a lot of innovation going forward. I think when, you talk about lessons, I think there's probably 3 lessons that I'd touch on. And there's a lot of talk about integration and interoperability. And I think, one of the challenges with any network is every network has multiple vendors. Whether you start with the antenna, through the cabling, through the radios, transport with, which Matthew touched on, in terms of switching, routing, core, OSS, BSS. There's no network that is one vendor. It's always a combination of many different vendors and many, many different partners. And integration is just part of the job that we do. That's part of what we do as a network provider and a service provider, is to integrate all those components together. And when we look at O-RAN, there's really nothing that makes that any more challenging than the work that we undertake every day as we integrate all these systems. And in fact, one of the things I would say is the architecture with O-RAN and an open platform actually gives us much better visibility and transparency into the entire stack, into each of the components. And we're seeing that as we do all our testing today, is that it really allows us to drill in and understand what's going on and where those pain points are when it comes to integration. So I actually, I see it as a tremendous opportunity to integrate more effectively than we have done in the past. And I think one of the things that I think is also unique, and the opportunity comes with the open architecture, is that we've really gone from sort of closed systems to an open system. And that allows us to tap into a workforce and skill set that has a lot more software talent, that can bring that software expertise from other industries and bring it into the network and the telecom space, which I think is fantastic. And it really allows us to tap into resources and a talent pool that is less reliant on sort of what I consider sort of unique system certified resources that have the secret keys. So, we're able to tap in and I think actually even develop a much more technically proficient workforce as well, which I think is exciting. The second lesson I would say is around security. There's always security challenges with any network. And we've taken sort of a zero trust model. And I think, as Secretary Pompeo pointed out, the real focus on a clean network is vital. And I think there's so many tools and capabilities that we can bring to this open environment that come out of other platforms that are now accessible and available into the telco environment or the wireless environment. So I think we're able to leverage that in a much better way than we were in the past. And it's always easy, or easier, I think, in an open environment to use those tools than a closed or vertically integrated system. And, I like to say it's a lot easier to find the cockroaches when the lights are on than fumbling around in the dark trying to find something. And, that to me is sort of the tremendous opportunity that comes with an open environment with the security architecture. And then the third lesson I would say is teamwork. everything we do is tough. Building these networks, is a challenge. There's no easy button, and having the best team and the right partners is absolutely essential. And those partners who share in that vision, who are committed to open, are really the partners we're working with. And, we've announced a number of those to date, but they share in the vision of the future, and they share in a vision of this open platform that we believe really unlocks a lot of innovation.
Well, thanks to you and to Matthew for those comments. And as you were talking, it reminded me of a very interesting post by Ben Thompson of Stratechery. I think it's titled something like India, Geo, and the Four Internets. And it talks about, in particular, the opportunities for scalable, agile, all IP, ORAN-based infrastructure. And so certainly commended to those who are watching. If you have time, certainly read it. And it gives you a hint of where companies like Reliance and Dish might be heading in terms of their vision for the future. If I might, let me turn to John and ask, what can we learn from Mavenir's deployments, and in particular in Europe, and to what extent do you think those deployments, the lessons from those deployments are transferable to the US market?
Yeah, thanks, Chairman Pai. It's a privilege to be here and such an honor to be amongst this team of panelists. So great wealth of experience. So just let me start off. I think there's been a lot of discussion on Open RAN, and we see sort of Open RAN as somewhat the correction of the standardization process that took place over the last 10 plus years, and really it's all about open interfaces, but full specifications that allow product to be developed. And when we talk about open interfaces, I think there's a couple of other interfaces in the network that should be open in the same time, and it goes under the guise of the X interfaces. But one of the things that we've seen, and there was some discussion this morning about brownfield versus greenfield, that unless you also get the X interfaces open such that GNOBs can talk with each other, and avoiding the hard handoff or the drop call issues, then you still got issues that need to be addressed. And I think we see it that the operator shouldn't be having to pay for standardized interfaces to be open. So there's some issues around some of that. But and as we've gone into Europe, we've really been in this brownfield, greenfield discussion, and because of these other interfaces that are already fully standardized, but being priced, if you like, into a contractual negotiation, makes it very hard for operators to say, I'm going to mix and match vendors in the same physical area effectively. So so that becomes one of the challenges. And then they look at greenfield rural areas or dense urban areas, but you've got to build a big area to sort of put these pieces together because of this X interface issue. Mavenir has been a 15-year-old company. It's been pioneering and disrupting the mobile marketplace with essentially virtualized systems from day one. Pardeep Kohli had the vision, and on IMS, core type products, we compete and we carry a very large amount of traffic. So virtualization is not new to the industry, and what it is, but it's coming new to the RAN, and that's really where Mavenir is now focused in taking that vision of a disrupted virtualized network into the RAN, and that's what we've been deploying now, probably on every continent in the world, actually. You've seen the announcements of Vodafone in the UK. We've got a live network there now. Excited to be a supplier to Dish in terms of the rollout in the US, which will be the largest Open RAN network, in the world actually at the time. Been looking forward to that success. But in reality, there's no different to how we deploy in Europe, to how we deploy in the US, to how we deploy in Japan or Australia. It's the same principles, but it's how do you make this thing easier, cheaper, faster, in terms of deploying those elements. And what we've seen by using open interfaces and disaggregated hardware, that you can do that very quickly. The supply chain times really shortened to the extent that I can buy computers off the shelf, I can ship my software, and provided I've got the radio piece sorted, then we can build these networks very quickly. Now, talking about the radio, we've been doing some things for the European market in terms of getting radio vendors that are essentially open interface ready. And I think at the last count, there's like 19 radio vendors coming to market with radio products. Now that's exciting. Open RAN has suddenly, gone from essentially 2 or 4 to 19. So, you can see people are really, buying into the vision of, I've got a market opportunity, I'm going to invest. We've also been working with, Facebook TIP on the Evenstar radio project for Europe. Bringing along low-cost radios, which are just going into market trials now for the European frequency band. Now, you bring that back to the US. The radio side is very, very different. It's tougher to get US banded radios for the US market, and I think we've even partnered with our competitors, Altiostar, in this area to generate a portfolio of radios, which, between us, we're going to make available to the Open RAN community in the United States. So, in summary, it's sort of all about execution, supply chain, and having that wealth of vendors with you to help integrate these products. But, from an experience perspective, it's the same in Europe to the US to Australia to Rakuten. But, software integration, cell site integration, and an acquisition of cell sites really is probably the toughest pieces in here. The technology, I think, we understand it, can make it happen, but, it's all about the end-to-end process of system integration.
Well, terrific. And before I move to the next question for Steve, apologies for those of you who heard a couple of kids in the background. You might say I have my own native open radio access networks here in the house, so you might hear them from time to time. Steve, if I might turn to you, your company's also done deployments here and abroad, South America, Africa, even here in rural America. And could you discuss what you see as the role of ORAN in developing environments as well as rural areas? And in particular, is there something of a leapfrogging effect where an area that might be on 2G or 3G or even no Gs is able to leapfrog to the most current, most agile state of network architecture?
Chairman Pai, thank you very much for hosting this. It's a pleasure to be here, and thank you for that question. I happen to have a lot of direct experience with this. I'm sitting at the end of my driveway in rural New England with my 500 kilobit uplink DSL connection, so I'm well aware of the rural connectivity problem. The way to think of rural and 5G are the same problem. It's connecting ever smaller numbers of users with ever increasing cost to deploy and operate equipment. In that sense, they're identical, okay? So if you're gonna serve urban areas with smaller and smaller populations, right, because you have denser cells, it's the same as rural, where you're serving fewer people, okay? And absolutely, yes, Open RAN holds the key to accelerating a global 5G rollout. And that key, though, is through innovation. I want to bring up one slide that Evan has for me, which to make a point that the key leverage point in driving out cost, it turns out, is cost-effective energy efficiency for the cellular network, for the equipment in the cellular network. So you heard Matthew talk about massive MIMO being essential for 5G. You heard John talking about the challenge of radio, okay? Well, it turns out the radio is where the rubber meets the road because it influences all these other costs. When we're doing deployments, if you look here at the CapEx and the equipment, okay, spectrum certainly appears to be very big. Well, massive MIMO, cost-effective massive MIMO is what gives you leverage on spectrum. You can get a 5x capacity, spectral utilization from that, right? You look here, the things like the site itself, the steel on the site. You need more steel if you have heavier, less energy efficient equipment. You need bigger copper conductors that create more wind load on a steel structure. You need bigger batteries, bigger backup generators, bigger cranes to deploy. The biggest leverage point is cost-effective, energy-efficient active antennas, right? You need more, the way you choose to build your sites gets influenced by the cost of the equipment. So if you go to the next slide, another way to see this is all the things influenced by cost-effective energy efficiency. It's virtually everything in deploying a site, okay? Now where Open RAN comes in when you have closed interfaces, the vertically integrated vendors aren't particularly motivated to push the envelope here. Right? In fact, the reason why Nokia and Ericsson have struggled to compete with Huawei globally is Huawei took the TCO and energy efficiency seriously, and Nokia and Ericsson were way behind on that. They're just now starting to catch up, okay? But that brings me to my second point. If Nokia and Ericsson struggle to build cost-effective, energy-efficient radios, I mean, I've spoken to Eastern European operators that benchmarked an existing vendor's equipment with Huawei's and found the energy efficiency savings alone would pay for the Huawei equipment in 5 years, right? So if the big guys struggle to do that, how can small companies have a shot, okay? But what's interesting, what's happening is because Open RAN has opened the interface, the number of innovators out there that see the opportunity to come together in what I would call a virtual Apollo project, right? To how do we double the energy efficiency of this equipment, which fundamentally changes the cost equation, right? Whether it's getting energy to the site, the weight, you name it. That's what I'm seeing going on. That's where the real promise from O-RAN is going to deliver a material difference in rural connectivity, developing markets, and where we leapfrog the 5G. I was on the phone with another developing country with their folks planning for 5G. This is a country with one of the most expensive electricity rates in the world. And what I said to them is, unless there is more energy efficiency in this equipment, there is no 5G for you other than a marketing version of 5G where we just change the number from 4 to 5 on your handset and deploy 4x4 MIMO on, the existing spectrum. 5G is active antennas. Matthew said it well. And you don't get that without energy efficiency, especially in markets with low ARPUs and really expensive electric rates. So that's the opportunity, is to have that Apollo project to change the game in radio. Radio is the tail that wags the dog of wireless networks. Thank you.
Thank you. That's fascinating. And I can assure you, we will be on the case to make sure that you and your neighbors have adequate broadband to be able to do everything that you need to do. We're on the case. So let me turn to Lori for a moment at AT&T. And obviously, you have a lot of experience as well with both existing deployments and thinking about future deployments. Let me ask you about what you see the current deployments saying in terms of some of the scalability and options and barriers to adoption for O-RAN. In particular, would something like access to fiber for backhaul be a limiting factor for O-RAN deployments? And how do you see that entire ecosystem evolving?
Thanks, Chairman Pai. I'm so honored to be here on such an esteemed panel. First of all, AT&T is very proud. We are one of the founding members of the O-RAN Alliance. We've been helping to drive the open architecture, the specification of open interfaces, working with both the operator and the vendor community. The challenge really for an operator like AT&T, really with any network architecture, is ensuring the reliability, the integrity, and the performance for our customers. So this isn't unique to O-RAN. As we introduce O-RAN into our network, the key consideration will be whether we can continue to achieve the same level of performance at scale that we have over our current with our current 170 million mobile subscribers and connections. So we are actively working in this direction. O-RAN is still developing specifications at this time, and some are further along. Others are still in the early stages of development. But having the specs alone does not guarantee interoperability or performance. So we really see that integration is the biggest challenge ahead. You really don't find the issues or gaps with the specs until you actually try to integrate two vendors' equipment together. So that I think the O-RAN ecosystem has recognized that really from the very start. The O-RAN specs include both interface specs, but they also include testing and integration specs. And there's a test and integration focus group that provides an overall framework. It also supports O-RAN PlugFest, which provides facilities and mechanisms that can encourage and really drive that inner working between the vendors. One interface that we see that's further along in development is the open front haul specification. That's between the radio unit and the baseband. there's just been a tremendous amount of work done on both the open interface spec as well as all the test and integration specs. We've been contributing to that. We've also done some significant, some limited trials of our near real-time RIC controller on our millimeter wave network in New York. We've demonstrated that we can have a RIC working and communicating in a field environment with external applications. But there is considerably more work to do to fully validate those interfaces and to implement them at scale. So we're likely to see a more gradual introduction of Open RAN into our existing network, and in particular, just depending upon the development around the front haul interface, which is something AT&T has been working towards.
Well, terrific. Appreciate those comments. And speaking of vendors, let me turn to Marcus. There have been some who have argued that the development and deployment of O-RAN related technologies might harm the incumbent vendors like Nokia and others. And nonetheless, though, Nokia is on the board of the O-RAN Alliance. It has an entire software-related line of business. And of course, you're participating in this O-RAN forum. What do you see as the future of O-RAN and Nokia's place in that open environment?
Thanks, Chairman Pai. And yes, enthusiastically participating. I haven't been dragged here. Against my will. So no. So let me provide a context. Obviously, Nokia owns Bell Labs, an organization you're well aware of, and probably you could argue the most innovative tech industry pioneer for the last maybe 100 years. Certainly in the ICT space of information computing and telecom. So that's a rich history of innovation that we are always looking to leverage, and a fundamental part of that innovative mindset since what was called the consent decree, if you remember, was actually making the intellectual property open and available for everyone to utilize. And so I think we've maintained that for the last 50 years since that separation. And so we fundamentally believe that openness is a key part of innovation. It was always open inside Bell Labs, but increasingly over the last 50 years, that's openness outside Bell Labs to the larger academic community, to the larger industrial community. So I would say openness equals maximum innovation. We would almost make that just an identity and an equality. So then that leads us to lead organizations like XRAN and CRAN, which were the precursors of O-RAN, and then join the Open RAN Policy Coalition and O-RAN Alliance, where we actually lead a number of the working groups. So it's just a natural part of our culture, I would say. It's partly the Bell Labs culture, but the parent company has always supported that culture. And our products typically have been more open than other vendors' products, to be honest. The X interface that was mentioned earlier, of course, we actually opened our X interface before anyone else, which is the one that allows base stations to talk to each other. We pioneered the CPRI and eCPRI interface specification so we could get that front haul interface open. And of course, we worked on the network to device interfaces, which we've standardized, in the core to RAN interface, which are open as well. So we've really always been open. And I think we found it actually, to be honest, a little bit odd that we were classified as an incumbent laggard who wouldn't be open, because we've always considered ourselves an open company. Now, to your question about why would we be open, not just philosophically open, but even commercially open, I think it's the fact that we see new value creation potential that is huge. And I think Stephen Bai did a nice job of highlighting two of the elements, but I want to add a couple more. Certainly, more radio variants able to attach to cloud native baseband. And that cloud native point that Stephen made is huge for us, because if I can deploy a baseband anywhere, anytime, I can dynamically scale out a network. And why would I want to do that if networks hadn't had to dynamically scale so far? Well, that's where we see the enterprise and industrial opportunity is hugely value creating. The next industrial revolution is about enterprise and industrials, local area, medium area, wide area, requiring what are called private wireless networks. But what it means is sliced networks, as well as individual networks dedicated to them, based on commercial cellular specifications, as well as unlicensed specifications. But for that to work, they want to deploy those networks live and dynamically. And cloud nativity is critical for that, because I can deploy it on any infrastructure. And then on top of that, of course, I can deploy the applications natively alongside that infrastructure. That's the AI application that not only optimizes the network by doing intelligent AI-based control of the network, allowing dynamic optimization of beamforming and signal-to-noise ratios for every user and every application, but it means I can use the same processor for when it's not being used for radio optimization for AI applications or facial recognition or voice recognition that are being used today. I can use it for AR and VR. So it's got this lovely confluence of the very thing we need to do to create dynamically scalable networks at the edge, the same things you want to do for high performance applications, and all of that is part of the new value creation paradigm. So I'm going to just make a couple more points. One is this integration point is key. Laurie made it. Stephen said it might be easy. Laurie said it might be hard. I'm going to say it's somewhere in between, and it rather depends on the performance you're looking to achieve. I actually think for a base level performance, it should be relatively straightforward to integrate all those components and get base level performance. But the more sophisticated the performance you need under all circumstances of latency, reliability, capacity, obviously the bar goes up. And I think it's as yet not entirely clear how we're going to verify the very highest levels of performance without doing some more deep interoperability. So if you could bring up my slide, we've been trying to work on that problem because we're trying to look at an architecture that allows for any level of performance to be made available. So if that pops up, it's an architecture we've called Modular Open Networks Infrastructure. And it actually has ORAN all over it. So that's the first point I would make. Look, ORAN, 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 ORAN. And that's not just because I was invited to this panel. I don't change that when I go to other panels. That's fundamentally part of it. And if you had any doubt about the importance of those interfaces to us, you see it there. But the other thing we're trying to do is work on what are the fundamental set of modules that you could procure in the open ecosystem. It is chipsets, but it's actually chipsets packaged into, call it servers or cards, that you could actually then package together. And those modules could have different performance levels. So if you see in the bullets I have on the slide, you could have a lower performance one, a mid performance one, and a high performance one. But no matter what, they would self-identify, plug and play, and allow essentially an automatic configuration and operation of that network at any level of performance. And that requires a little bit more work in our industry. As I said, I think we've got base level done pretty well through ORAN and OTIC and the interoperability for it. But I think we need to do a bit more work to actually complete this for all levels of interoperability with all sophisticated radios, with all levels of industrial requirements, and make it really plug and play across all those dimensions. But otherwise, we're well on the way there, is my message. Innovating with the community to get maximum innovation, as I said, through openness. But there's a bit more to be done to get to the highest levels of performance in our view, which is why we're working on that extension of the ORAN architecture towards a more modular, open, variable performance from low to high architecture. So thanks for having me, and it's a great panel so far.
Absolutely. No, thank you for those remarks. And I will turn to Marie in a moment, but let me just capture the essence of what Marcus just said with a question to Matthew. How has Geo's deployment accommodated those low bandwidth or high bandwidth or low performance, high performance type use cases that we just heard about?
I think it's a very good question. Before I answer that specific question, Chairman Pai, I think what Laurie mentioned and what Marcus mentioned, in terms of interoperability, I think it is an extremely important component, because the reality is we need to make all of these interfaces work, correct? And work, not just interoperate. We know when we get two routers to work together, which is supposed to be, as we said, the all IP network, it is a lot of effort that goes into whether a Cisco router or a Juniper router, just sitting next to each other in Silicon Valley, right? Getting to talk to each other is not a simple task. And why I say that, to the credit of Ms. Laurie, is I think when people say we've got ORAN deployed, I'm an optimist, but I'm also a realist, because I know what it takes when people say they got ORAN deployed. I think what we have is if I use the term BF-RAN, brute force RAN, right? Right? And I say brute force RAN, and Marcus knows this very well. brute forcing Nokia to integrate with another vendor with no open interfaces. It is called the big hammer that is coming from the vendor in terms of money, right? So that hammer works to go from. So now we have to evolve from what I call as the BFRAN to the real evolved ORAN, so we can actually get the benefits of security, scalability, and the maturity that the United States inherently has. And the reason why I say, Chairman Pai, I know you've been across the globe a big advocate, not just from a regulatory standpoint, but even with operators. Because if you look at, be it cloud, be it operating system, be it Apple or iOS, be it chipsets, right? Semiconductors, FPGAs, ASICs, which are all fundamental to ORAN, or whether it is AI-based systems and AI-based chipsets, these are all fundamental building blocks to ORAN. So we have the ingredients, but we need to come together on a common framework and standard. In terms of narrowband versus broadband versus very high band and low latency, Chairman Pai, in our network, we have really not got massive machine type communications yet. And the reason is the specifications for MMTC for 5G is not yet there. So when people talk about low band connectivity for IoT, it is predominantly an NB-IoT connection. Otherwise, the type of connectivity that happens in India is predominantly today from 500 kilobits, as Steve Papa said, to anywhere from 500 kilobits to about 10 to 11 megabits. And our intent is through ORAN, i.e. through trusted partner ecosystem, to get that 10 megabits to 100 megabits. And we sincerely believe with the right partnership, we can indeed get there.
Terrific. Well, thank you for that. And let me turn to Marie with apologies for making you wait so long. But I do want to ask you, from your vantage point, how do you see the introduction and deployment of ORAN affecting the relationship between the core and the edge of the networks? And if I might pose a second question to you to thank you for your patience, in particular, how do you see this affecting the Internet of Things ecosystem that already is flowering in the current environment?
Yeah, thank you, Chairman Pai. I'm also very excited to be part of this great panel, and I'm also very excited to see, the ultimate virtualization of the network with the RAN virtualization, especially since, HP has been, one of the founding members of ETSI-NAVI, and we've been pushing for this virtualization for years now. It's been very effective in the core, and now it's getting in the RAN. And in a nutshell, with the RAN virtualization and ORAN, the RAN really becomes a set of virtual network functions, just like the core virtual network functions. So everything else, whether it's onboarding, validation, deployment, orchestration, the observability now with this O1 interface to every node, the service assurance, the slicing, the security is homogeneous across the RAN and the core. And not just for 5G, but also for 4G, for Wi-Fi, for even enterprise virtual CPE and so on. So we have this vision that was built for 5G to have a common core with heterogeneous access, which is becoming real. Really, having this virtualization across the whole network. And it's not just virtualization, it's also SDN, this software-defined network for the connectivity. So stitching together all these virtual functions in the RAN is being done with SDN, with SD-WAN when it's distant data center. So we really get, this homogeneous way of doing things across, the different parts of the network. And HP, we've been working on these topics, for years now, doing that for 4G, for virtual LTE, for virtual CPE. And now we are doing that for 5G, evolving not just, on hyper-based infrastructure, but also more and more cloud native, container based. It's very much hybrid cloud now, even moving to hyperscalers. And whether it's core network functions or RAN, now it's quite similar, same processes. And in terms of the instances, and you were talking about the edge, it doesn't matter so much, whether you deploy in the core or you deploy in the edge for low latency or certain use cases. Just a matter of placement. So just a matter of getting the parameters, on the instance where you want to deploy it or where the AI tells you to deploy it. And this is just placement. And then the backend is just orchestrating that. And once you have that, and this is one of the beauty that I see also with the virtualization of the RAN and this kind of distribution that we see now of the RAN, which is that more and more operators are considering deploying at the edge of the network. And so this is another aspect, we are sharing at CMEC, and we've been advocating this MEC type of use cases for years now. It's been, challenging and so on. But now that the RAN is a edge use case, is a MEC use case, now we are getting this MEC location, this edge location, where we can not only deploy the virtual RAN, but also deploy some core elements, also some applications. And I come back to your questions about IoT, to enable these IoT use cases, whether it's video surveillance with high bandwidth, or whether it's low latency use cases like the autonomous cars. We need this edge location. And with virtual RAN, now we're getting this edge location. And so there is a business case and also an opportunity for operators to do that. So, all about, virtual RAN and O-RAN for, all these capabilities, also the no vendor locking, the no black box, DevOps and CI/CD who can track now all the changes in the network, whether it's core or edge or RAN, authentication, auditing, which is now common across the infrastructure for end-to-end security. And it's even reinforced with some capabilities that we have with HP Secure Root of Trust with some embedded crypto. And also, as mentioned, the energy saving, which is becoming so important, is now much easier with the virtual RAN across the core and the edge and the RAN by scaling down, if less traffic. So overall, I would say, this virtualization of a RAN is really a great opportunity. I think it brings lots of flexibility. Everything becomes pure software. So it's much more affordable as well. It also welcomes new entrants. So in terms of, we've talked about, being inclusive, I think, and all the work you've done, Chairman Pai, for that, I think is also very important to really empower, the whole broader community and ecosystem to bring new use cases and to be able to be part of this big 5G, story. But as mentioned also, a few times in the panel, interoperability will be key. Just like, it's been key with NFV, we had launched this Open NFV program, to help, sort out, interoperability across vendors. And in 5G, definitely with all these microservices and open interfaces and standards, interoperability is definitely key, which is one of the reasons why we have launched this 5G Open Lab in Fort Collins. It's a facility which is open to any vendor and operators and startups and so on. And it's based on a secure Arden data center. And it's really, set up to perform multi-vendor 5G POCs and testing and interface validation and things like that.
Well, that's terrific. No, thank you for that description about how you see core, edge, IoT, all of those things. And we really appreciate it. And again, sorry for making you wait so long. If I might turn back to Lori, who has received perhaps the supreme credential of any panelist, which is being repeatedly cited favorably by your co-panelists. Obviously, AT&T has a variety of different technologies embedded in its network, fiber, DSL, wireless. How do you see O-RAN being integrated into a network of the scale and size of that? And if your colleagues from Mavenir as well as Parallel Wireless would care to chime in as well, since you, of course, have experience working with some operators like that, feel free to do so as well. But I'd just be curious to see how you see it playing into the existing network architecture.
Right. So AT&T is an integrated broadband connectivity provider. So we provide connectivity via fiber, DSL, and wireless. We strive to have an integrated network with seamless connectivity. So O-RAN is really the architecture supporting our 5G wireless service in it. And we view that it allows us to open up the interfaces between the various components in the radio access network and really shift to a more modular network with different components and software sourced from different suppliers. So we think 5G is really the perfect time to start thinking about openness to help foster innovation in the ecosystem. 5G brings new capabilities. We talked about new spectrum, the beamforming, the massive MIMO, the higher speed broadband connections, and also talked about the edge and all the new enterprise services at the edge. So with these open interfaces, suppliers can really take advantage of the capabilities like the AI, like the machine learning, and can bring those to help really customize the network, to really enhance the network via closed loop type automation. So we're really excited about all of the opportunities that O-RAN can open up.
Terrific. And Steve and or John, if you have anything to contribute on that front too, to the extent you've worked with some of those operators facing that same challenge, I'd be curious to hear.
Yeah, let me jump in. As I say to Laurie, Mavenir is waiting for the opportunity. I think that's the best way to describe it. So, when AT&T starts the process, we're willing and able, and I throw that also out to Marcus about this interoperability testing, because we believe interoperability is key to the success of this marketplace, and I was glad to hear Matthew talk about the BF hammer. So I'm going to utilize that going forward. So. So Marcus, we're ready and waiting for the Nokia radio. I think there's a lot of discussion about Open RAN, but proof is in the eating, as they say.
Well, if I can respond to that, Chairman Pai, I would say absolutely, of course. That's in the absolute spirit of my slide and our intent. I also respond on the question of broadband generally, because obviously one of the things Nokia does is offer DSL and fiber and fixed wireless access and mobile access is one of our unique capabilities. So increasingly, we're looking at using the RAN intelligent controller of O-RAN as an access intelligent controller that would allow someone on a fiber, DSL, or cable connection to have the same optimization function as on a wireless connection. Therefore, you wouldn't know which connection, or perhaps you would know, but you wouldn't care how you were connected because you were always optimized. So we're actually looking to take the same concepts and apply them in wireline, which I'm sure will please everyone. So that's we're going above and beyond.
Terrific.
I would just add our experience. We've been focused on brownfield networks, and there's sort of a cardinal rule of the cell network, which is thou shalt not regress the capability at a cell site. And with 25 years, 30 years of the 3GPP roadmap, there's a lot to build. And so we're working with some of large global operators to get that right. Okay. In many ways, the way the early Intel data center computers were deployed, they were actually in rural locations. I was a product manager for the first line of Intel computers. It was actually at AT&T NCR Teradata back in 1993, 94. And my customers were rural Walmarts, retailers in the Philippines, et cetera, because they were willing to take risk because TCO mattered so much to them. Okay. And we're seeing the same thing on a global basis, right? I'm sure there's exceptions. We have some interesting greenfield networks, some that we've spoken about today. But globally, it's more about brownfield, and you can't regress the network. And when you have user populations, there are countries where less than 25% of the phones can do a VoLTE call today, right? So they have to rely on older handsets, okay? And those are the folks that are under the most TCO pressure, right? More so than the ARPUs in the US that AT&T enjoys can be 50x some of these other countries, but they need the same equipment for 5G.
Yeah,
exactly. Stephen, if I could bring you back into it, one of the questions that is often raised is time frame. Dish, of course, doesn't just want to build a wireless competitor. It wants to build a wireless competitor as quickly as possible. I'd be curious to see how the incorporation of some of the O-RAN technologies that the company has announced of late, as I said, including today, might affect in a positive way the time frame that you're looking to deploy on.
Yeah, no, that's a very good question. Whether it's with Nokia, Fujitsu, Mavenir, Altiostar, VMware, and even Matrix, they're just the vendors we've announced and the partners that we're working with today. But and I come back to a comment I made earlier. I think we're in a unique position where we don't have any legacy. We're not having to go back to integrate into 3G and 4G and perhaps even when we talk about the radio, the radio is only one component. But and I've been around this industry a long time doing different network upgrades and technology migrations, and one of the challenges you have is the OSS BSS layer as well. It's not just the radio piece, and so for us, we're not encumbered by that. And we have a great platform on which to, sort of build our network. And it's an enviable position, frankly. And we see the technology at the state where it is today that is mature enough for us to build and to build it at scale. And so, it's fantastic where we are, and it's a credit to the whole industry to get us to this point. But Dish obviously is in a unique position to be able to take advantage of that. So when I look at it, it's really the platform today, sort of 5G going forward, building on the components that we have, O-RAN being one piece of that. But, the cloud native infrastructure, the development of OSS and BSS systems today is way ahead of where it was, 5 to 10 years ago. And so, we're in a position to really actually, accelerate the deployment of this technology. And I think it'll help the whole ecosystem, with what we're doing. I think it will bring the whole ecosystem along and allow other people to take advantage of that, whether it be in the developing world or other developed countries. And just to, probably add some color to this, I think it is really challenging for an incumbent operator, to actually embrace any new technology. You saw that with 2G to 3G, 3G to 4G, and now you're seeing with 4G to 5G. It's really, really hard. It takes a lot of courage to take on that technology migration when you've got so many customers on that network that are dependent on a legacy technology and legacy systems. So, fortunately, we're in a great position, in a very unique position to really accelerate this build out and create a platform that really is going to unlock an enormous amount of innovation for a lot of US companies.
If I may, Chairman, just to build on that from a vendor standpoint, one of the issues the legacy vendors had, if you want to call them that, is the number of features we have to carry forward, to Stephen's point. And that's actually what takes a lot of R&D, is carrying features forward. So if there's a perception of less innovation, I would argue we're at least equal in innovation, but a lot of R&D budget, because people talk about billions of R&D we spend, but a lot of it is carrying features forward. And so that's where some of that complexity and that spend comes from. And of course, that disadvantage is the inability of a new entrant to carry those features. It makes perfect sense, but we have to. So we end up with this conundrum of we have to do the new thing as well as carry the old thing forward. And that's, of course, makes some sense. And the new entrant can start from a new perspective, but gets the disadvantage of not being able to carry the legacy forward. So I think it's not really that sort of incumbents are bad and new entrants are good. It's really we're coming at it from different spaces and trying to converge upon a common architecture. And I think O-RAN is helping us do that, to Stephen's point.
Terrific. One of the things, this might seem like an off-the-wall question, but it occurs to me, given that the title of this panel is Lessons from the Field, I think of my own visits to the field, and I've heard everywhere from the Delta in Mississippi to a dusty village outside of New Delhi, India, that one of the challenges that operators have found is the workforce, that there aren't as many trained crews that are able or willing to build these towers, to maintain them, to attach antennas and the like. And I'd just be curious for anybody on the panel, how do you see O-RAN, Open RAN, its deployment and operation as affecting the need for a physical workforce? Obviously, it's going to drive economies of scale. Does it also ameliorate the gaps that we see in terms of a workforce that is able to do the work in the field?
We need to standardize an antenna mount that a drone can go up, pick up the active antenna, bring it to the ground, and bring it back down.
Great suggestion. No, I think Open RAN, really does open up the door for job creation, not only in the field, but also, in the operators themselves. I think, we've seen the de-skilling of operators over time as they've shed the load to the incumbents. But in reality, Open RAN is sort of bringing back the opportunity for operators to compete on a feature by feature, product by product basis. That if we do the job right, mobile networks of the future will look like the internet. And so to the extent that the operators can develop features themselves, launch features themselves, try things out, shouldn't be needing all of these big suppliers effectively to produce some of these competitive elements. And I think you're seeing, certainly seeing in other parts of the world now, they're recruiting engineers to take on the O-RAN type principles, as I call it, or the Open RAN principles of, open interfaces and interoperability, but also the technical people that actually can get their arms around it. And And also the other side of it, once you get these open interfaces in there and some of the features that are there in 5G, you can get into true network slicing in a sense. Well, I've got one radio, but I've got 3 operators that are using it, and Mavini has been involved in some of these neutral host type trials in the UK, for instance, where you've got one base station and potentially 3 or 4 operators wanting to use it. So I think in some respect it may even lessen the capital needs in the field. And the operators become more true software vendors or software operators, if you like. But that's a sort of a vision a little way down the road. But I think once we get the supply chains working, some of that's going to naturally happen.
That actually hits it.
So in terms of in terms of technology, I mean, it's a revolution, I would say. In the past, the RAN was really complex and so on. I mean, now we've built a cloud native 5G core. And so this technology, I mean, anybody can write, a microservice. Now it's so easy. I mean, it's IT type of course, then you need to add a bit the all end-to-end and multi-vendor and so on. But technology-wise, I mean, we have moved away from proprietary protocols to HTTP2. And I mean, this is really IT and internet technologies. And there's lots of open source as well. So I think it really opens up to these new entrants and, any developers out there in the world, actually.
Yeah, if I may, I think there's 2 ends to this. One, we still need people to climb towers and, to install equipment and maintain the equipment of these remote sites. But I think, with the capability that O-RAN and really cloud native and virtualization, in addition to, sort of O-RAN enable, is the ability to open up an environment to allow for more innovation. And innovation is not geographically constrained, so that somebody has a great idea, can really develop some capabilities that we can deploy in a network in a way that we weren't able to in the past. And I think, at one end of the spectrum, we can unlock that and allow people to develop software that can really enhance the network in a way that wasn't possible before or very difficult for us to integrate. But on the other end, we still need people that, are actually physically connecting cables, that are physically having to maintain that equipment, because somebody's got to replace that when something breaks. So we see the need at both ends of that spectrum, and clearly going to take advantage of the build that we're doing to help, stimulate that growth.
Just real quick statement, Chairman Pai, just to add to what Stephen and Steve Papa said. That is, when we think about people on the field, to your question, we look at people on the field no longer as domain experts. We look at people on the field as task masters, meaning the systems in the backend is able to tell the individual what task to be done and how it is to be done. Because you don't need a very big expert on 5G Open RAN, because we can't have PhDs across the world, right, in geography. So that's one big thing that we've done. The other thing that I would add is O-RAN, Open RAN today is only one small component. There is the infrastructure that Steve Papa talked about, but there is also the IP layer, the transport layer, the systems layer. So there's a lot of work to be done for us to become the true web scale, IT-centric entity that we need to all evolve to.
Well said, Matthew. Yep.
We have about 5 minutes left, and so I don't want to monopolize all of the time with questions posed to each of you, but is there anything that we haven't had a chance to discuss yet that a member of the panel would like to amplify on, or a new issue that she or he might care to discuss?
Yeah, I'd like to just follow up on this open versus open discussion. It was earlier today, and I think Marcus alluded to a little bit of it, that there's a mention that standards are open. Well, in reality, the devil's in the detail. And clearly we've got to make sure that open specifications are full product specifications. They're not frameworks that can allow proprietariness to further creep back into some of the networks we've got. So, I think that's an important issue going forward. I also think, that, and this sounds like operators may need an excuse, but in reality, some of the operators feel, are sitting on the fence in terms of where Open RAN is really going to go. And, if they make a decision to go one way, they lose support in the other. So, in a sense, they're looking for somebody to point to and say, well, it wasn't my decision. It was Chairman Pai's decision. It was. So
I'm used to that.
Yeah. So I think some of that is going to be necessary in motivating operators to move forward with the concept of open disaggregated networks.
Yeah, one comment I'd add, Chairman Pai, is to applaud the FCC and your actions over the last few years to bring more spectrum to the market, to encourage the discussion around O-RAN and the adoption of this capability as we go forward. So I think you and your fellow commissioners have done a terrific job of advancing the agenda for the U.S. economy. So I think I speak on behalf of the other panelists on that as well.
Yeah.
Well done.
Well, thanks so much. No, it's been a slog, of course, on both the licensed and unlicensed bands, but I do think at the end of the day, our hope is that we will, to the maximum extent possible, remove spectrum supply as a constraint on some of the network innovation that companies like all of yours have been able to pioneer. So we hope that the future is bright in that regard.
The one component that I'm sure you would have touched on other areas, but here too, is not just the supply chain diversity or the supply chain security, but I would also say the supply chain superiority.
Yeah.
What I mean by that is, how do we ensure the Mavenir and the Parallels of the world get access to the best technology, right? They are not, because of their size, at a disadvantage, right? How do we ensure that? And how do we ensure that the raw materials we have access to? Why I say raw materials for compute, raw materials for storage, raw materials for ASIC/semiconductors, right? Even for the companies like Qualcomm, NVIDIA, now NVIDIA plus ARM, Broadcom, name them, right? Each one of those folks needs their appropriate raw materials, because even for O-RAN, that supply superiority of technology and access to that raw material, right, I think is very important. And having these smaller players being enabled to be successful is also, I think, equally important.
Terrific.
Yeah, I agree with that. I mean, this is one of the reasons why we have launched this 5G Open Lab, to really welcome, different vendors to, put some equipment in the lab and then welcome some of these, other players to be able to, test with these environments. So, I welcome all of you to actually, contact me and join this initiative. And also, I think I would like to emphasize the fact that 5G is great, it's deploying and so on, lots of radio, and we have this, emphasis on O-RAN and the RAN, but the brain of the network is the core. So we need the 5G core to deploy to really have the beauty of the end-to-end 5G capabilities, including the slicing and the end-to-end security and so on.
And the only thing I would add, I think, Chairman Pai, is I think what you have done expertly and together with some of your colleagues in the US government is the idea that incumbent vendors are not bad, right? That incumbent vendors that embrace open should be encouraged as part of that ecosystem, because a massive scale 5G network will require a large amount of incumbent vendor deployment as well as new entrant deployment. So that hybrid, and that it's not one or the other, it's both, I think is actually a very good message and a positive message that vendors like us like to hear, as opposed to being painted as the legacy laggard, which I don't think is correct. So I think that's been very valuable.
Yeah, Open RAN is all inclusive, so it's not doesn't favor one to the other.
Well, to those who are viewing, I promise you, I did not set up the resolution of this panel on such a positive, uplifting note, but I will express my gratitude to Marcus and John for enabling us to get there. I want to thank all of our panelists for taking time out of their busy days to share this expertise. Obviously, there's much more that we could discuss, but I think we've gotten a tremendous amount of feedback on some of the positive developments in the field. And so in that regard, I want to thank each of our panelists, John and Lori, Marcus, Stephen, Steve, Marie, Paul, Matthew, and anybody else I might have left off inadvertently for convening today, and look forward to continuing the conversation. This is obviously not the end of all the lessons that we need to learn. There's much more to come, and I look forward to being a participant with all of you as we get into this new generation of wireless infrastructure together. So thanks to everybody, and we will now take a very short break until the convening of our technical panel, which will be led by our august Chief Technology Officer, Manisha Ghosh. So thanks everybody again. We'll see you soon in the virtual and hopefully physical worlds sometime soon.
Thank you.
Thank you. Thanks.
Good afternoon, everybody. We are at the final panel of the session. We've saved the best for the last. Before we kick off the final session, I'd like to give Commissioner Rosenworcel an opportunity to say something about the event and her statement on Open RAN. Commissioner Rosenworcel.
Thank you, and good afternoon. It is a treat to join you to kick off the final panel of the day, a technical deep dive into open radio access networks. Now, I might be the last one of my colleagues to address you today, but the record will reflect that I was actually the first commissioner at the agency to speak extensively about the power of Open RAN, and that was more than a year ago. And it's for good reason. Open RAN has extraordinary potential for our economy and our national security. That combination is something to seize, especially right now in the early days of 5G deployment. You know, our 5G future is about connecting everything. It's about radically higher speeds and lower latencies, opening up possibilities for wireless that we can't even fully imagine today. If we do this right, it could render our smartphones the least interesting thing about the future of wireless technology. Think of it as instead as an input in everything we do, bringing new efficiency and effectiveness to every sector of our economy. Now, doing this right also means putting security first, and it means recognizing that this new connectivity brings with it a whole lot of vulnerabilities. And to date, the FCC has focused its efforts in this area on limiting the deployment of insecure wireless technology by restricting the use of network equipment from Chinese companies. We have encouraged our allies around the globe to do the same. But we shouldn't be lulled into a false sense of security by flashy and well-promoted decisions about hardware and administration headlines about Huawei and ZTE. That's because the 5G cybersecurity challenge is much bigger than simply dealing with a few Chinese companies. Restrictions on Huawei and ZTE are a minor fix for a much larger problem. While we can ban a few specific products, services, or companies, no country can isolate itself completely when we are connected worldwide. Plus, our national ambitions are far too great to be defined only in relation to a single country. We must focus now on our competitiveness, on strengthening our alliances around the world, and on reasserting our values by building a new market for 5G equipment. That, I believe, is how we will restore American leadership and secure 5G. This is ultimately what Open RAN and this whole conversation is all about. It's about making the market for 5G equipment both more competitive and more secure. So at Mobile World Congress last year, I explained that if we can unlock the RAN and diversify the equipment in this part of our networks, we can increase security and push the market for equipment to where the United States is strongest in software and semiconductors. That means we can increase vendor diversity and in the process increase competition and resiliency. Plus, we'll all benefit from software-centric innovation and radio access networks and faster upgrade cycles than with traditional hardware. Now, I've since testified about this idea before 4 different congressional committees, 4. So I can say with authority, momentum is building. But we do have more work to do because not everyone is convinced. Earlier this year, the Attorney General of the United States called Open RAN just pie in the sky. But one company has already made it into the history books as the first to launch an Open RAN network in Japan. And Open RAN hardware and software is now projected to reach 10% of the total market in the next few years. And so I believe that if we want to lead in the development of Open RAN, then we need to take action now to help build this momentum and this movement from the ground up. And gathering today and learning from one another is a great start. But there's more that we need to do. First, we need investment in research and development, both from the government and the private sector. There's a bipartisan bill in Congress right now called the USA Communications Act that would have the FCC provide $750 million to accelerate the development of Open RAN in the United States. This is a good idea. Second, we need to launch an Open RAN test bed that brings together operators, vendors, vertical interests, and government agencies. That's something we can help do right here at the FCC. Even better, we could build this onto our ongoing work with the National Science Foundation to authorize citywide test beds for 5G in New York and Salt Lake City. Third, we need to build scale economies for Open RAN technologies. This happens when we coordinate with other agencies here at home and increase participation in international standard-setting organizations that are doing work abroad. And as we move forward with plans to remove insecure equipment that is already in our networks, we should consider incentives for replacing that equipment with Open RAN architectures. We also need to build incentives for producing the next generation chips that Open RAN technologies will require. And that includes research into the use of gallium nitride chips, because early research shows it could be more efficient than traditional silicon chips for 5G technologies. So that's a lot of work. But look at the expertise we have gathered virtually today. I want to thank you for being here. I want to thank you for listening. And most importantly, I want to thank you for being part of creating a more secure and competitive 5G future.
Thank you very much, Professor Rosenwasser, for kicking off this final panel with those.
I appreciate that you just upgraded me to professor. But we'll stick with commissioner.
Commissioner.
Thank you. I appreciate your time.
Professor. Thank you very much. Panelists, could you please turn your cameras and microphones on? Okay, so this has been a long day, and I hope most of you on the panel, as well as in the audience, had a chance to listen in to the morning and early afternoon session. There were a lot of very interesting, and I would say at sometimes maybe even provocative questions raised in terms of what the promise of Open RAN can be and should be. What I'd like to do with this panel, with the experts that we have on today, is take a deep dive into a few of those technical issues that were raised and try to really tease apart what is available today, what is possible today, what the technical challenges are for Open RAN to truly become a next generation architecture. I've always thought that maybe Open RAN is the way to get rid of all G. I mean, we are stuck in this generational mode of thinking of one G following another. And now when we are in this mode where we can continuously evolve with an open radio access network architecture, should that be the path we are taking? So that's just one among all of the other technical issues that we want to raise and discuss in this panel. So the way I'd like to do this is a little bit different from the previous panels. We have 10 extremely accomplished experts in their field. I won't go through their bios. Their bios are all listed on the FCC website. But what I will do is just go down the list in alphabetical order, give each panelist about a couple of minutes chance to just express where they're coming from into the Open RAN discussion. And then we'll take it from there into a question and answer and discussion phase. So without much ado, Mihai Banu is from Blue Danube. Mihai, please go ahead and introduce yourself and just get started. You're muted.
Okay, thank you, Monisha. Good afternoon, and thank you for attending this panel. Today, I want to focus on the challenges implementing O-RAN for massive MIMO systems in the sub-6 GHz bands. This will include the 7.2 O-RAN split. Massive MIMO is used for 3D beamforming, which is the key feature for the most advanced 5G radios. The widespread use of 3D beams is a prerequisite for delivering the highest capacity in cellular networks. This is particularly important for mid-bands like 1.5 to 4 GHz and so, because these are the most valuable bands with a good propagation and reasonable bandwidth all at once. As we know, low bands suffer from insufficient bandwidth and millimeter wave bands suffer from poor propagation. Another important thing that we need to remember is that a large portion of the mid-band spectrum is FDD. Conventional massive MIMO technology is fundamentally more difficult for FDD than from TDD due to the lack of channel reciprocity. So let us talk a little bit about the O-RAN challenges. Conventional massive MIMO requires a large number of digitization stages, such as 32 or 64, resulting in an equally large number of very high-speed digital streams, which need to be processed in real time with powerful signal processor and sophisticated software. So on one hand, massive MIMO makes the RAN system significantly more complex and more expensive than regular MIMO. But on the other hand, we want to split this complicated system into portions any vendor can implement with 100% guarantee to connect flawlessly with the other portions provided by other vendors. No wonder there are so many technical disputes on this topic with obvious vendor biases and many rumors in the industry that O-RAN will take much longer to become a real open standard than we hope. At Blue Danube, we believe we have a solution to this problem. In our opinion, the issue is not O-RAN per se, which is rather straightforward to implement in MIMO with a reasonable number of digital streams, but rather the issue is conventional massive MIMO, which is unnecessarily complicated with a very large number of digital streams, a brute force approach. Our answer to is the concept of coherent massive MIMO, as illustrated in the slide I prepared for this panel. Can you please show that first slide, the one slide that I have? I don't know. I cannot see it, but is it shared?
It's coming. I think everyone is going to share it.
All right. First, let us focus on the hardware coherency matter illustrated at the bottom of this slide. For any active array, the only way to make a predictable 3D beam natively without any DSP is if with all active array elements are almost identical electrically. In this case, the array is coherent, and the average phase error between elements is 5 degrees or less after all the hardware calibrations, and this has to be for all operating conditions. An example of hardware coherency is provided by any military radar phased array, for example. The conventional massive MIMO on the right does not use hardware coherency and instead divides the antenna aperture into many small subarrays connected to many individual radios to individual digitizers. Then it relies on channel sounding and hardware and processing are obvious. The coherent massive MIMO system on the left digitizes the entire aperture of the array, but only as many times as the maximum number of layers we expect. Each digitized stream represents a different independent analog 3D beam created simultaneously by the coherent aperture. This is where the hardware coherency plays the key role. I also stress that digital 3D beamforming between the digitized streams can be done as in the conventional massive MIMO system, but with far less reduced complexity. Also, coherent massive MIMO works naturally in FDD as well in TDD. Blue Danube has a very low cost and efficient technology to maintain hardware coherency under all operating conditions and to create any set of agile 3D beams by hardware in addition to digital beamforming. No DSP cycles for hardware calibration are necessary. So the bottom line is that since our coherent massive MIMO uses far fewer digital streams than conventional massive MIMO, the O-RAN split for this system is fundamentally simpler, similar to conventional MIMO, and therefore can be brought to practice reality right now. Thank you very much.
Thank you, Mihai, for jumping right into the technical details of what makes massive MIMO O-RAN system work. That's excellent. Charles,
it's supposed to be a deep dive, right?
Absolutely, and thank you very much for kicking it off so brilliantly. Charles, I'd like to go to you next for your opening statement.
Sure, thank you. So my name is Charles Clancy. I'm an executive with the MITRE Corporation. And at MITRE, we have, I think, a unique vantage point across the entire federal government of a lot of exciting things that are happening in 5G with adoption in different agencies, interest in standards and policy and rulemaking in different agencies. And I think some of the key things that I think that are exciting, particularly from a technical perspective about this, is really the use of artificial intelligence and machine learning in 5G. If you look at the role that machine learning can play in how we optimize resources within our RF environment, it opens up a whole new set of capabilities to deal with a wide range of deployment scenarios. So in a typical, I don't know, US urban environment, you might be worried about kind of congestion in the RF environment, lots of cell towers that need to all optimize around each other, potentially some limited interference, but not significant. And in that scenario, the radio intelligent controller that's part of O-RAN, I think, provides a whole interesting set of opportunities for doing all that optimization. But if you think about more hostile environments, particularly as the Department of Defense considers using O-RAN in some of its systems, you get a whole additional set of capabilities when you start working with more of a contested RF environment, not just congested. So the ability to manage around sources of interference or jamming becomes a really exciting component that I think the machine learning aspects of the O-RAN radio intelligent controller can provide. I think one area that's a little bit understudied so far is security, and so that's my personal area of interest and expertise. We haven't really thought through the threat models for O-RAN yet. For example, do we need to be encrypting the front haul link between the CU and DU? Is that something that's even necessary? What are the risks of intercepting these signals over a fiber optic cable versus over the air? A lot of open questions, I think, still around really what security is needed. But suffice it to say, the more you're going virtual, the more things are being provided by third-party apps. We need to make sure we think through that end-to-end in terms of security. And third, I'd say we really just need to ground what we're doing in use cases. O-RAN in the abstract can be very complex. It can mean a lot of different things. But if you start talking about specific use cases, whether it's radio resource orchestration for drones, or it's dealing with contested RF environments for public safety applications, I think we can then really start to firm up what we need out of O-RAN now versus what we could get out of O-RAN long term. Thank you.
Thanks, Charles. And those are topics that we are going to delve into in greater detail as we go along. Next up, Cheryl Davis, could you please just tell us a little bit about yourself and where you're coming into it?
Sure. Thank you so much. And I'm very honored for the opportunity to be here with you all today. So I'm part of Oracle here, and we are a leader in telecommunication solutions with a global footprint, supporting communication service providers as well as our enterprise customers. So why are we here talking Open RAN? Well, as we're offering our 5G technology that's built on our cloud, an Open RAN is very important to us, and just a few points on why. We provide our 5G service in software so that our enterprise customers have 5G for their IoT needs. And so we have to be able to ensure that that service works with whatever and whomever our customers select for connectivity. Therefore, we have to be able to operate with the vendors in the RAN space. And so moving to a RAN that's open, interoperable, and standards-based allows us to integrate with the rest of the system, ensuring that our customers can capitalize on this technology. And as parts of the RAN could also fit as cloud deployments, certainly we will be following these developments and opportunities. And so just our view on looking ahead, we view that a 5G solution that is open, interoperable, and standards-based will really unleash the next wave of American innovation, as we've heard today. Moving from this monolithic model to one in which a large ecosystems of vendors can work together to deliver 5G solutions is important for supporting multi-supplier networks, and that's a core principle in security. And so because our customers are deploying these open and standards-based 5G solutions, they have the opportunity to integrate future innovations, whether they be in 5G or beyond, in a timely and cost-effective manner. And we're very eager to be a part of this and to also bring some of the security and innovations that we've been able to develop in the cloud into the 5G system. So thank you again for having me here, and I look forward to our conversation.
Thank you, Cheryl. Ashutosh, you're up next.
Can you see me? Okay. Yeah, hi. Thank you very much, Dr. Ghosh, for inviting me. My name is Ashutosh Duda. I work for Johns Hopkins University Applied Physics Lab, which is a university affiliated research lab. We work with many government agencies, Department of Homeland Security, Department of Defense, US Army, Navy, to see how the evolving 5G technology can take care of many of the pain points they have, how they can use 5G technology to make their operation or ConOps more efficient, how they can take advantage of many of the 5G pillars that we have today to support variety of applications like massive content, massive, low latency application, IoT type application, and how they can make the network more reliable and flexible and adaptive. So all these things can happen because of many of the 5G characteristics we have today. I think it was mentioned in the earlier panel, things like software-defined networking, network function virtualization, mobile edge cloud, orchestration, network slicing, edge security, among others. As the previous panelist one mentioned, the previous panel, Mary, I think, many of these have been deployed in 5G core. Now what we're doing, we are trying to bring that to radio access network as part of the O-RAN open architecture and to provide the same amount of flexibility to support this kind of network dynamicity or make the network more adaptive. So as you can see, these characteristics have lots of benefits that we can take advantage of, right? But at the same time, in addition to the actual benefits, they also provide, I'm focusing a little bit on security, the embedded security function, the inherent security function they have. Think example of software-defined networking or network function virtualization, right? If you have that and you have the orchestration facility, how can you scale up, scale down the network and still provide the resiliency when there is a denial of service attack taking place, or there is a heavy performance overload? How can you take care of network slicing to provide isolate the mission critical application from non-mission critical application? So that is a security, inherent security as part of network slicing. Similarly, you can make use of closed loop automation, dynamic service chaining to detect the attacks and mitigate it within a reasonable period of time. So these are some inherent security benefits that we can take advantage of. And if we apply these to Cloud RAN and still provide this kind of automation, you can really make use of these enablers to support billions of IoT devices, support ultra low latency, massive content, and make the network flexible. So these are the opportunities like programmability, virtualization, embedding the DDoS detection monitoring functions. How can you correlate the data traffic and control traffic at the edge of the network so you can detect it early enough to mitigate the attacks? That's so important. And this can be done by virtualizing the RAN. So while I talked about the added benefits, there are also challenges that we need to think about, right? We should not be, I think the commissioner said before, it is not only supply chain security. We have to think about what are the additional security challenges we have to take care of while we deploy these enablers, right? If you think about virtualization, you have to think about side channel attacks due to virtualization. If you're employing or deploying slicing, there are potential risks between slice to slice attacks or impersonation of slices, slicing manager attacks. If you're putting the virtual network functions with firewall functions on the Cloud RAN, when there is a denial of service attack happening, you're scaling up, you're adding more virtual functions or firewalls. Can it start the resources from other VNFs, other third-party application? You have this automation, which is an interesting fit, a real benefit, right? But if you have the orchestration, you are depending on the APIs. So you need to think about orchestration security. You need to think about northbound, southbound API for the SDN controller. So these are the things you have to really think about. So there are opportunities by moving into O-RAN. There are security opportunities. There are security challenges that also we need to think about. And as Charles said, we really need an in-depth analysis of end-to-end component interfaces, open it up, come up with a threat taxonomy, come up with the security best practices, and then at the same time, build test bed in use cases, right? How can you support our government, different agencies use cases and take advantage of 5G enablers at the same time, make it secure. I think those are my takes, Manisha.
Thank you very much, Ashutosh. Yeah, and I don't remember who, but somebody made the statement of it's easier to find cockroaches with the light turned on. And I was just thinking that, yeah, but then they find new hiding places with the light turned on and you have to go after them. So yes, by opening up the network, we do make some things easier, but we are probably changing the threat models and we have to go after the new ways that the network can be compromised. Laurie, can we have you up next? Laurie is representing, I guess, the sole carrier on this panel. She's from Verizon. Go ahead, Laurie.
So Manisha, thank you so much for the invite for today. Verizon is excited to participate, and we're extremely interested in advancing Open RAN and have already been working with existing and new vendors to help with that effort. The potential for small technology companies to have a presence in the RAN business and allowing them to scale at their pace is a great opportunity, and we fully intend on setting up challengers to be successful in this space. Tasks like taking cloud to the edge, decoupling the RAN, creating a flexible architecture, and bringing more vendors to the RAN ecosystem are tasks that are being advanced rapidly by Verizon. So we know that many of those tasks will be tackled in the O-RAN Alliance and participation in ORPC, and these will be critical to promoting the technology. And we helped bring 5G to fruition, and we're a player in O-RAN as well as an early adopter. So as one of my colleagues says, network architecture disaggregation through open interfaces, it's a journey. And we're kind of at the first step of that journey, which is the ability to mix and match baseband software with an open RU. And we're excited because there's future stops. And we hope that that'll include additional disaggregation and open interfaces beyond baseband and RU. There's strong evidence that O-RAN is driving a diverse US-based ecosystem. The challenge that we see at Verizon is scale and maturity. We have a mature network here at Verizon, and it's not a greenfield network. We support O-RAN entirely and know it is the future. We will be adopting this critical architecture and in a time frame that successfully allows the network to mature gracefully, but at the same time protecting our customers. And that is really the key for mature networks, like many of the tier 1 operators, is making sure that we get these needed technologies like O-RAN quickly and as painlessly as possible for our customers. So I wanted to thank you again for the invite and looking forward to the discussion today.
Thank you, Laurie. And I think that echoes what we heard in the previous panel about how the incumbent entrenched providers are more beholden to being backward compatible or supporting existing users, whereas the new entrants can be much more agile and jumpstart and move quickly over to newer technology. And that's a challenge that the industry has to be able to embrace and come to terms with. Thanks. Manu Gosen.
Hi, good afternoon, and thanks for the invitation here. Manu Gosen here, and to connect the dots, I'm here representing the opening comments that Commissioner Rosenworcel made for the Open RAN testbed mentioned in New York City and Salt Lake City, representing the PAWR Platforms for Advanced Wireless Research Public-Private Partnership testbed between the National Science Foundation and 35 members of industry. These platforms have been built since 2018, so we were at the forefront of building open, disaggregated end-to-end network architecture testbeds. These testbeds are available for testing today, and I would urge you and encourage you to sort of think of these environments a little bit differently than a lot of the community labs and system integration labs that you may come across. These testbeds have been built both vertically as well as horizontally. Vertically in the sense of having an end-to-end network architecture with all the different disparate elements from the radio access network, the CUDU, RU, back into the edge, into the core, but also horizontally, aka within each module, there is the ability to stack different pieces of the puzzle in new and varying ways. These testbeds are pre-commercial. They are at a TRL level of 3 to 6, which allows for early prototyping, proof of concepts, and trials as well. And Open RAN was sort of built from the start in keeping these principles in mind as these testbeds were built. Manisha, if you mind putting up the slide, that'd be helpful. Thank you. Thank you. So these are the current portfolio of this public-private partnership. You're going to hear from 2 of the 3 later on. And the fourth one, which we heard a lot of in today's conversation, was around rural broadband. And very encouraged to hear some of the comments made by the FCC commissioners around the thinking that's going around the rip and replace program and trying to think about how do greenfield and brownfield deployments in a rural context come. So we have a platform, a test platform that's going to be selected, and it's going to begin its deployment and construction in 2021. So it'll be interesting to see how that journey maps the journey that's being advocated for within the FCC. Next slide, please. And in terms of sort of the open research problems, sort of we see this mostly, the biggest one is algorithmic frameworks. So the big one to be allowing innovation or allowing visibility for our community, which is the academic community, to look under the hood and to give us more exposure into the parameter space more fully, so new algorithms can be developed and can be deployed. In addition to that, we need to think about how these algorithms can be deployed on these different disaggregated CU, DU, and RU splits and allow for innovation in a truly open ecosystem. A couple points that we'll probably discuss later come to mind around artificial intelligence and its role, especially around the radio intelligent controller. As the RAN gets disaggregated, there are now more touch points to gather data. And as more data comes in, that sort of strengthens the story that we heard earlier today around measurements and the role of AI. What we believe, or what we are exploring in the context of power and in the general ecosystem, are the ability to develop data sets for training, inference, the ability to compare paradigms of offline and online learning, as well as optimizing the three different latency bounds that have been built into the O-RAN ecosystem, namely the real-time, the near real-time, and the non-real-time. Open testbeds, which is obviously where we're coming, we need open testbeds for innovation, and this needs to be democratized to access not just the startup ecosystem and the incumbent vendors, but another major pillar, which is the academic community. So these platforms that we built and we operationalize, we still need to, we think about these as a bridge that connects Open RAN research before it goes into commercial or pre-commercial trials, especially when the early innovation concepts are being tested. On the XHaul piece, again, now you have three different front haul, mid haul, back haul pieces. And on top of that, to connect all of them, you have this intelligence in the rig that ties it on with what are called XApps. To anybody familiar with the iPhone ecosystem, the apps are going to be developed in this Open RAN innovation ecosystem that allow for deep vertical integration of technologies and solutions in the form of applications, which are nothing more than a bunch of containers running on top of a Kubernetes stack that can be deployed and chosen by the operator to meet the objective that they may want. So these are sort of the four main research challenges, and hope to delve into that. Back to you, Monisha. Thank you.
Thank you, Manu. Yes, we will do a deep dive into a number of the issues you raised later on. Let's move on to Amit Jain. Amit Jain comes to us from Virana Networks, a brand new startup in the space of millimeter wave, and he'll tell us about how O-RAN plays into their strategy.
Thanks, Monisha. So as you mentioned, Virana Networks is a startup. We are focused on radio access networks for millimeter wave spectrum, and I would say we are really counting on Open RAN for our success at this stage. So as all of you know, the FCC has licensed close to 5 gigahertz of millimeter wave spectrum to wireless service providers. And this is 7 times more licensed spectrum than what has been available for mobile services in the 600 to 2600 megahertz band. Millimeter wave spectrum is today supported by it's part of the global 5G standard. You have number of semiconductor vendors and handset vendors who claim that they have millimeter wave handsets and CPEs. Yet hardly any carrier in the US right now is planning to build a nationwide millimeter wave network. I think Verizon is further ahead than anybody else, but still they are doing a number of large cities, some deployments, but nobody so far is saying that we're going to offer millimeter wave service to like 70% or 80% of the US population. And the reason is simple. A millimeter wave network requires 15 to 20 times more cell sites than a network in the lower frequency bands. And the cost of building a millimeter wave cell site is not 15 to 20 times less than the cost of building a low band or mid band cell site. So this is a huge problem. And I think unless we solve it, millimeter wave spectrum will not get utilized widely. And I think that Open RAN can actually help in solving this problem. Now, speakers this morning, others talked about two aspects of Open RAN. First is virtualization, the ability to run RAN functions as software on off-the-shelf hardware. And the second topic that almost everybody brought up was how Open RAN brings open and interoperable interfaces to the network. Now, actually, I don't think that virtualization really helps millimeter wave, because if what you're going to do is, if you're going to run millimeter wave 5G on the same off-the-shelf hardware on which you're going to run mid-band or low-band 5G, it is not going to make millimeter wave 5G 15 to 20 times less expensive on a per cell site basis. It will basically end up costing about the same. So if we really want to drive down the cost of 5G deployment in millimeter wave, I do believe that we need innovation in hardware design. And I think in the US, we are pretty good at hardware innovation. So where Open RAN really helps the deployment of millimeter wave is through open interfaces. And I think it is these open interfaces, as well as all the methods and procedures for integration and interoperability, that can enable new vendors, new startups like Verana to enter the market. Because 5G, for all its strengths as a global standard, is still, it's very complex. It's an evolving standard. 3GPP comes out with a new release every 12 to 18 months. Carriers absolutely want to embrace the features that 3GPP brings. So you require not just initial network integration, but continuous interoperability and integration in the network. So with Open RAN, and now new entrants can focus on what they can do best. New entrants don't have to try to build the entire RAN from the grounds up and keep evolving it. And I think this is the method through which we can expand the vendor ecosystem. We can, as a small entrant, as a new innovative entrant, we can work with others in the market and partner and put together a solution that makes sense for service providers in the US. And that's, in a way, at a high level, that's what we are looking to do.
Thank you, Amit, for that. And yes, that's one of the topics that's always been on my mind, is when we talk about O-RAN in the context of today, it's usually in the mid-bands. Moving up to millimeter wave does open up, I think, a whole new world of challenges in terms of fronthaul, in terms of all of the other control aspects of beamforming that need to be fully explored. So let's move on to James Kimmery from Spirent. James is a well-known figure in 5G, and he's recently moved to a new company, and I'm sure he's carrying on his work on 5G in Spirent as well. James.
Thanks, Manisha. I appreciate the opportunity to be able to speak on this panel with all of you. First and foremost, I wanted to talk about two different topics, both representing my former company and my current company, both research and test and measurement. I think one of the exciting aspects of Open RAN is this concept of open interfaces. And by having these open interfaces combined with open source software, you can see where this ecosystem from a research perspective can be created. I mean, one of the challenges that we see in terms of the research community is if you have to basically reinvent the wheel every time you develop a prototype, it gets very, very expensive. And being able to utilize open systems and open interfaces enables researchers that may have one particular aspect of the network that they'd like to optimize and experiment with. They don't have to be an expert on all the other pieces. And I also think that ORAN in and of itself, because of this interoperable open interfaces, that more commercial companies will be able to participate in these test beds. In prior generations, but with proprietary equipment, researchers had difficulty tapping into the equipment that was provided, and a lot of times it was difficult to use. So that combination of open interfaces, open source software, I think that could really create a more robust, advanced prototypes in the future, and that's what we need as we evolve the networks. One quick point about test and measurement. These open interfaces, they create opportunities for testing. Each of these interfaces must be tested. And I think one of the things that people have asked me this, well, if you have to test all the interfaces, isn't that going to increase the cost of the system? And in my experience, I think no. And in fact, as you build a CU, you build a DU, you build an ORU, then these systems can actually be tested independently without access to a CU or DU, an RU, or any combination thereof. So that also facilitates testing earlier on in the design process. You think about actually doing performance testing on an RU without the baseband being present. Well, you can do that. That's what ORAN facilitates in this context. So in closing, I just think that ORAN is going to change a lot of things. It's going to change, hopefully, the way that we research, the way that we test, and hopefully the way that we deploy next generation networks.
Thank you, James. Yvonne?
Yeah, thank you very much, Monisha, for the invitation for the panel. So Manu already talked about power, so I'll try to stay away from it at least a little bit. So I'm a program director of one of the two test beds that Manu was mentioning. Are actually 3 power test beds, namely the Cosmos test bed in New York City in West Harlem. But rather than talking about the millimeter wave and optical stuff that we have in the test bed, I wanted to touch on related topic of how the industry views these test bed platforms, and to sort of touch on the experience we had with both ONAP automation, that we've been hosting these POCs, ONAP POCs, for the last couple of years, and now moving towards the so-called establishment of OTICs, and both OTICs, the OTIC East, which is actually part of Cosmos deployment, as well as OTIC West, which Cobus will talk later on about, are actually, OTIC stands for ORAN Alliance Open Tests and Integration Center, are being established right now. And so a couple of experiences there. Really, the fact that we are facing something that we haven't faced before, which is an enormous increase in complexity of these systems. So testing the complexity becomes a crucial aspect. And when I say that, there are a couple of issues, right? So quite often we have stated performance promise that these systems are supposedly delivering. And then when you measure it in the context of integration, you suddenly start seeing completely different numbers. And so this is something that we've seen in these POCs, and quite often they require hands-on and on-site presence, where people are now suddenly tweaking things, trying to tune them up. So in other words, individual testing is not enough. You sort of need to put this into context of deployment of big system, and not just interoperability between individual components, but sort of putting it all together end to end. And quite often there are a lot of surprises when you do it for the first time. Another thing is that we are sort of seeing this difference in sort of industries, to call it that. We have on one hand traditional vendors who are building reliable telco VERTI equipment that is being deployed, And on the other hand, you have the agile software development culture that's suddenly jumping in. And that creates a huge problem, right? So we need to sort of merge the two societies somehow, or two groups. And that's an interesting thing that we should think about. And then finally, one thing that's actually a couple of people already touched on is that we need, in order to make this really widely available for the community to develop new and better things, in other words, move beyond what we are traditionally doing with the telco equipment, which is to sort of create this new value on top of it. We need to have these well-defined and absolutely open APIs on top of everything, so that we can, and of course, test facilities to go with it, which are fully open and available to community at large, not just the main participant in this discussion. And of course, hope is that, as was the case with the opening of the application ecosystem for mobile devices, we will suddenly see things that we never thought about, right, being developed and deployed. So this is where I would stop and hopefully discuss more technical details later.
Thanks, Ivan. I think you bring up an interesting point about, two different communities, the software community and the traditional networking engineering community. We heard about workforce development from a different angle in one of the previous panels, but there is also the workforce development of a new breed of engineers who have to meld together the software programming piece with the network knowledge, the wireless network and the core network knowledge piece, which is something that academia especially needs to, I think, gear up for if O-RAN is here to stay. Finally, we have Cobus. Cobus is also the PI of one of the power platforms, and I will let him talk a little bit about the power platform in Utah. Cobus, I guess you want your slides up at this point, right?
Yes, please. That'd be great.
Thank you.
So my name is Cobus Vandermeer. I'm a professor in the School of Computing at the University of Utah. In the context of this panel, I am also the director and the principal investigator for one of these NSF and industry-funded platforms that has already been mentioned. So just to sort of set the context a little bit and sort of where we're coming from, there's a sense in which the softwareization and the opening up of the radio access network is just the logical next step in the open software-defined networking evolution that has been going through networking more broadly. I think an important point, though, is when we talk about the radio access network, it is way more complex than any of the other networks where these open technologies or open approaches have been applied. And so sort of as a position statement, I guess, and I'm echoing what several others have already said. I think there's in the case of Open RAN, there's a tremendous need for practical experimental exploration, validation in a realistic environment, and being able to explore use cases, explore the complexity of the interfaces, explore the security thereof, explore the new attack vectors that are enabled, as it were, in an Open RAN environment. And so that's kind of the context of the Power platform that we are developing is really meant to enable this type of research. And so the picture here, and I'm not going to walk through this in great detail, but this is sort of a comic version, if you will, of the platform we are developing here in Salt Lake City. We have a variety of endpoints. We have a variety of radio nodes in the RAN, both at street level and rooftops. We have edge compute. We have a private fiber front haul and back haul. We have a metro cloud environment. We have a controlled RF environment. So in some sense, we have a a ready-made wireless lab that is being built in the real world to enable this kind of research. So next slide, please. A fairly unique thing about our platform, and again, this ties in with sort of the general trend in industry as a whole, is that this is software-defined end-to-end, right? So all of those little building blocks in there, you can think of as running on general-purpose hardware, and so the functionality is defined by the software that you put on there, and so that gives huge amount of flexibility in terms of experimentation and research. And so that's what's kind of shown on the top left there, and then the top right, we also have what we call a bring your own device model, where you can kind of in this whole architecture come and plug in your own devices at the various layers if the platform we provide is not what you want. So that's in a nutshell the Powder platform. And so the figure at the bottom is just to make it a little bit more real in the context of Open RAN and specifically some of the things that we are doing. So if you take this general purpose hardware, right? So a cloud compute platform, software-defined radio, and you combine that with software, and oftentimes the software can be open source software, then you can get this end-to-end open source Open RAN environment. And this is something that we're specifically working on by taking the open source components that's coming out of the O-RAN Alliance, and we're kind of combining that with other open source stacks out there in the form of Open Air Interface and SRS LTE to get us to this end-to-end open source environment. And then just to echo some of the things that one of the earlier speakers said, a key thing that we try to enable in our platform is that you don't have to be an expert to use this. And so for anyone who've tried to stand up any of these software stacks, you'll know it's super complex to do that. And so we follow this kind of Lego building blocks approach throughout our architecture. And so we try to provide building blocks where you can sort of, by a click of a few mouse buttons, instantiate an O-RAN environment or an SRS LTE environment and have that as a building block on which you can then build. So we're doing some of our own research on this in the O-RAN environment, but I want to emphasize that Powder is a platform that is open to the community at large, both academic and industry, for research and development. Thank you.
Thank you, Cobus. I mean, as someone who came to the FCC from NSF, I cannot reiterate the importance of having these openly available test beds, because a lot of what we heard about innovation and about new companies and new entrants, all of this is going to happen from people who are maybe in school today. And for them to get their hands on these test beds where they can actually play around with these kind of networks is what is going to seed future innovations. So thank you all for your opening remarks. What I'd like to do now is go through a list of questions, and I will, ask you to engage in some discussions about it. So the first one is about use cases. We heard that term very often, not only from you guys, but also in the previous panels. So what are some of the use cases that you think are uniquely suited to Open RAN? Are there certain splits and configurations, for example, that you would prefer to use in urban areas and hotspots? Are there performance trade-offs which make sense in some situations and not others? We heard the number that only 10% of networks will have O-RAN, will be O-RAN in 2025. Now, should that number be higher, or should that be more targeted to a specific applications that would benefit the most? So I'd like to start off with asking Charles Clancy about your thoughts on this topic.
Sure. So I think there's two types of classes of use cases to consider. One is potentially the deployment scenario use cases, where your motivations are are really more economically driven, right? How much it's going to cost to deploy a particular type of technology in a particular metro area, for example, and you may get cost or economic sort of efficiencies out of O-RAN as enabling technology. I think the other way to look at it is from an application perspective, right? What are the applications that are going to be the killer app for 5G that could be uniquely enabled by O-RAN and perhaps not by a more monolithic RAN architecture? So I'll get back to really, I think the radio intelligent controller, the RIC within 5G is within O-RAN is one of these key things that can enable applications better and faster perhaps than you get in a monolithic O-RAN RAN architecture. And so in particular, a use case I'm uniquely excited about is UAS. So as you think about commercial drone operations, you're doing optimization of everything. You've got to do route optimization of the drone in order to get it where it needs to go, achieve air traffic control functions, air safety functions, flight operations functions. But at the same time, a drone has a very unique propagation environment, right? It's at a higher altitude. And so it's able to see many G-Node Bs simultaneously. And as a result, it can cause uplink interference to a whole bunch of cell sites simultaneously if its RF resources aren't appropriately managed. So I think there's a really interesting RIC use case around joint optimization of drone flight paths that achieve all of the other metrics jointly with radio resources and being able to sort of manage your eigenspace effectively with, say, mid-band spectrum in order to ensure that the radio resources allocated to a drone from one cell site aren't interfering with, say, latency sensitive time slots that might be happening on another tower nearby. So I think those are some of the examples of use cases that uniquely benefit from O-RAN. And I'm sure there are others. You could also think about autonomous vehicles, although you don't have quite the same unique RF propagation environment. So again, I would encourage us to think both about the application layer that sits on top that can be uniquely enabled, in addition to maybe the deployment scenarios that could be done more efficiently with O-RAN.
That's fascinating. So when you're thinking about drones, are you thinking about them as clients or as base stations themselves?
So that's a great point, right? There's kind of two scenarios there. One is just your typical delivery drone that we imagine will be in our future one day, delivering our food and our packages. And in those scenarios, the drone is really just a UE that's connected to an urban 5G infrastructure. And there's all kinds of interesting problems to sort out with how you're going to do all the real-time machine-to-machine communication, all the edge cloud infrastructure, broader than just O-RAN. But you do also have sort of these, rather than a cell on wheels, you have a cell on wings, right? The airborne cows is a whole other interesting use case where you might be using millimeter wave backhaul for augmentation. And there the challenge is if I have a drone that's acting as a G-Node B that's in an advantaged position over a large region, then radio resource selection algorithms might have all my UEs simultaneously go connect to that drone just because it's got the strongest signal strength, which would then quickly overwhelm it. You'd have congestion issues. So again, I think the radio intelligent controller in O-RAN is a unique resource that you can use to do all of the RF resource planning in both scenarios.
Thanks, Charles. Laurie, do you have something to add in terms of use cases that you see are unique?
Sure, absolutely. I think as an operator, this is one of the most important topics and sometimes one of the most difficult ones for people to grab a hold of. So I thought it would be good to highlight a couple of specific examples. You know, we experience a need for a variety of radios for specific use cases. And today's day and age, we're often limited by what one or two suppliers have to offer. So that can slow down bringing new technology advancements to customers. I think an open architecture enables more players to fill the gaps to address deployment specific needs. So some examples include, for instance, the in-building space. You know, customers want 5G indoors, and we need to bring a variety of options to the space as the customer needs are varied. One solution doesn't necessarily fit all. So if you go into, you know, a customer's warehouse and you want to put a 5G radio there, that may not be what works in a hospital. So having more options and a variety of radio and baseband vendors from which to choose, it helps us customize our solutions for our customers and ultimately provide the correct solution with the best characteristics for that customer. Another example is when different form factors are needed to satisfy zoning or even physical space requirements. So again, what one or two vendors can provide may not suffice, and flexibility can be the key to gaining approvals to do the physical installations that we need to bring, service to our customers. So I think also, with new service offerings and agility within the space, it requires innovation within the RAN and ultimately reduced barriers to entry. When we achieve open front haul, X2 interoperability, and vRAN, which can lead to O-RAN, we give ourselves a path to evaluate these new services quickly. And that also allows us to introduce new services at scale. So again, one size doesn't fit all, and the ability to mix and match solutions to our needs are really going to help to push technology advancements. And ultimately, having the ability to disaggregate software from locked hardware is a necessity to see these use cases materialize.
So another question that has been on my mind is we hear a lot of talk about latency. And actually, at this point, I'm rather confused. Does O-RAN actually lower latency, or does it increase latency in terms of, because now you have so much more software and general purpose hardware in the stack rather than specialized hardware, which in general works to reduce latency. So what about applications that require low latency? Does anybody have a thought as to whether O-RAN is the right solution, or is that a use case where O-RAN would be useful?
Well, maybe I can try here. I think that in principle, at least from the front-end point of view, from the RAN side of things, O-RAN should not, Open RAN should not increase the latency. Now, in fact, it could actually decrease it somehow, because part of the functionality that right now exists in the BBUs in 4G is moved into the radio. Now, of course, the splits have to be designed correctly so that you don't increase, again, you don't create some other bottleneck, and I think that this is being reviewed and all of that in the O-RAN work groups, and certainly the 7.2 split I think that is efficient in that respect. It should be efficient. Now, again, as I mentioned earlier in my discussion, we have to be careful. What is it that we're trying to split here? So that if we, again, I'm going to go back to the earlier points I was saying, that if you insist in doing what people have been developing for 4G blindly and say, I'm going to be very stubborn and just want to go with all these millions and zillions of digital streams and the digitize like crazy just because I want to be digital, blindly like that, then you may get in trouble. And in fact, people are getting in trouble right now. And in terms of the amount of hardware that you need to put in the radio to do this, all these extra, calculations and the circuits and so on. On the other hand, if you do what we do, which is get a little bit more wise about it, then you realize that you can do the same or even better. In fact, you can do better if you simplify things. And, we're all engineers, or most of us here, and we know that the solutions that usually work in the real world are the simple solutions, not the complicated solutions. Simplicity always wins. And so that's the way we have to think. We have to rethink about, just don't take what exists out there and let's just automatically try to put it in the O-RAN. Okay, let's just rethink the system a little bit and be smart about it.
Okay, and that kind of ties into maybe a later discussion topic. What we can briefly touch on it here is, so as you said, if we are going to think about doing it intelligently, but it's also, it sort of brings together the O-RAN specification, which is now happening in the O-RAN Alliance, And you have the 3GPP organization, which is developing what was traditionally the radio access architecture. So where does this come in? Where does this kind of thought process find a home? In which standardization body? Does ORAN need to work much closer with 3GPP, or does 3GPP internalize the fact that their future Gs have to be built keeping in mind that we are looking at open interfaces? So thoughts on how the standardization process would work out, or where these very important issues get resolved.
So I can take a stab at that. And I think what's interesting about what's happening with ORAN is, yes, it's a standardization effort, open standards, open specifications, but it's also an open source implementation, right? And so that combination, it's not just standards, it's not just open source, it's sort of a standards-based open source initiative, and I think that's fairly unique. I think the other part that's fairly unique is that there is a software ecosystem within that alliance, and I am not directly involved in ORAN, so this is sort of a little bit, and someone looking out from the outside looking at this process, it seems like a fairly well-engineered software architecture. And so all of those things, so open source, open specifications, well thought out architecture that is also happens to be flexible and open, in my mind, puts us in a completely different space in terms of thinking about standardization, right? If you have a framework that is well engineered, well thought out, and so flexible that in fact you can add new things in that, then it really changes the way we think of standardization. And as you were saying earlier, Monisha, I mean, it might be that, now we think of this framework as becoming the standard rather than the next G becoming the standard. So I think there's real potential here for allowing us to think completely differently about standardization and what that means.
Does anybody else want to jump in there? James, go ahead.
Yeah, I just wanted to say, in general, for those of you who've been involved with 3GPP, that standardization body has been wildly successful. If you think about what that group has to do every quarter, all the different RAN working groups and pulling together all the requirements. So I'm a big fan, given the way that some of the political biases have creeped into some of the other technical standardization bodies. I think 3GPP has actually done a really good job there. And then in terms of ORAN, I think ORAN and 3GPP, at least at this particular point in time, they're actually complementary, in my opinion. The release 15 and release 16 of 3GPP really opened the door for this ORAN ecosystem to be created. And I think that the 3GPP members actually embraced this sort of natural evolution. And to give you an example, using your latency example, I mean, when in release 16, you have many slots and two-step ratch, which are techniques to lower the access time. And, those are more physical layer things. But, if you're communicating with a device that's thousands of miles away, well, the round trip latency is going to be a function of physics. And in an ORAN network, if it were to implement these techniques like mini slot and two-step ratch, just as two examples off the top of the head, then if the service for that was at an edge device or a RIC, then you can see that was located in a close geographic proximity, then you can see that latency would get the benefit of 3GPP and also the benefit of this Open RAN architecture. So I see them as two things. However, I'll do the I can't predict the future, but I do want to give props to 3GPP and what they've done. It's been a hard job, and I think they've done a good job.
Amit, you wanted to say something?
Yeah, I was going to agree with James as well. I think 3GPP has done a really good job so far. And if you look at it, 3GPP is not just defining the RAN, right? So 3GPP is defining what the handset is doing, what the core is doing, and what the RAN is doing. And the interface between the handsets and the RAN is an open interface. We are buying handsets from one vendor and RAN and code from other vendors for the last 30, for a very long time. So that's an open interface. It's working well. I think so far the interface between the RAN and the core networks has also been open and has worked very well. I think across the world in many networks, carriers are using on a market by market basis. They'll have RAN from one vendor and code from another vendor. I've been part of startups and other, where we have built RAN products that introduced the carriers and connected over the S1 interface or the IU interfaces that were defined by 3GPP. So that has worked well too. To an extent, the challenge over time has been how to do interoperability testing. And a lot of that work has been done normally. Either it has been done by the large vendors, or in many cases, the carriers have helped in getting that interoperability done. So on some of the previous products that I worked on, we had the support of some of the large carrier customers that we were working with to get all the RAN to core interoperability done. So I think what is happening in Open RAN right now is we are looking at just the RAN. If you look at the network, you have the handsets, the core network, and the RAN. And now there is an effort to see, okay, if we actually are willing to break the RAN into, in a way, smaller sized problems, whether it is RUs, DUs, the RIC, the centralized unit, if we can kind of decompose it, maybe it becomes easier for there to be more innovation, because otherwise we are dependent on just a few companies who have these things integrated. And that is what is creating new interfaces, which are not very well defined in 3GPP, because that's not what 3GPP was traditionally trying to do. So that is the space, and I think 3GPP is still doing work in terms of like defining the F1 interface between, say, CUs and DUs and other RAN interfaces, but still that has not been traditionally the area that 3GPP has focused on. And that is a gap, in my opinion, that the O-RAN Alliance is trying to address at this stage. In the past, there were other bodies like the Small Cell Forum, which defined the IUH interface, which was trying to do something similar, or the FAPI interface. So other attempts have been made in the past to try to see how we take the RAN, decomposing into smaller elements, allow more innovation to happen. And that's what you're seeing in O-RAN Alliance. And I think we have to be kind of careful. I think a lot of times we are intermingling when we use this open RAN umbrella. We mix up things like O-RAN Alliance, which is doing interfaces, other groups that are developing open source software, the Telecom Infrastructure Project, which is actually doing specific software implementations. So these are different things, but hopefully they all lead to more innovation and more progress in the RAN space. But I don't think this is an alternative to, say, the 3GPP standard setting process. Just my thoughts.
Ivan, you have your hand up. You're muted.
So I was gonna say that one sort of, I don't want to say a problem, but one issue is that the speed at which things are happening is quite different in terms of 3GPP and O-RAN Alliance. In the sense that one is driven by software community, which tends to do things at much faster turnaround times, even to a point where people don't really think through all the interfaces, but come up with implementation that sort of works, which then creates a problem later on, of course, but that's a separate issue. Whereas 3GPP tends to be way more thorough in terms of making sure that whatever interfaces they come up with are well thought through and satisfy certain performance requirements. Having said that, it doesn't necessarily mean that this cannot be harmonized in some way. And maybe we just sort of let the ORAN community run in these cycles of updates, frequent updates and frequent changes, whereas sort of 3GPP waits for a little bit to sort of see the stabilization of the whole thing and then declares it a standard. And it's not clear that all the standards are really needed to be done on 3GPP level. Maybe it can be done something like that.
Right.
Sort of,
So let's switch to a slightly different topic now. Mihai, did you have something to say?
Yeah, I just recall that actually my team that is following closely the ORAN activities and so on, they've often given the suggestion that, and this may be relevant to the government here, that if national labs were somehow to pick up on this issue of interoperability, and do some more studies and rigorous, independent sort of from all the interest of each vendor and so on and so forth, that may be an interesting idea. So I just wanted to share that concept with this panel. Again, it's more like what I hear from my guys as a suggestion anyway.
Yeah, and I think, the power test beds is one way of doing it, and there are others. I think in the previous panel, HP mentioned that they have a 5G Open Innovation Lab. So there are ways to do this. And actually that segues nicely into the next topic that I wanted to discuss in a little bit more depth was the use of AI and ML. So we heard a number of speakers among you as well as the previous panel as to how the Open RAN will enable the use of artificial intelligence to better control networks. But we also know at this stage that AI is also not a cure-all. It has its pitfalls, it has its biases. And so how do we as a community ensure that things like, we talk about the digital divide. How do we know that the AI doesn't configure a network so that people who are already underserved are even worse off than before, right? Because now you have so many more touch points within the network to actually decide who gets service and who doesn't. In the past, the FCC looked at people getting service based on the signal strength they were receiving. But now today, signal strength is not a good proxy for whether you're actually getting service. It's all of the intelligence that goes behind the network, which gives you the resource blocks you need or provisions the network. So what are your thoughts on how we can make sure that as AI rolls out in Open RAN, that the checks and balances are in place to prevent these kind of things from happening? Manu, you want to take it?
Sure. Thanks a lot. So yeah, I think with especially AI or any model is only as good as the data that is available to it. So clean data sets and essentially this is also, again, talking about adjacent technologies. This is not necessarily a telecom or an Open RAN issue. AI has its tentacles in pretty much everything we're doing. So these issues of clean data, unbiased, what topologies should be built constrained, I think this is much more beyond what we are looking at. But just to bring it back into the realm of Open RAN, specifically the idea of developing the data sets for training and inference. So now this comes back to offline learning and online learning. And I think the consensus, somewhat at least in the specifications, if I'm not mistaken, work group 4, they are looking at some level of offline training initially, sucking all the data from all these disparate disaggregated elements, and then essentially running it into the models they're building to see what comes out. An interesting analogy is, yes, your question of the bias that may be introduced, it actually may go the other way. So if you've seen a very simple science experiment of how do you think you build momentum on a swing set, and when a robot was trained to do that, it actually started to pump its legs on the way back. which is complete opposite of what the human in the loop would have done to essentially do a task. So to come back to the point, the objective is going to be defined by the operator, and I think thinking in ML AI terms, we have to meet that particular objective. And in the AI, in the Open RAN world, that's going to happen at the RIC. And again, the RIC has also been broken down, and this ties into your earlier comment around latency. They've disaggregated the RIC even in meeting some latency bounds, so sub 10 milliseconds, sub millisecond, 500 milliseconds and above. So non-real time, near real time, and real time sort of RIC would be something where we clearly see. But just to recap, summarize, data, clean data sets, and then essentially building models, and one day also thinking out into the future, we might even not need any manual algorithms, because the AI RAN would probably be optimizing the different touch points itself.
So if I can maybe quickly latch onto that, and I think the data sets, as Manu said, is really important. I think in terms of verification, I think making data sets available to the research community will be pretty important. And then just another maybe smaller comment. To the extent that machine learning and AI is sort of involved in everything that we do, there is a tendency to think, well, it's going to do these bad things. But I think Manu again said that very clearly at the beginning. It's not as if there's one AI program that's just going to run the network. At least, let me say, not in the foreseeable future. And so there are objectives that are being applied to these models. And these are typically much, much smaller things that might be, optimizing energy and performance at the same time. So things that are really hard, but it's not as if you're saying, hey, here's the network, go run it, right? And so I do think it gets broken down into smaller pieces where, at least for the moment, there are very clear objectives that are being applied to the models that are being trained.
So if I may pick up on the question of data, and we have Laurie from Verizon here. So even today, the carriers they own the data of whatever goes through their G-Node Bs and E-Node Bs, right? Now, when you're talking about disaggregated RAN, you have a lot more data, but presumably all that data will still be owned by the carrier running the network. So when you talk about now having data available to the academic community or researchers, how do the carriers look at making training data or test data available to the broader community to help make sense of what's going on in your open architecture?
Yeah, so I can take a stab at that, being the operator representative on the panel. We encourage data sharing on test beds and anything with the academic community. We're largely engaged in it. I think where we have to be careful is when we're sharing data on a live network. So, Verizon has been expressly against that. We're very protective of our customer data. We don't share that, but we're very engaged in test beds. And we encourage that because you learn when you're on a live network more so than, on any other types. But we've been able to do that in closed atmospheres so that it's not impactful to our customers, but that we can provide that level of data and the interaction between elements that's needed to provide those test beds.
Ivan, you had your hand up.
Yes.
And then Ashutosh.
Yeah, so I guess there is additional issue here as well, which is if we are monitoring and we have all the at least power test beds have capabilities of really observing quite large swaths of spectrum, and therefore we can generate a lot of data, record it, and so then the issue becomes who and how can have access to that data, and whether we can sanitize that enough to make it generally available to the whole research community, or whether we have to, as a community, have some sort of a, I don't know, repository of data where you have to be vetted first before you are given access to certain levels. And so that's a very interesting topic that we, as both academic and non-academic community, should address sooner or later. And you know, again, the ultimate goal would be to come up with something like famous JPEG picture of the lady, right, Eliza, whatever her name was, right, where we can then sort of at least use that as a baseline for evaluation of whatever we are trying to play with, whether it's Open RAN or not, right? This is a general issue.
Thanks. Ashutosh?
Yes, Manisha. So I wanted to say a few things. You know, what Ivan and I, we also part of the IEEE Future Network Initiative, where we are studying the applicability of AI ML for various use cases. Again, security being my topic, we have also been looking how we can take advantage of AI ML to do predictive security, right? That means before even the attack happens, based on the data set that you have, based on the behavioral pattern, past traffic, how can you detect that attack is going to happen and proactively prevent the attack altogether? In fact, within the Future Network Initiative, we have a security expert group. We are developing some use cases around that and working with Ivan, who is the co-chair for TestBed, try to see how we can do some proof of concept based on some AI algorithm. Maybe some of the NSF testbed, we can try that. So I just wanted to allude to that fact.
Thanks, Ashutosh. Charles?
Sure. So I wanted to, I guess, note that I'm not particularly concerned about some sort of bias in AI resource allocation really happening in a realistic environment. I think if you think about a 5G network, it's sort of already stratified into network slices that have different QoS requirements associated with them, right? So you might have some real-time latency-sensitive network slices for ultra-reliable low-latency communication. You might have some best-effort network slices for general broadband mobile consumption. But you really have sort of SLAs and QoS profiles defined for those network slices already. And then it's really up to the RIC, Radio Intelligent Controller, to figure out how to deploy resources in the RAN in order to meet those SLA requirements. And really that's an optimization process. So I would suspect that near term, a lot of the AI that's going to be applied is really just sort of sophisticated optimization algorithms that are really no different than the way the radio resource management functions work in today's eNodeBs. Right? It's just now on a disaggregated gNodeB, you're able to do optimization across sites in a more efficient way. I think, yeah, down the road, we may get to the point where there's some black box deep learning that's being used to do resource allocation, potentially. But again, I think we will have built up to that over time, and we'll have a lot of sort of less sophisticated, more QoS-driven models that we'll be starting from and using to validate along the way. So again, my point is we're not just going to hand over the entire radio access network to deep learning tomorrow as part of ORAN deployment.
Well, I mean, so in one of the previous panels, there was this notion about these network interfaces becoming like APIs on your phone. And while that sounds like a great way to go, it also opens up, and this sort of segues into the next topic, which is security. So when we're talking about opening up these internals of the radio access network in as easy a way as an application programming interface that's visible to programmers outside, right? As security experts, what do you think of that? Do you think that that is enhancing the security of ORAN, or is, in certain cases, could that opening up new threat models that we haven't really considered in the way we design a 5G network? I think, Cheryl, you had some thoughts on security in ORAN. Maybe you could chime in there a bit.
Sure. So what I wanted to just take the opportunity to share is just some of our perspectives on security, kind of pulling from our communications and cloud background. And so when we look at 5G and offering it via cloud, right, beyond some of the foundational security measures that are already built into 5G, we really look at the IT and cloud-based design as offering defenders those new opportunities to be able to shift the cybersecurity advantage away from malicious actors and to the defenders. And so, kind of taking a step back as a cloud provider, right, we can leverage the scale, we can concentrate all of our resources, our engineering and expertise on securing that cloud. And what we see then is services that are then running on that cloud environment, like 5G, can then, they have the opportunity to leverage those securities. And so, we look at 5G then inheriting the cloud scale, reliability, security, and allowing those capabilities to be rapidly deployed, scaled, segmented with the tailored security measures. And so, things like virtualization, the cloud native approaches, containers, network slicing, as we've discussed, encryption, identity management, access control, these are all things that can be brought to bear to secure and then to the and tailored to meet whatever the application is, certainly. But to the conversation we just had about AI and ML, right? We see this as critical to the path forward in security, not just for the core, but also for securing the RAN. And so what we've been able to do is really have these AI-powered autonomous systems, right? So leveraging what we can see, all of the data that we have, as to how things are running in our cloud, and then applying that to security, right, to autonomously prevent and detect and respond to the predicted sophisticated threats at machine speed. And also, take that burden away from the cybersecurity workforce, so the people who would, have before been going through the logs and whatnot, and giving that job to machines so that workforce can actually be put towards those more strategic tasks. And so, as we're looking forward and the security landscape is changing and how we're accessing this, like really, kind of web-based system, our view is that the cloud, it can be a little daunting, certainly, but we view the cloud as a real opportunity, and the technologies that we've been discussing to really provide some enhanced security for an open and interoperable and standards-based 5G deployment.
Go ahead, Ashutosh.
Yes, no, this is an important topic. In fact, when you look at the evolution of the generation of networks, right, the threat taxonomy or the threat model keeps on changing, as I was telling in my initial talk. So you really have to look at end-to-end, open up the interface, look at the potential points of attacks can happen, then build a threat taxonomy, and look at the additional security pillars. I think some of them were mentioned: orchestration, slicing, edge cloud. So these are benefits. You can take advantage of that. If you're having a jamming attack, you can probably do some kind of a dynamic radio resource scheduling. You can use SDN NFV scale up, provide elasticity. You can really have security monitoring at different interfaces like data plane, control plane, to see where the potential source of attack, where it's coming from, right? So if you have all the security controls properly in place, you really should be able to take advantage of the ORAN features, but at the same time protect your assets from the attacks, either from the subscriber side or from the internet side. So security should not be an afterthought. As you design your network, as you map your application with specific parts of the network, let's say for ultra low latency, you need edge cloud. If you really want to have edge security detection, you need to put them in the edge. So do that mapping and then find out what kind of security controls you have, what else you need. I mean, I'll just give an example. You are working very closely with Department of Homeland Security right now, and they like to really take advantage of 5G enablers that we have today. We're taking a stepwise approach. We're actually working very closely with this power test bed. Many of them are present today as panelists. So we're looking at the requirement. We're looking at the KPIs with the latency. And Manisha, if you remember, we thought about key security indicator, like not KPI, key security indicator, KSI, right? So what are the potential risks? What is the probability of attack, the threat factor? Once you determine that, then you see the granularity of attacks, whether you want to put more security control at one network asset versus another network asset, right? So this really need a, I think Charles used to call it threat model. So we need a threat taxonomy and try to figure out the opportunities the challenges, additional challenges, and then come up with potential mitigation technique, and then work with the testbed like Power and do a proof of concept, apply different use cases. And things do not work, go back to standards, go back to 3GPP, IEEE, ITF, ITU, and try to change. I know HCNFP started the security expert group, right? So this is how it has to be an iterative process, and it has to be all driven by application, use case requirement, and flow down.
So Charles or Cobus, any of you, can you point to any new security threats that you think might arise as a result of the disaggregation of the RAN?
So I think one, if we think of one of the key primitives that 5G provides is the aspect of slicing, right? And so slicing is about isolation. And now we're saying, well, wait a second, we're going to have this thing that is going to have a cross-slice view. And oh, by the way, we're exposing a bunch of interfaces here, and we're going to run applications on top of that, right? So I think for me that's, and it might be a small one, but that's an example of, wait, this is something completely new, because we've had these isolated slices. Now we, because of the benefits, introduce an entity that has a view across those slices, and we're going to have applications running on top of that. And so I think I can generalize that to say, I think the largest unknown here is because it's a much more complex environment. We don't really know, and this is Ashutosh said the same thing, right? We have to work through those. We have to work through use cases. We have to figure out the threat model or threat taxonomy. But we have an inherently complex system, which we're now opening up by a bunch of open interfaces. So at the very least, we have to acknowledge that we are we're making our attack surface much larger than it used to be. And we have to think carefully about what that means and what new attacks that might enable.
And I would say that I think this gets to what the actual scale of the business models of 5G end up being, right? There's two very different scenarios here. There's one scenario where a 5G network basically is running 3 network slices, an enhanceable broadband slice, an ultra reliable low latency communication slice, and a massive machine type communication slice. Each one has a default sort of set of QoS requirements associated with it. And it's really kind of carrier centric in the way that they're operated and monetized. And then, okay, you've got 3 different apps that are plugging into your RIC that are expressing the QoS requirements around those 3 slices. That's all really contained within the carrier ecosystem. And so the carrier can be responsible for the security and robustness of all of that. It's not really open in the sense that just the iPhone app ecosystem is open. The other scenario says, well, every single enterprise network is going to have their own network slice. Every single different sort of industrial IoT vertical is going to have its own network slice. And our carriers are going to be running, I don't know, 200 network slices or 1,000 network slices, in which case this is a much, much more complex problem. It's not clear to me the sort of timeline of how we get from 3 network slices to hundreds of network slices, but I think there's will be plenty of time along the way to sort of see how all of this changes over time and really build up sort of incrementally the trust in how we would vet these apps that might be running on top of the RIC. I just don't see hundreds of them by 100 different third-party vendors all showing up initially, right? I think initially it's all going to be more carrier-centric.
But as somebody said, we didn't know about Uber when 4G got standardized and implemented, and we don't know what's waiting for us around the bend once 5G gets deployed. So changing topics now a little bit into testing, there was a comment in an earlier panel that testing and integration of Open RAN is not really that much different from the kind of integration that happens in networks today. We do that all the time. We are testing, we're putting together things from different vendors, and we have to do interoperability. my personal opinion is the Open RAN scales that problem up a lot more. So when we talk about testing, I know the ORAN Alliance has testing subgroups, but who at the end of the day, is it the carrier that is responsible for making sure that all of these interfaces are tested, work well? Is there a third party that aggregates the network together, who's responsible for making sure it all works? There is also a question about performance versus ORAN trade-offs. I've heard in other contexts that, it is really hard to come to the same performance as our current networks as URAN. And I've heard the opposite too, that no, ORAN can beat, and we've heard about how spectral efficiencies increase with ORAN. So how do you put all of these varying demands on the network in terms of testing together, and who does it, and where does it get done, and what are the research challenges towards doing it? Yvonne, you have your hand up, so why don't you go ahead?
Yeah, so I just want to draw on the previous or on the experiences that we are currently having, and both, as I said, both Powder and Cosmos are OTIC, meaning we are hosting these POCs where the people come in. So I think there are actually two issues here, right? One is sort of having the environment where players can play with the stuff or show that things are working, and then somewhat a different issue as to who can certify that things are what they are promising they are. And I'm not saying that one place cannot do both things, but certainly there are different objectives, and therefore probably it shouldn't be a single place, right, where these two things are happening. Then the second aspect of the whole problem is the fact that we are talking about really a fairly non-trivial number of different environments where, especially including verticals and things that we are not necessarily used to, being viewed as a target for various components in this system. And so then this idea of having a single place where you're going to verify that everything is working according to plan is probably not feasible at all, unless you're talking about some very sophisticated environment where you can, meaning something that sort of extends beyond a single physical environment, right? And given that we are pushing performance really further and further away from what technology can actually deliver these days, chances are that that's not necessarily the ORAN type of thing. And that's something that you touched on, where people are saying, oh no, in this particular case, fixed function radios are way better in terms of performance than fully programmable software-based constructs, right? And so therefore, I mean, there are this whole range of things that we need to be testing, and arguably whole range of environments that it needs to be tested, and therefore whole range of test beds that need to be available for people to test things in. Completely independent issue becomes then who certifies that your VNF is really based on 3GPP specification A and LoRaWAN specification B or interface B, and it's working well with somebody else's core network or any other component. And actually the number of components and the number of combinations we can actually play with makes this a somewhat non-trivial integration problem.
Laurie, you want to go next?
Sure, I was just about to piggyback on what you said, Monisha. I think it's the whole ORAN community's responsibility, not just the carrier, the vendor, or the manufacturer. You know, testing challenges, they can be a threat when it comes to Open RAN. And from experience of testing on wide scales, sometimes it's difficult to identify the piece of hardware or software operating out of spec when there's so many different multiple vendors that are being represented and evaluated. That doesn't mean that it can't be accomplished. It just adds a different level of evaluation that needs to be done. And it's a layer of complexity that can be resolved by eliminating proprietary interfaces and standardizing with mature technology.
Thanks. James?
Yeah, I was just going to say, just make 2 points and piggybacking on what Yvonne said earlier. all of the components in the system have to perform to 3GP specifications, whether they're ORAN or not. And so that's a given, and that ensures a minimum level of QoS and compliance to FCC regulations and other standardization bodies. So ORAN doesn't alleviate that onus. And then just as a general point, Laurie's point earlier about the ORAN community having to self-police itself, and I think that the ORAN community does believe that we have to do that. And at some point, these interfaces, it's just going to be accepted that they work, and the testing will be light. But I don't think in this time frame, the early time frame, that it is going to be a little bit of, it is going to be a challenge to ensure interoperability. But we all have a vision, I believe, of getting there.
Manu.
Sure. So I think there is, the time's not, near, and not to put words in Laurie's mouth, but anywhere near a production operator environment, a test ORAN element is going to be assimilated. The way the big four data center hyperscale networking operations work is real-time debugging, fixing, feature addition happens in a live operational network. That paradigm is something that needs to be maybe rethought. I do still agree that there is some sort of a separate entity, either the ORAN Alliance itself through the OTIC program, or someone else that sort of does take the burden or shoulder the burden of doing a lot of the interop activities. And then we, I believe as a community, and most likely the operators have to drive this, have to think of what's the pathway from somebody who's working in academia, who then is entrepreneurial in nature, comes together to a startup, comes to a forum such as ORAN, validates what they have done, meets all the performance QoS and metrics and KPIs put forth by 3GPP and ORAN, and then what's the onboarding model? Right now, each operator has their own self-defined one, and it works well for what their metrics and objectives are. But I do think there is a place for an entity, a testing entity, either spread across, and maybe it can also be topical, but something where the operators have the front row seat into observing what's happening and mirroring what's happening in their own production networks to see what might make that jump or make that shift.
Amit, go ahead.
Yeah, Manish, I wanted to make 2 points here. I think first is that we talk a lot about interoperability, but I think it's more than that. It's about continuous integration because features do change. So we can get initial interoperability, but 6 months later, there is a new feature that a customer wants to introduce. And often that feature may affect the handset, the RAN, the core network, the billing system, OSS. And you basically have to figure out how it all gets integrated before it can be rolled out in the network. So I think that's a topic I don't have a solution to offer on this call, but I think as an industry, we have to think through how we are integrating and rolling out new capabilities on a regular basis. I do think doing that does require a lot of technical expertise, whether it's at whoever is doing the system integration, whether it's a third party or whether it's a carrier. You do require a fair amount of technical expertise to pull that off. And I think that's going to be a big challenge for smaller carriers. I think one of the comments that was made early on was that, just early on in today's forum, was that perhaps smaller carriers or rural carriers who have Chinese equipment should look at, using ORAN equipment. And I was thinking, I've worked with rural carriers in the past where the entire network department would be one person, and this person would mainly just have like a CCIE certification that he can operate Cisco equipment. And that's would be about it. He would be like an IT person. And now if we go to this person and say, we have got this, make this ORAN equipment, all this ORAN stuff work, it would actually not work out. So I almost feel that a lot of the open architectures that we're talking about actually lead to more consolidation in the industry. The example Manu gave about like hyperscalers doing all this continuous integration. Actually, what we have seen is in the data center industry is that now you only have 4 big companies who can run 4 or 5 large companies who can run data centers in that fashion, and everybody else is out. So either you use a cloud from one of these folks, or you are not really in the business anymore. So I think we just have to also think about, as we're moving in this direction, what is the implication for smaller carriers in the market? And of course, as a lot of people have mentioned, what does it mean for the big carriers themselves in terms of how they are transforming themselves to benefit from this technology direction? But I think those are things to just consider.
Thanks, Amit. Ashutosh, did you have something to add there?
Very quickly, I just wanted to make people aware that there are different kinds of testing, right? We have conformance testing, specification testing. Then you have another thing where you have a specific use case or application, and you want to make sure the KPIs are properly met or not, right? If you're doing an ultra low latency application, you probably need the functionality of Edge Cloud, right? If you're just sending lots of bandwidth and file transfer, you may not need that. So I get that mapping is important when you try to do some testing. I know we have been doing a lot of stuff in the power testbed, some of the DHS fast responder use cases. At the same time, within IEEE, and Ivan and I, we are developing some testing procedure as part of the Future Network Initiative roadmap technology. So I think there are different kinds of testing you're talking about here.
Right. And the question in my mind also is that, with all this disaggregation, we hope that networks do not become more difficult to maintain and upgrade, right? But I heard a couple of statements towards the thing that, when you add a new piece in, what does that do to the network? So what are your thoughts on, does this disaggregation actually make the network easier to maintain, or does it make it harder to maintain? Or is it somewhere in the middle? How do upgrades get rolled out? How do you test them once they get rolled out? Because face it, as soon as you move to a software world, you're talking about constantly living in a beta version, right? We're used to software that is always released without being fully tested. And so there has to be a way to think about how you do this network upgrade and maintenance in real time in an ongoing fashion. Who wants to take that?
I can give a shot at it.
Okay.
I think that one of the things, and Spirent isn't the only company looking at this, but if you look at the network, instead of doing end-to-end testing, there will be nodal testing on different aspects of the network. And then there are devices that you can hang off the network that also will be able to test any particular upgrades. So I think it's evolutions to existing test equipment that's out there. But as long as the test equipment has these interfaces, then they can test the individual elements that are being rolled out in a controlled fashion. And then the test and measurement solutions can scale to end-to-end and even down to the device itself. So that sort of mitigates the transition costs for these particular upgrades. So you can look at individual pieces, test individual pieces of the network, even if it's deployed, and then the solutions scale as you roll out any particular additional service or feature.
Anyone else have any thoughts to add to that? Sharon. I see your hand is up.
I was just going to add, from a software perspective, kind of going back to some of the comments I made about AI and ML, right? I think that there's a real opportunity that, as you're disaggregating and putting everything into software, once you're able to get your AI and ML, your autonomous systems up and running, the opportunity, just as we do in our cloud, is to, once a vulnerability is identified and the patch is ready, you can, number one, you can identify, when things are going wrong, but then autonomously patch in real time. And that's something that, we think is just absolutely critical whenever you're up against kind of the threats and the speed of the threats that are coming. And so, an opportunity as this matures and as we move to this disaggregation to port some of those techniques into this space.
So we have just a few minutes left, and what I'd like you guys to do is just, I'll go in reverse alphabetical order and ask you each for, one research challenge that keeps you up at night. What do you think this community should be looking at? And Cobus, you're up first.
So I just want to say I really like reverse alphabetical. For me, research challenges don't keep me up at night. Those are the things that actually make me sleep at night. But I think, just to try to answer your question a little bit more meaningfully, I really think the whole idea of Open RAN and all aspects of it is really interesting from a research perspective. I do come back to the complexity of the system as a whole, the implications of that specifically with result to or in connection with security. And I'll go back to saying I think the way we need to get there is through experimental evaluation and use cases. So no, I'm not staying up at night. I'm very excited about it.
Great. Hope you get a really good night's sleep tonight after this forum.
Yeah.
Ivan.
Yeah, so I was going to say complexity if I was first.
Okay.
I just took that one.
You can repeat a previous.
No, I'm going to go to the next one down the list, right? Which is sort of what we can learn from the agile development community and continuous integration, and can we actually come up with some sort of a resilient deployment, continuous deployment, where we do partial deployment and avoid stuff like complete collapse of networks, which of course happens to all the big software vendors in this universe. So I don't know. Can we live for a few hours outage of a cellular system? I don't think so. But nevertheless, maybe we can learn something.
Thanks. James?
There's nothing that really, I can't point to one item or one thing that keeps me up at night, but I do think there is a need for a little bit of patience, because right now SA networks are just now starting to be deployed, and I think you'll see the benefits of network slicing as well as Open RAN. At least initially, some of these early deployments are really sort of enhancing the enhanced mobile broadband case. But as we move forward in the short term, I think that once these networks are deployed with these interfaces, I think that it will create significant economic opportunity. I just don't think that we're there yet.
Right. Amit.
Well, I'm part of a new company, and we are completely focused on building this millimeter wave RAN product, and really focused on the economics, because I feel that radio access networks are access networks, and the most important thing is the economics, the cost per gigabyte in which we can deliver service. And if that works, the other things can, it will create a lot of opportunities. So that's what keeps me throughout the day and late at night.
Manu, I think, one of the last things you mentioned, the cost per bit has not been a research metric that the academic community has focused on much, but hopefully the NSF powered and last rural broadband platform is one that will set that right. So Manu, I'll throw it to you.
Yeah, so just really quickly, I would say one is incentivizing and attracting the academic community. If you look at all these forums and alliances that are out there, I encourage you and urge you to look at the membership roster and try to identify a single US academic institution that's there. You'll be hard pressed to find one.
Yep.
So this is something I believe for the policymakers and federal agency sponsors, something to think about or to consider. The second is availability, and that might be tied to availability of software. The dearth of truly open source code that's available for an average graduate student, PhD, postdoc to really absorb. And I understand the complexities, but even for a single deep dive in a singular element, some of that basic hardware and software infrastructure, which we in the Power ecosystem are really trying to put effort into building up a repository where really code is available unencumbered through some of the other IPR issues that we haven't discussed here, would be really important to bring to the fore. And then all of this ties into training and workforce. All these companies that are out there need to hire the students coming out of the academic institutions. And if they aren't ready, the pipeline is not being built as you're deploying Open RAN, and you're going to start thinking about that 2, 3, 5 years down the line. I just want to make sure that we emphasize that and we build this continuous pipeline. But again, absolutely. I didn't mean to sound ominous. We're very excited. This is a great time for Open RAN research.
Laurie.
So I'm lucky, like my peers, James and Cobus, that this is not what keeps me up at night. But one of the things to keep in mind is that this isn't a one-size-fits-all network architecture. Mm-hmm. And I think that the research will help us, bring us together from an implementation and from a standards perspective. So, 5G is really interesting. It's different from 3G and 4G in that, each company is focusing on what they consider to be strategically important. And that could be very different. And I think the more that we get research out there and testing and standards, it's going to help us to bring us together for one common goal, which is to escalate ORAN, to bring it to fruition, and to make sure that there's an importance that it plays in the ecosystem.
Thanks, Laurie. Ashutosh?
Yes, I'll break it into two different things. One is what keeps me up at night. Second thing is what keeps me motivated, right? So if things start getting deployed, systems optimization, testbed experimentation, on top of security, how to make it secure at the same time, provide the right services. So those are the important things which kind of keep me up at night. But the things that keep me motivated, I think important, understanding the use cases of different verticals. For 5G has lots of opportunities. We really need to understand each vertical and map it to the 5G enablers that can be used to provide that. And last but not the least, I think many of the panelists said, the collaboration among researchers, regulators, operators, vendors, build a proof of concept, try it in a test bed, go back to standards, and do an iterative process. I think that is very important.
Absolutely. Cheryl.
So again, maybe not something that keeps me up at night, but just looking at the opportunity space, and we like to focus on the what and on the applications. And I think the Uber and 4G example is great, but with 5G being not just an evolution of 4G, but kind of a revolution. The art of the possible is just almost unlimited at this point. And so I think kind of dreaming of what it is you want to be able to do with these, particularly within private networks, and then testing it out and not letting the policy restrict the art of the possible, and putting this hypothetical into real, and figuring out the ins and outs of what we need to do. I think that's a great way to push this innovation. I think looking at what the Department of Defense is doing with its 5G pilots, that's a great model. You decide what the use case is going to be, test it out, and then figure out what are the gaps where we need to go. And industry will all be there to innovate right alongside them. So thank you.
Thank you, Cheryl. Charles?
I guess I'll just highlight the the scale of evolution that we'll see here. So what I mean by that is code that a PhD student is running on one of these test beds supporting 3 users that runs just long enough to do the data collection before it crashes is very different than code that will run on 100,000 cell towers supporting 100 million users. And so these features are not all going to be available overnight. It's going to be incremental, and it's going to be really exciting to see, I think, this roll out in a few waves over the coming years.
Thanks. And last but not least, Mihai.
I had the honor to start this and now to end it. I guess the discussion that we had last on the integration challenges and how we're going to make sure that different parts, provided by different vendors fit together and the whole thing, that I think it's a real serious problem. Now, it doesn't keep me sleep at night. My wife says that I always go to sleep first and then I snore. So anyway, but that is a serious problem that we need to think hard about it. On the other hand, I think that James was the one who mentioned that the economic forces, once this becomes a real opportunity in the market, and I think that as we go, it will, then either the current company like Spirent or Keysight or so on will evolve into providing these services, or maybe, putting my hat of an entrepreneur here, is maybe there'll be some startups that will become the experts in that. And in fact, that sounds to me like a pretty interesting, possibility there. We'll pick on that and do it. But that is a gap that needs to be filled one way or the other. However, I do have the confidence that it will evolve because of the economic forces here and the opportunities for making money, I suppose. So with this, I'll go back to you.
Thank you all for your insights and your expert opinions. This has been a great day. I don't know about you guys, but I think I learned a lot from each of the panels and from all of you. We are at a really exciting time just changing completely the way mobile architectures get deployed. We didn't have time to touch on one of my pet topics, actually, which is we always tend to think of cellular and Wi-Fi as these two systems that don't talk to each other. And I think O-RAN can also be brought in to do better spectrum sharing of licensed and unlicensed and spectrum sharing in general. But those are research topics that will continue to evolve within the academic as well as the industry community. And with that, thank you all again very much. Thanks to the audience that were tuned in. That's it. And so I'm happy to close this event at this point. Thank you all. Thank you.
Thank you.
Thank you.
Bye.
Thank you. Bye-bye.